Hi everyone, welcome. Very warm welcome to our AECtech Symposium. Very pleased to introduce all of the speakers today. We're going to have our 10th AECtech event happening now. I'm Jeroen Janssen. I'll be moderating the day, introducing the speakers, managing the questions at some point as well. Few introduction slides. So we got some AIA credits available for the whole day. So those of you who have registered, that'll be added, I think, automatically in the background. They'll take care of it. So you'll see a few of those slides to take care of that. So one is this official credit, another one on the copyrights, and you'll see when we introduce the presenters, there will be a little course description and learning objectives. Not too much to worry about, they'll be there. So briefly, the agenda of today, we split it into kind of roughly 4 blocks. So we'll have some speakers now in the morning with a roundtable of questions. So what we'll do is we'll have about 20-minute presentations with a bit of padding of 5 minutes to switch to the next one. And then at the end of that, so we'll have 4 presentations. We'll have a block of 20-25 minutes of questions of a panel here. So please keep your questions to that point, and then we'll have hopefully a lively discussion. Second up then after the coffee break is a roundtable. So we'll look at machine learning and practice. Lunch, of course, and then again that block repeats of a set of speakers and then another roundtable. And then Robert Tani will do a few closing remarks. I think that's it from the organizational part of view. From now on, I'd like to introduce Sanne, who is our first presenter. So Sanne van den Burgh from MVRDV next. She will be presenting virtually. She couldn't make it, unfortunately, in person here. But we're going to learn about MVRDV next, what they're doing within their architectural practice as MVRDV, but also really diving into the data, making that understandable, and how can that be used and made legible in a way. As I said, you'll see these slides coming up kind of the whole day. A bit of description of very generic presentation and some general learning objectives, all in the flavor of our computational community here today. But with that, I'd like to hand it over to Sanne and give the room to her.
Thanks so much, Jeroen, for the introduction. And hello, everyone. I'm very excited to be talking to you today. And as Jeroen already mentioned, I'll be talking about the work of MVRDV and also MVRDV Next, the new experimental technologies group that I'm heading inside the office. So the title of my talk, Research by Design, Design by Research, is of course a classic. And what I'll be talking about and showing you is some examples of how our projects inform the tools we make, and how our tools then again, vice versa, inform the projects we make, and how that forms a closed loop into a constant exploration that we do in the office. You might know MVRDV from projects like the Market Hall in Rotterdam, which is an example of something typical Dutch, double, triple land use, combining a lot of different functions together. You might also know us from the Public Art Depot, Boijmans van Beuningen, which is a new typology combining a museum and an art storage together in one building. And recently, we've opened our first project in New York, which is the Radio Hotel in Washington Heights, that we're very happy with and very proud of, to have a local presence in New York as well. Our main design office is in Rotterdam, the Netherlands, and this is what our office looks like. I'm also talking to you from the very same office. This is where all of our design work happens, but we also have offices in Berlin, Paris, Shanghai, and since recently, New York as well. And if you think of the work of MVRDV as infrastructure, mixed use, residential, offices, leisure, urban design, interiors, then you might think of the work of MVRDV Next as everything that's happening under the hood to make our projects possible. With this group, we do evaluation, simulation, datascaping, fabrication, and we develop and implement computational tools and workflows. The MVRDV Next group was founded 5 years ago as an internal startup, and by now we're a group of about 10 specialists that work in a project integrated way. We're specialized in computational workflows, but also in sustainability. And with that group, we also do our own independent research. We have a collaboration with the Delft University of Technology. And together with Delft University, we also have a think tank called the Y Factory. And with the Y Factory, we research the future. We look into the future of residential, of leisure, green cities, visionary cities. And we do that not only because it's very fun and inspiring, but we also do it because it's incredibly needed. We all know the IPCC reports and the Club of Rome, and we also have a shared responsibility as designers and architects to shape our world around us in a responsible way. And ever since the 90s, MVRDV has been working on and developing visionary tools. And this already began with tools like Spacefinder and Region Maker that look into exploration of the world around us and capacity mapping. And I will also be showing you some other tools today. And the main question that we always ask ourselves is that we think architects should not be the users of tools, but actually the makers of the tools that we use to shape our world. And again, indeed, we do this to address the global urgencies that we have, because as we know, we're actually still increasing in population and we're rapidly exhausting our planet. So that's the overarching theme of our work, is how to build and design responsibly, because we know that urban sprawl causes traffic and emissions, and urban density can be anonymous and stressful. So how to respond to that? And can we find ways to densify inside the city responsibly? This is an ongoing theme in our work, and this is a project that you see. It's the World Expo in Hanover, and here we looked into densification and stacking of landscapes. And can we imagine to actually apply principles like these in residential? And can we imagine that we all might want to live in a villa in the countryside, but is there a way that we can imagine densifying that and stacking that? This is a research project we've done with the Delft University of Technology, and this is the WeGo hotel, and this is actually our dream. Everyone has their own villa with a garden, and what happens if we actually stack that all together inside one envelope and densify it? Together with a group of students, we built a software that enabled us to play a game where each student was representing a specific user with specific interests, and by gaming with each other and negotiating over the space, the students together in a game environment built this final WeGo slab, a place that is collective and individual all together. And we were also able to build a prototype of this as an inspiration for the way we can negotiate with each other to see if we can all achieve our common goals. This is the vertical village. This is actually an expansion of the project you've just seen. That's all about, again, negotiation for space. And this is a next step in exploring how we can design and build together in a virtual environment. And this is the Village Maker. Imagine that we don't need architects anymore, and we can all design our own house in a software. We developed the House Maker, and with the House Maker, you can design your own dream house based on your family and your budget and your wishes. Then the next step is who needs a master plan? We developed another game, in this case, the Village Maker. And the Village Maker enables you to load your house from the House Maker into a hypothetical envelope. And you become the mayor of this envelope. You can set the rules for all the homes that appear in this envelope. So for example, would you like to have 2 hours of sunlight in every home? Would you like to have the single daylight village, or maybe the EU regulation village? So depending on the rules you set for the population of this envelope, you get different outcomes. And as you see here, the possibilities are endless in a seemingly wild configuration of homes that all have their own space to exist. And what could that look like? What you see here is a wonderful world of gardens, stairs, villas, textures. You can walk your dog inside this village in a constantly evolving structure. We take it one step further. Let's look at the high-rise version of this. And I'm going to show you porosity. And in porosity, we asked ourselves the question, can we open up the skyscraper? If we look at skyscrapers, then this is, if we reduce it, then this is what it might look like. And how and if and how can we open up the skyscraper to make it more permeable and more accessible and more human? Together again with a group of students, we looked into ways of how to open up a tower. Each student was assigned one tower, and students either opened them up by adding balconies or actually bending them open in a kind of an O-ring or adding parasites to them. And here you see the full scala of interventions that students did with these towers. We were sponsored by Lego, who gave us 1 million bricks, and that enabled us to actually build all of these options in Lego. And from these options, we selected the 10 most promising ones. And these were built in 2-meter tall prototypes. And that's what you see here in this series. And can you imagine that we start building skyscrapers with terraces, with grottos, with decks? You can go jogging, you can go barbecuing inside your tower. And again, walk your dog. You see all of these clouds and caves and spaces that extend the public realm into the third dimension. And here you see the sheer size of these objects, and they are currently on display in the Centre Pompidou. So what you see is that through computational research, we translate that into designs, and then the designs again become exhibitions to gain attention for the initiative. And the next step from looking at gamification and we go through the vertical village, through actually the 3D skyscraper, we took it one step further and we actually built something that we like to refer to as the human high-rise. So I'm going to take you to Amsterdam, and I'm going to show you how this work that you've just seen inspired us to build a skyscraper in Amsterdam. This is the Amsterdam South axis. This is the CBD, the Central Business District of Amsterdam. This is an area that mainly consists of offices. That means that at night, it's very dark and not very lively. So the city also understood the need to bring life to this area. And therefore, the city organized a competition, bringing residential and mixed use to the CBD area. And if you look at the site, then you see this question mark right here. This is the site where this building resides. And you see the different colors that this building or the site exists on an intersection of offices, residential, and green. So there's an opportunity here to bring those three different characters together. And the proposal essentially exists of a typology of 3 towers on a podium. And there are 3 residential towers with a podium that is offices and retail. So it's a very lively, even there's some culture in there as well. So what did we actually do based on the research that you've seen before? We broke down the volume and we analyzed this together with Arab. We developed a tool that actually shaped the design according to sunlight, sound, and wind. And if you see, these are some of the options that were calculated in terms of performance. So we looked at the relationship between outdoor space, views, shadow, and window types. And if you look at this army of options, then the red ones are the ones that are performing worst. The green ones are the ones that are performing best. So if we look at the volume itself, you see there's a public route going over and across the building. There's a grotto that brings you through the building itself. There's vegetation on top of the building, and there's an activated lively plinth and a sky bar. And together with MVRDV Next, we developed a computational workflow that enabled us to create a seemingly organic, wild pattern on the facades. And this was a workflow that brought us all the way from Revit to Rhino through a Grasshopper script that enabled us to design all of the tiles, draw 44,000 tiles in 27 revisions without any loss of material and with an extremely high degree of precision. So this is what the computational model looks like if you translate it back from Rhino to Revit and back. And this was also the way it was in the end manufactured. And here you see the final result of the project. So if you're in Amsterdam, please pass by and experience the valley in real time. Here you see the public route and indeed the facade pattern that was completely generated with a custom hyper-specific design tool. We're also very happy that this building is recognized as the best skyscraper of 2022. Then the next example that I'm sharing with you is the roofs of Rotterdam. And Rotterdam was completely bombed in the Second World War. And what happened is, to celebrate 75 years of reconstruction, we built a temporary installation. And as you see in this slide, it was a staircase that brought people to the roof of the building next to the central station. And this installation was incredibly popular. It was there for 2 weeks and it actually attracted 350,000 visitors. Based on that, we were inspired to develop the Rooftop catalog that shows different initiatives and infills you can apply to roofs. Can we use roofs to create extra housing? Can we use roofs to generate energy? Can we use roofs for water retention, for sustainability, for mobility, social spaces? And this Rooftop catalog then again led to us setting up this rooftop installation. This was last summer in Rotterdam. And as you see, there's a complete orange loop bringing you over and across the roofs of the city to experience everything that the roof can do to help the city. And we also applied another rooftop intervention here on the Netherlands Architecture Institute that's actually situated next to the depot, Boijmans van Beuningen. So here you see also another built installation, a manifesto for interventions that can help the city. And that again then led to a computational project by MVRDV Next, which is Roofscape. And we've actually just finished this. We're working together with the city of Rotterdam, who was inspired enough to ask us to develop a tool that helps them to explore their rooftop policies. And Rotterdam has been dreaming about their rooftops for a long time. We already see that there is a lot of things happening with new landscapes in the third dimension. And yeah, how can we unlock the hidden potentials of the cities around us? So the tool we've developed essentially allows you to first analyze what's there. So we can actually map out, make heat maps of all of the roofs, the types of roofs, the age of the roofs, the structure of the roofs. And based on that, depending on the type of roof and the context of this roof, we can start to test what roof is suitable for water, for green, for social spaces, because of course, these have all different requirements. Then the next step that we can do with this tool is simulate scenarios, and we can actually start to disperse the necessary program that the city needs in terms of energy, in terms of water, and in terms of reduction of urban heat island effect. So we can test scenarios, see what would be best applicable to what neighborhood, and in the end also quantify the impact of the scenarios. So this is indeed what you see in this scenario. We can also start calculating how much green we add, how much heat island reduction we have, how much water we can retain, and how much energy we can produce. So we can explore and utilize the potential of the city through hyper-specific tooling. Then the last project I'm going to show you is how we design with the sun, and how also designing with the sun helps us to unlock potential in the city. Designing with the sun is in our roots. Already in the 90s, we've displayed ways of us working with cutting sun envelopes out of buildings. This is an example of a build project in Bordeaux, where we actually had extruded all of our sites to the maximum height and then start cutting back the volumes according to sunlight and daylight. And in the end, that brought us the master plan that you can currently visit in Bordeaux. So also, if you see these type of shapes, you would not normally design by yourself, but if you use a software to actually shape your volumes according to the local regulations, then this is what you end up with all these strange sloped roofs that you see here. Designing with the sun is something we do a lot inside our practice. These are all examples of how we work with the sun and how we test different options and variations for models that work with the local regulations. And because we were doing this in so many projects, that inspired us to actually see if we could apply a solar strategy to an entire city. So again, we used the city of Rotterdam to test our own methodology with making sun envelopes. We're going to look at Rotterdam, and Rotterdam has developed high-rise vision to help them map out what's possible in the city and to also map out maximum heights. What you see here is that any city has high-rise regulations, and traditionally you would say, for example, you can't build higher than the church, or you can't build higher than 200 meters. And the city is also interested in exploring densification potential. So what we see is a tendency to move from absolute envelope constraints to performative envelope constraints. And that's what we tested in a software. If you look at the high-rise zones in the city of Rotterdam, these are actually in red indicated the zones where you cannot build higher than 200 meters because we have to protect certain areas in the city from shadow. And the yellow areas that you see in this map are areas where you cannot cast shadow. So what we actually investigated is to voxelize all of the plots in the city, and for each discrete element in this voxel envelope and analyze if it casts shadow or not. And indeed, you can actually build higher than 200 meters as long as you remove the area that casts shadow. And this unlocks a whole new potential for the city. And what you see here is a city with 60 minutes of shadow, 30 minutes of shadow, 15 minutes of shadow. This offers us the opportunity to actually negotiate with the city and with developers on where is the biggest development potential in the city and how can we negotiate and talk about space, shadow, and development and densification. So Solarscape is a software that negotiates between public and private stakeholders. It's a scenario maker to explore the interplay of policy, building codes, and space. And it's a workflow that calculates and visualizes design space within the city. To wrap it up, we see and we have seen some examples of how MVRDV and MVRDV Next use a technology to try and innovate their designs, but also to address the global urgencies. And if we actually ask Midjourney, what do we see as design? Then Midjourney actually resorts to gradients and shapes. It's not exactly clear what it aims to do. And luckily, as architects, we have an understanding of context, which we do not yet fully see in tools like Midjourney. If we ask Midjourney what is technology, then we see a collection of tools, but it's not exactly clear what they aim to do. And if we actually ask Midjourney what is innovation, we rarely experience such blissful moments of illumination, but we agree with Midjourney's intuition that innovation is driven by people. And the tools we use are as good as the person that is using them. And we feel that by using these tools, we hope to address the global urgencies to reach data-driven designs that also involve soft data, because soft data is as important as hard data to reach cities that are safe and happy and connected and responsible and beautiful. So I would like to end with the conclusion that we are working around the clock to maintain and expand agency as makers and not users of the tools that shape us as designers. Thank you.
Thank you, Sanne. That was great, very inspiring. We'll be back after the, what do we say, 11:10 to ask some questions, and we'll invite her over to the panel as well. Next one, I'd like to invite Jitki Chin and Chris Lanzisera from Suffolk Construction up for presentation. So Jitki is the Chief Data and Innovation Officer at Suffolk Construction. So she's dealing with a lot of data technology, but as well actually co-founded Suffolk Technologies, which is a venture capital firm investing in startups and the likes within the built environment. Chris is Vice President and Suffolk Illuminate, and really looking at the vertical integration, the whole design chain all the way through. Again, I'm gonna flip through this, a broad description of the presentation and learning objectives, but really I'd like to hand over to Chris and Jitki to come over and present.
Okay, great. Hi. Thank you for inviting us here and giving us a chance to talk to you. We represent the builders in the room in many respects, which I hope you see as an important partner in executing a lot of the visions that you all as design professionals and technologists have. And we hope to share with you a notion of partnership on a broad scale that will enable the execution of so much of what we're all trying to achieve here. So sort of they bring back this idea of what can a master builder be using data as a tool and as a fuel for that. So I think we're all extremely familiar with the criticisms of our industry, particularly the construction industry, in terms of our inefficiencies and all of the challenges that that brings in terms of our inability to truly manifest the overall project vision due to delays, due to value engineering. I know how dreaded that is for all of us. And the basic sort of change in cost overruns and time delays that occur within our industry. And we believe that working together, there is a solution for that. And that's really the role that we're trying to play and why we're presenting to you today. In general, when we look at the challenges that we face within our industry, we know that these are problems that beget themselves. They start feeding upon themselves. We lose predictability. Our clients lose confidence in our ability to deliver. Costs go up, challenges go up, pressures go up, and we're unable just collectively to achieve everything that we aim to achieve. And nothing could be more frustrating for all of us than that particular challenge. And we're here to solve for that. And one of the things we found in our own internal research within the company, and then obviously on the side, and I think we've all heard this, but that so much when we're in construction itself, this is during the construction phase, a lot, and some of this is of course builders blaming someone else other than themselves. I mean, I get that too, but the lack of completeness or coordination of critical issues within the documentation, within the design itself, not the vision, but the actual details of putting it together that go beyond just means and methods, but how the building comes together in a coordinated and complete way becomes a significant stumbling block for us as we're building. Now, that is a challenge that we think, again, working together is something we can resolve. And we think that the tool for that is going to be really a data-enabled, just as in the previous presentation, right? A data-enabled sort of vision for how can we solve more of those problems. Now, we've all seen this. I'm sort of hashing over something in this. I think it's interesting. This slide, there's a slide quote in here from Stephen Kieran and James Timberlake from Refabricating Architecture, a book which was published in the early 2000s, so 20 years ago, when I was first coming out of architecture school. Interestingly, a little side, it was super exciting to present after MVRDV. I don't know if anyone knows, there's this great book published in the late 90s called Farmax, which was sort of the beginning of a lot of that discussion that we just saw. Super inspiring to me when I was in graduate school. So just really exciting to be here to see that. Book's way out of print and I've never been able to find it, but anyway. So this is a great quote from that book, Refabricating Architecture, again, 20 years ago. And it's so exciting to be in a room now where we're seeing a lot of things that they were talking about back then really finally starting to manifest themselves. We're at a really, really great time. But the idea here of we've got the tools right now to do this. And these are the tools, and I love this analogy of going back to the Renaissance, back to, of course, our good friend, Brunelleschi, who I'm sure we all know so much about. But this guy who was able to be an architect, an engineer, right? He built the machines that were used to build the dome itself in the Duomo in Florence. Amazing visionary, amazing capabilities. I also think it's really cool that this guy sort of resuscitated, figured out perspective, right? So he was also, a visualizer and an architect and an engineer and a builder, right? And what I'm trying to say here in this slide is that's all great, but that building was a different time. That's a different level of complexity, a different level of issues that we're facing. When we look at all of the people that it takes to build a building together, right? We know that we need to go super fast flashing the slide, sorry. We need to bring all of the people together to make our buildings happen. It's not the vision of a single person any longer. And that's just not the case. So what we're really doing here at Suffolk, in our company, is we're trying to use data as a resource to bring our project teams together, to bring the builder, to bring the design teams, to bring our trade partners, and to bring our clients together with a common tool. So in general, sorry.
So if the currency today is data, so that we can unify all the stakeholders and bring us back closer to that master builder world, but of course, data enhanced, technology enhanced. What is the actual data that we're looking to bring together? So from our design teams, we obviously have all the spatial information ranging from, during the conceptual design through to constructability review, and then eventually to the constructible BIM model itself. This is all the spatial information that we have, right? From our pre-construction team, all of the pricing information, the work scope, as well as schedules, conceptual schedules based on typical production durations. From project management, once you're into the construction phase, there is a huge variety of information. P6 schedules, weekly work plans, 6-week look aheads, all of the construction administration documents, RFIs, submittals, change orders, financials, safety, increasingly novel information types like image data and sensor data. So you see up there, we have a solution called Open Space, which we use to actually capture the physical reality of our buildings as they go up. And this way, we're not limited to just sort of structured information or information that someone has to type into a computer somewhere, but an actual physical representation of the build. In the past, all of this information, we're just sitting in separate silos in different systems that didn't really talk to each other. Over the last 5 years at Suffolk, what we've done is bring them all together into a single data repository, cleaned it, harmonized it, stitched it together, and just basically prepped it to serve it up to all of our frontline professionals at different stages so that they can use the data to better take decisions. Today, we have a repository of hundreds of projects, over 100 terabytes of information across 25 data systems in our data repository. So in terms of then usage of data, where do we start? We started with transparency, and we started with transparency on the construction side. So, when data was tied up in silos, no one person could see the full picture of our projects. And projects are very complicated things, right? You got to piece together the information across your schedule, safety, financials, construction admin to really understand how the job was going. And sometimes there's a danger in complex projects that's being too, focused on a small part of the project and losing sight of the big picture. There's also an issue with projects being kind of a little bit their own islands. They're geographically dispersed, they have their own P&L, they have their own clients. And so particularly in today's environment where labor is tight, we have a lot of young professionals coming into the construction industry that don't have a wealth of experience necessarily. Transparency of the project to senior management and regional leadership was also important. So support could be given if needed before it became too late, right? So we decided the first place to start with our data was just to give transparency. We collected it from the projects, we're going to share it back to the projects. And so we built a project dashboard that gave full transparency in near real time, automatically fed to all our job sites, where they can see your high levels. Where are you on budget, on schedule, on safety? Where are you on the next level down, which is, we call it leading indicators or potential indicators of risk, PCOs, CEs, allowances, contingencies, buyout schedule. Talk about then, action items. Where are we with requisitions, RFIs, submittals, labor, punch? And over time, we're constantly tweaking this to add information that will be helpful to our project teams, right? So, and in each one of these, you can drill into more. Hey, if we have PCOs, right? Which ones exactly are they? What's the age? How do I action? It has to drill down to like an action level before things can be acted upon, right? So in summary, it summarizes project performance. It aggregates upwards and synthesizes in real time. It cements an information interface for our project team. So over time, we can add more information and add more insights to it. And then over time, what we can do with this is actually bring together the wealth of our experience across multiple projects and suggest benchmarks, suggest leading kind of predictions of what could happen if issues aren't dealt with, to actually provide nudges on behavior so that folks will take the action that they need to take. And then last but not least, culturally, what we found after we've rolled this out was that it is a career accelerant, because by being able to see the forest for the trees, a lot of younger professionals are now able to have much more senior conversations and understand what was on the mind of senior management and of the client whenever they were talking about the project. So I think this is the first step that we did in terms of using our data. The next thing that we did then is to actually say, all right, now that we have all of this measurement in place, let's think about the concept of a safety net. The safety net of saying, hey, if a project once is fully designed and fully priced with a baked schedule, everything from that point on is a defense game. It is about not eroding time, not eroding margin, and then keeping the highest standards of safety and quality. And so, a safety net of data can be constructed across these projects by taking all the measurements that we were showed previously on the project dashboard. Now we set tolerances, we set benchmarks, we highlight exceptions, and then we have a mechanism for dealing with the exceptions. So, and then finally, increasingly, once you have this net, you're looking forwards, you're trying to be very proactive. So we have forward predictors of risk. Hey, if a certain set of factors on a site, like the supervisory ratio, the weather, the schedule stacking, and the high risk observations mount up, then we have a risk of potentially a safety incident happening. And therefore, what do we do about that, right? So this whole idea about casting a data safety net across our projects helps us play that defense game using data to make sure that we don't erode the margin and time that Chris has spoken about earlier. But defense is not the only thing that data can play. We first start with defense, but we can also go on the offense.
Right, thanks. Thanks, Jackie. So the idea here is for us then to take that data that we are harvesting during the construction phase, and how can we use that to better inform and share with each of you during the design phase the key pieces of data and information that you need to make the best decisions to realize an optimized design. I mean, we talk about optimization of design. It's important to always understand that, design, and I think we all get this, that cost, schedule, scope are the key factors that make a project buildable and executable. In the end, we want to get things built. We're builders. And so how do we work together to make sure that really happens? By using the data we can collect on our projects, our real projects, we can understand cost, information for materials, for assemblies, for labor rates. We can understand the schedule impacts of all of that information. And then we also can understand the questions and issues that come together, the key points of conflict that make the build process challenging, so we can solve for those during the design phase. And so we've built within our pre-construction estimating team some pretty robust tools around cost estimating and schedule analysis. They are real-time live document or live cloud-based software applications that allow us to track real-time cost information and then apply that into our schedule generation. So the idea here is we have this tool called Cost Lab that allows us to very rapidly generate cost estimates, project from that cost estimate, knowing labor rates, knowing specific durations that are required for a particular cost factor, how long it is likely to execute a particular action in the field. We can generate that particular schedule from that. We have cost data here, as you can see in the upper left, that's historical pricing. So we know on all of our projects, the past, what the cost per ton of steel happens to be. A little out of whack right now, but in general, we're able to do those sort of things. What was really interesting about the system that we've created is then you go from the estimate phase to the buyout phase, right? Where we're actually generating the GMP with our subcontractors. We feed back into our system the costs that were assumed during that buyout phase. Then when we actually wrap up the project in the end, sort of in a post-mortem sort of model, are able to take the real-time labor rates and durations, real-time schedule, and the actual final cost and feed that back in. Our database becomes much more rich and robust as we do that every time. Then we are also, actually work with Jackie and her team through a natural language processing analysis of almost 120,000 RFIs as a test that we get in the field, right? So we as a company generate gobs of RFIs. And we have an ability, we've been trying to analyze those RFIs to understand what are the hot topic issues that keep coming up repeatedly over and over and over again, so that we can focus our collective attention on some of those details when you guys are preparing your final construction documents in the end, right? And so as we look through this and as we start analyzing this, we've got a ways to go on this, but we are using it in terms of a check, sort of creating our own sort of checklists and hot areas of focus. But you can look at some of this information and see that, for example, ductwork kept coming up as an issue with particular subtopics associated with it. We were able to attach those RFIs to change orders, so we knew what the value of that particular information was, right? And then we were able to sort of make an analysis that, based on the frequency with which this particular issue occurs and the cost of that particular issue, there is a value in us being hyper-focused on that particular topic, right? None of this should be rocket science, but it's really cool that we have the data and the ability now to harvest that information and start being better at predicting where challenge areas are going to occur, so that as a design team, we can work together to solve those particular points, right? And so ultimately, we're trying to take this to a point where we can share all of that information with you, and we can work together collaboratively using our data and using tools that we collectively and individually are developing. So as we look at this sort of workflow that we've got before us, if we had sort of a design vision, design models that we can work together on, right? And then we can start importing into that particular details from a particular library that we know are vetted and have particular cost and constructability and labor rate insights built into them, start plugging that in and then having an iterative process back and forth with the design team through the actual digital model itself, gradually refining and tweaking that particular design solution, so that as we're developing the design, as you are developing the the design from a functional aesthetic standpoint, we can imbue that solution with actual predictable cost and schedule ramifications. And this is sort of this collective vision of when we talk about sort of a data-based master builder, that's the idea, that you've got builders here who are partners who have information that they can share with you, information that only you can use because of the rigor and sophistication of the tools that you have at your disposal. So as we go through that particular process, we get to an ultimate vision where we have this incredibly data-rich model with all of the information that we would need to generate specifications and better construction documents, which we can then use to have a much more predictable and successful build out. I'm going to sort of close with a piece of software that we've been developing internally called Cost Lab. I'm actually not sure how to make it play. Okay, there we go. So this is a generative design piece of software that we have developed internally within Suffolk that has a tie-in directly with our cost database and is a product that we can share the output of with you to iterate back and forth on. So you can see we're selecting a site here, programming it with a residential block over residential over with a little mixed use podium level. And then through various series of tweaks on this, this is all very practical, nuts and bolts, developer-driven kind of assumptions here, but we're able to generate the most efficient unit layout with elevator cores, proper egressing sizing, proper mechanical ventilation within that particular space, which is important because we are using it ultimately to generate a cost estimate and schedule. So it has to have a lot of practicality built into it, and it can't just be a per square foot analysis. What we're really looking at here is something that plugs in very directly. You can see here, sort of plugs in very directly with the cost estimate so that you have actual quantity survey as you're going through it. And then we can output this model to Revit, share with you, which you can then come back and we rerun the system over and over again, arriving at that ultimate sort of optimized design solution. So I hope the message here is that we as builders are here to partner with you. We have particular set of both data, but also ambition to solve for some of the same problems that I hope you're trying to solve for. And I hope you can see us and the build industry as partners, which will go a long way to solving a lot of the challenges that we face as an overall industry. So thank you very much.
Thank you very much.
Thank you so much. Very interesting to see both spectra of from the design to the contractor, and we'll get back to that in the questions and the discussion. Next up is our own core studio team. So we're going to have Sila, and we'll split it in two. So we're going to have Sila Gultek and Omid Sayedi presenting our new advances in Core Studio Core AI, how we're applying machine learning, artificial intelligence into applications, into the design work at our firm and in collaborative projects. And then the second half, David Mans will show our newest, still alpha version, but newest application. Really excited to show Ellipse today, and how we're seeing. I probably should let Dave talk what it really means, but it's bridging the 2D with the 3D and really bringing the data, the attributes out, and being able to interrogate that live on a screen much more intuitively, hopefully. So with that, Sila, Omid, feel free to come up. So that's the slide advance, right? As soon as that's enough. It's a big PowerPoint. That's okay. This one will change. Yeah.
Jeroen. Welcome everyone to our presentation by Core Studio. Core Studio is a firm-wide idea incubator, and our mission is to increase the value we bring to clients through innovation. The Core Studio conducts research, develops custom software applications, design workflows, and interactive computational models. Core Studio was formed in 2011, and our crew is getting bigger and bigger with diverse backgrounds from different countries. So let's talk about our first part of the presentation. So you woke up in the middle of the night and it's cold, so you ask artificial intelligence to set the heat up. Or you are craving for tacos, then you start typing taco to Google and autocompletes to the taco recipes or shows you Mexican restaurants nearby. We already live with AI, and those unseen algorithms control our lives and devices, from smartphones to robots, from security cameras to our cars. Artificial intelligence impacts businesses and increase the economic growth by improving the productivity. And as we all know, in AEC industry, we have so many repetitive and laborious tasks. And AI can be helpful by suggesting some architectural design for architects, or it can help us with some of the project management or safety-related problems in construction. And for engineers, it can combine the institutional knowledge with big data so that the engineers can focus on creativity and complex tasks rather than trial and error. So with that being said, it would be perfect if we could transfer the entire company's knowledge to different apps. And as Core Studio, we believe that it's possible, and we can achieve this by using AI. And we will walk you through some of our current projects. So first one is T3PO. According to United Nations survey, heating building accounts for 30% of the building-related carbon dioxide emissions worldwide. And we can with the new energy code regulations, cities will be asking building owners to cut this emission substantially. And infrared thermography is a great tool to assess these energy losses in the structures. And T3PO is the latest software that we built by Core Studio and is powered by AI. So we use computer vision algorithms to identify anomalies like thermal leaks and bridges in the interior, exterior, and mechanical in the building. And we can save up to 70% time compared to the manual infrared thermography surveys. As we all know, reviewing and finding useful information from drawing is pretty difficult task, because most of these drawings are in physical format. So you end up tracing so many drawings to reach out to final information that you would like to get. And that's why we are working on drawing data extractor, so that we can extract these information from the drawings easily and build a repository so that we can use it in our machine learning models. And as you can see, we can identify critical structural locations, geometries, section or load information from the physical or scanned drawings. So reinforcement learning is another exciting area of AI. And ManageRL was a tool that we developed in one of our hackathon projects, internal hackathon projects. So it uses TT's timesheets, project information, and also key performance metrics from the employers. And it builds a model so that we can make the decision-making process easier for the initial phases of the design and distribute to employees when there are concurrent projects. And good thing about reinforcement learning is that you can also discover different management styles. Fryboto is an AI-based chatbot that we developed with Rumble and Continuum in our hackathon 2020. So it's helping us to encapsulate the collective intelligence of an organization, and it accelerates the reach to the company's assets pretty easily. It can give you design recommendation. It can suggest people or project if when it's relevant. It can show you 3D 3D model of the structure, or it can even book you flight tickets if you are looking for.
Now let's talk about structures. Structural design is a relatively complicated process to automate, especially because it involves several steps. For example, defining the geometry, assigning the loads, and maybe the most challenging part is you have to go through this trial and error to make sure you have all the sections that are both economical and satisfy code requirements. We at Core believe this design process can be automated substantially with AI in 3 different stages. The first stage, of course, is data. Our firm has over 70 years of engineering expertise, and we try to leverage this institutional knowledge to build massive data sets that explore every corner of the design space. Our physics-based design engines can build millions of design points that takes for human decades to create, but we try to do that in just a few days. After we are equipped with these kinds of data, we can start designing buildings with machine learning. For example, for a chevron brace frame, if your traditional design takes n times, you can accelerate that by a factor of 50 using this app. So, for example, you can minimize the communications in your design office, you get vetted recommendations in just a few seconds. But what we value most in Core Studio is the time you save by using this AI-accelerated workflow. You can help your engineers focus on creativity, and they can aspire to be great engineers rather than being great at CAD. Equipped with a big repository of different machine learning models and different data sets, we try to connect all of these through our cloud-based infrastructure named Cortex. Cortex is a place for Core Studio to access, share, and deploy machine learning models. For example, you can pick your data set that you require, for example, steel, and then fine-tune your machine learning model based on this new data set. And probably the most exciting part for myself is I can do inference calls using my daily driver like Grasshopper. So without all the complications, we can generate maybe several steel designs. Cortex has enabled us, excuse me, to build very powerful AI-equipped apps, which I'm going to show you in the next few slides. If you are an engineer and you have designed timber, you probably know about all the tables and exceptions that come with different species of timber. The machine learning app behind the glulam timber designer has seen over 30 different species of glulam and does the job for you with just a few clicks that helps the app to identify the geometry, and you just get the column profile for up to 20 stories. As an engineer myself, I have spent countless hours designing hundreds of girders and beams for different floor layout plans. And this process takes time because not only you have to design for forces, but you have to make sure the vibration criteria and serviceability things are all satisfied. And the Steel Bay Designer app does that for you by just specifying how many bays you have and how long they are. Finally, shear walls. Imagine that you're on a call about a skyscraper project in Midtown Manhattan with an architect, and the architect is asking you if you can make the shear walls just slightly smaller. Also on the same call, you may have the client who's asking you a relatively good estimate of how much steel or concrete they should buy to build this shear wall. Well, this app, like the previous ones, can be your real-time assistant. We would like to conclude this part of the presentation by saying that Core Studio is very excited about the future. We also understand how powerful AI is, and with great power comes great responsibility. Our team is comprised of people with diverse backgrounds, as Sila mentioned, including architects, structural, and machine learning engineers. And we value that our products are being constantly reviewed by seasoned engineers at Thornton Tomasetti. With that said, we strive to make sure that this AI integration is done the right way, which is by the AEC professionals. Thank you, and back to Dave.
Thank you, Seelan Omid. Everyone, great to see everyone here in person. It's been a long time, so fantastic. I want to talk about an application today that we are releasing early next year called Ellipse. And Ellipse is a little thing we've had about 2 years of development, but I'd say over a decade of kind of feedback and direction coming into it. And the questions that kind of sparked Ellipse was, looking at the current process of project delivery, design, development, and all the phases of it, and thinking about how many thousands of data points, how many thousands of hours, how many different stakeholders all come in to the development of a project, and how much of that data is actually lost in that process, whether to time or through communication. There's a lot of information, a high percentage of it, that ultimately just gets dissipated in the process and lost to history. And then how, through the process of actual project delivery and development, the mediums we use today to communicate that information and bring it out to the world, how much data actually gets lost just through the way that we actually put the work out into the world. When we move things into drawing sets, we cross-reference with schedules and annotations, we pull in spec documents, all on static medium that rely a certain amount of time where these things align. But really, we're looking at a series of kind of dead or disparate documents that have all different types of phases involved in them. And that kind of communication between those different platforms can ultimately get lost. And then, of course, at the end of the project, after it goes in delivery, how much of that knowledge long-term just ends up in cold storage, right? That BIM model gets put away, 5 years from now when you have to open it up again. Does it even still work with your current version of Revit or whatever application you're using? What problems do you run into there? So how can we actually begin to think about creating an ecosystem or an environment where all these disparate sources, disparate stakeholders, and then all the different data sources can come together into one place that we can access? And so along that process, then, what's everything that has to be maintained? The geometry of the project, all the graphical clarity and information that goes into a good drawing sheet and annotation, the information and the data, but also all the cross connectivity. One of the great things about BIM models and what it's brought is the ability to basically connect these sources within the platform itself. But so much of that gets lost when it exits that ecosystem out into the world. So in the 8 minutes I have left, or however many, a very brief history of the decade of exploration into lossless approaches, which is something that Thornton Tomasetti and Core Studio have been looking at basically since the founding. So Core Studio has kind of looked at this from 3 different mediums of delivery since the beginning, and kind of hackathons and prototypes. Early hackathons looked at an application called VA3C, which was the first kind of approach to beginning to move 3-dimensional modeling up onto the web and make it accessible to multiple stakeholders collaboratively. Pollination was a tool that took the idea of all this BIM data that gets generated. Can we create an online platform where it can be shared and exchanged, and again, kind of added to over time? And then one of the later applications we looked at was how do we actually take all that 2D drawing information that ultimately is what we deliver as architects and engineers into the world, and then bring that up to the cloud. Over the next couple of years, Core Studio had basically worked on refining these ideas through a lot of feedback from all of you, and then also internal testing, and beginning to develop libraries that could support this type of an effort. And these kind of over the past couple of years culminated in 3 different applications that all basically took this information, put it in web applications, and then opening it up to the public so that everyone could begin to try sharing it, using it on their projects, and ultimately learn how this process is evaluated. And as that began to develop, one of the key things that became important is the need for cross-communication between all these platforms. But since we had basically built 3 independent platforms, it became a lot of hot wiring behind the scenes, and it became pretty clear that we needed to kind of reinvent that problem. And so to simplify it, basically what we thought about is, can we take it back down to just looking at 3D, 2D, and data visualization, and building a new platform in the center of that, which we look at as an AEC data studio, we're calling Ellipse. And so at the heart of this new platform is basically the project data, which again, not just from multiple software, but multiple stakeholders is looking to bring it together. And it's not quite as simple as that previous diagram. As we've mapped it out, that's kind of expanded in complexity. But how do we address all of these things to create a very simple user experience for accessing Ellipse? So what is Ellipse and where is it at today? Basically, Ellipse allows you to take all of that information coming from BIM platforms or ultimately several other different platforms, be it drawings, models, or even sheet sets, and then take each one of those pieces of information and then upload it to a web platform that is accessible to multiple users, as well as kind of curating what data ultimately goes up into the platform itself. That information is then accessible online for both accessing 3D models, 2D drawings, and the data set simultaneously, and beginning to leverage those attributes to visualize data that's behind it that maybe the application you're working in doesn't easily display, and begin to explore the actual values underlying the geometry and ultimately the design of the project. It also allows you to go in and kind of query information. So how do you very rapidly take those models, drawings, or even just the data itself and begin to evaluate and look at the distribution of the different data points? And then also one of the big goals was to maintain that cross connectivity. So one of the big advantages, again, in a platform like Revit, is that you can query in the model where a drawing element is coming from and find out where that information is associated, and then see where else throughout a drawing set it's also located. So Ellipse allows you to maintain that connectivity, the topology of the model and the drawing set outside of the Revit platform. So when you want to click on a element inside of one of your drawings and see where it is in 3D, you can still maintain that relationship. And then as we get further into it, eventually see where else it is in the kind of drawing sets, and then also see all the data that's associated with it as well. And we wanted to build Ellipse basically not as kind of a static dashboard, but as a flexible platform where you can kind of construct how it is you would like to visualize this information based on the stakeholder or team member or whoever you're working with you would like to share it with. So one of the underlying drivers of Ellipse is allowing a kind of maximum flexibility to customize the way you interact with these models and data on a kind of case-per-case basis, whether that's through the lifespan of a project or depending on who ultimately you're looking to communicate information to. And so here we can see just a little bit of the ability to kind of build up your own project dashboard, which can have everything from 2D drawings, 3D models, down to just typing some text or putting together a little presentation. And additionally, we didn't want to just limit it to the software that we're aware of and use, but wanted to provide the ability to basically just upload data, models, and drawings directly into the application. So one of the main features in Ellipse is that you can actually upload your models, drawings, and data sets directly and at multiple different times. So as your project kind of progresses, you can add this additional information in and build up a kind of a larger project, a central project that you can distribute to your entire team. And you can begin to curate how that information is displayed based on who you would like to interact with it, and then also who it is you'd like to communicate information to. So depending on if you're building a presentation as an architect, if you'd like to just simply give access to the models and drawings in more of a data-centered way for a spec writer potentially, rather than sending CSVs and Excel sheets back and forth, can you create a live data interaction and bring that in? Or potentially even in a sub-consultant working on the project, how can you begin to pull that information out and have it all accessible, but also curate based on who that stakeholder is, what it is they can access so that the data and the materials they're seeing are relevant to their experience with the application. And then additionally, we wanted to provide the ability to collaborate and provide feedback. So instead of just pushing things out into the world, giving you the ability to comment, to actually provide feedback, assign tasks, but also attach files and additional information such as specs, site photos, however it is you'd like to use that 3D model, whether it's in the field or in the office to communicate. So that's a little bit about where Ellipse is now. We'll say tomorrow-ish. Could be a couple of weeks, could be a year on some of these things, maybe more. But we're looking to expand the ecosystem we work with. So right now in the alpha, we're basically allowing you to interact via Revit, Grasshopper, and Rhino. But we're looking to expand into engineering software as well and beyond. And this is one thing we're very excited to get feedback on and learn how people would like to use this. We're also beginning to leverage some of the new technologies that are available, both in 3D web viewers and 2D viewer technology via the McNeil 3DM platform. So at this time, we can actually take multiple different file formats, but we'll be extending this out to allowing you to upload different models from different sources, be that an OBJ, a DXF, or even future IFC models, PDF and Excel, and begin to read the data and geometry into the actual content. And thinking about where the sources of those data ultimately come from and how that can kind of grow over time. Projects aren't just coming out of Revit. Things are coming in from multiple different sources. There's a lot of great technologies out there that already kind of handle interoperability and data management. So how can we leverage the fact that this is an online platform to pipeline that data in and create an ecosystem for kind of visualizing and sharing data from multiple sources that might be dynamic and live, not just static and output at particular times. So if you would like to try Ellipse out, it's in early alpha right now. So we're doing a little bit of an invite only. So you can ask for access to that, or actually the core AI tools as well via the QR code. And then we'll be doing a public release on Ellipse in early 2023. I'm not going to fix a date or even a month at this point on that, but it is available to try now, and we are really looking forward to getting everyone's feedback and being able to develop this tool that's meant for the entire AEC or AECO community to actually contribute information and feedback and help us guide the development of this, because ultimately this isn't a tool for us, this is a tool for the entire community to work with. With that, thank you very much and enjoy the conference.
Thank you so much. Exciting times ahead. So next one up, we'll go back to the architecture. So we're really pleased to have Michael Hodge from TVS Design over to speak. Michael is digital practice and design technology principal at TVS, based out of Atlanta. Maybe I'll leave it there. Oh, no worries at all. Very much welcome. You want to plug yours in or look at
We can get it from there. I could plug in if it's possible, but
it's preloaded on the machine.
No, I won't. It'll be fine. Thank you. Gotcha. All right. So you want to advance that? We need it because we got a lot of slides. Sounds good. Sounds good.
Hi guys, can you change the presentation?
No, well, we could. I just wanted my notes in there because they weren't in the original one that we uploaded.
Oh, okay.
So we can keep this here. I was just gonna.
He says just go ahead and use it.
Yeah.
You have loaded
Yeah.
it.
Gotcha, okay.
Yeah. No problem. Yeah. You can. You sure? I was gonna do this one.
Yeah, you can.
No. Oh, that might be. All right, got it. All right. All right. Good morning, everyone. Emilio and I are really, glad to be here and privileged to have been asked to come and talk a little bit about what we do at TVS Design. For those of you that don't know about TVS, the firm was established by Bill Thompson, Tom Vincilette, and Ray Stanback back in 1968 in Atlanta, Georgia. And we've done a larger number of the prominent buildings that are in the city of Atlanta. And as a firm, the work that the initial founders set out to do has always been an exploration of innovation and technological excellence, as well as an emphasis on delivery quality. And with that said, it's garnered us expertise in convention centers. So public assembly is one of our largest market sectors. We have 10 different studios throughout the firm. We cover pretty much everything there is to do in architecture. I won't bore you all with the different market sectors specifically, but what you'll see in the graphic here is that over the last 20 years or so, we've had either an active convention center project in construction or initial stages of design every other year. We just completed work on the Javits Center here for that renovation and addition, as well as the Las Vegas Convention Center, both of which were going on at the same time. And in parallel, you'll see that a number of the projects that are listed up there will overlap through that duration of time as well. That has allowed the two of us to actually be here because those projects have pushed the envelope of what can be done and how design tools have influenced that over time. Next one. With that said, adding more to that public assembly side between aquariums, stadiums, we've also found, and just recently in our research, that we've done a large number of performing arts centers as well, which I'm only 5 years into TVS, so I didn't realize that in parallel with convention centers, we had a large scope of work in that arena as well. So, as dynamic and I would say compelling as the project work that's been done at TVS is, we're here to talk about digital practice and design technology operations. And as I mentioned earlier, there wouldn't have been an opportunity for that without some of the projects that preceded us getting there. About 4 years ago, almost 5, the core group of the two of us right now and an extended network that we're going to talk about came to be based on digital transformation in our industry. So it was a chance for change, and it was an opportunity to come in and look at what was primarily an IT-driven design application infrastructure and change that and make it more people-centric, as well as put together a research and development component that was never there in the firm. From that, looking at the things that others at my level, principal-wise, were trying to figure out transformation as far as digital tools, processes, the engagement of clients, how we deliver, how do we need to better manage that? And a part of my discussions was that we needed less of a management structure or coordination of those tools, but something that was a framework that dealt with the people first, because if you don't have the right infrastructure for the people to grow and develop and create, it won't work. And from that, this is where we got to what are our 3 mantras under digital practice and design technology ops: people, processes, and tools. So a large amount of what was my job almost 5 years ago was to convince the firm that we needed a balancing act between what was IT and what would be this new entity that we were creating. And that was hard for them to see because, as many of you might know, if you're in AEC, that vertical structure of what was always technology and IT was always driven under one group. And you'd end up having specialists underneath that group. But my take on it and my vision was that we have architects coming into practice that are more hybrid and capable of doing more than what the traditional architect can do. So why do we need specific specialists? There's some needs and necessities for specialization. Emilio is our director of digital practice and design computation. Our design manager and director of design computation, which means that his specialty and a group that he leads underneath him, is focused in that area, but that group, they're not a separate group of design computational specialists. They're just our designers and architects that are in our studios that he has some oversight and direction of based on the project types. So the idea that the entity that we created governs processes, standards, and application, had to be separate from IT, but parallel. And luckily, in tandem with an old colleague of mine from Perkins&Will, Jessica Steele-Harden, we have a great balancing act happening at TVS that allows us to focus on our strategic priority of basically keeping pace with our industry leaders. And that's tough for a very small firm. I don't know if you saw on that second slide, there's only 145 of us at TVS. We have an office in LA, a small office in LA, and another office in Tampa, but the majority of that 145 is in Atlanta. So our resources are limited. So we found a way to be agile, nimble. We partner up and have a lot of relationships. Rob and Charlie are old friends, and we've done some things with Core, and we try to bring them into project processes when we can. We have to do that in order for us to compete. And a large amount of the work that I show will show that as a small firm, we do work that big firms do as well. So focusing on people, as I said, was the first take of how we wanted this to come together. And Emilio actually was at TVS prior to me for about 5 years.
That's right.
Left, found out, some of the things that were happening because he was trying to make change when he was there, realized it wasn't happening, came back in the role that he's in. So the studio in its entirety is just the two of us. However, there's 17 other individuals that are throughout the firm, spread it out as a network of collective intelligence that we both connect with. And the framework goes beyond the digital tools. So, we're going to talk a lot about what you all have seen so far as things that we apply and do, but we're also going to talk about how we're dealing with those individuals that aren't the traditional architects that, typically, as far as the profession goes, you either get put into a specialized position based on something you're really good at. And that idea of being the real generalist to do more is very difficult. So we've kind of structured a balancing act between what would be human resources as well as talent development to create growth paths so that certain areas of expertise, proclivities that you might have with different tools allow you to actually still be that generalized architect, but then focus on the things that make you want to get up and go to work every day. And for me, I believe that's a necessity to put together the right type of infrastructure for 21st century practice, especially being someone that came through a path that was a little bit winding because I was a little different than everyone else that was practicing architecture back in the early 90s. So with that said, the makeup of what we have put in place, nest at least one digital practice leader, somewhere between 2 and 3 in most studios. And as I mentioned earlier, they're not in a separate group that's digital practice. They're an extension of what we have. And some of them are just focused on BIM related, data related, and or computational or parametric focuses, but individually, they all become a certain level of coordination and or leadership within their studios. As an ecosystem, this is what it looks like for us. Basically, what I feel comes out of this is a great network of knowledge that can be shared peer-to-peer. Anytime that one of the studios needs an overlap of a certain individual or resource, it's easy to get it. And at the same time, the interconnection that kind of is created based on what Emilio and I have in place and the way that we bring that collective intelligence together just gives us a lot more strength and power. It can be challenging sometimes to pull one person from one studio to another to focus as needed, but we're still working on how that infrastructure really relates to the primary goals of keeping key knowledge and understanding growing and putting in place the right skills and an emphasis on how these teams can be successful. Because again, without the right setup for people and what I talked about earlier, this focus on growth paths, it's very difficult to get the most out of a very small organization. And what we've done is we've gone beyond just what's a start here. This is something that we'll, preview more in another event later about how this impacts our individual practice professionals. But we've got a way of tracking those that are seen as a bit different. That, I know that you all probably saw that article back, I can't remember how many years ago it was, but I think it was in Arc Record or another publication about the polymath. And mainly what I see is that, what I mentioned earlier, certain practice professionals aren't going to follow that straight path that most do. And if you have the right infrastructure for those personnel, that set of personnel to develop, you're going to get a better result as far as what you can and can't do. And for us, process-wise, that's highly important because, being small, the core of our teams don't have a large number of persons that can do the high-level expert work that's needed. And like everyone else, we're, in that position of model-based delivery and design processes and trying to figure out the integration of data to that. So from that standpoint, having what I would call parallel experts to the process is just going to help us as we find ways to be stronger, faster, and as needed, have that framework that brings together those capabilities. Now, I'm going to step back and I'll let Emilio talk a bit about what was there before us that predated us getting here, because that framework, is people-centric, but as far as advanced processes, TVS has been doing things for a while in that regard.
One of the benefits that we had coming in as a digital practice or evolving as grassroots is that these tools or processes weren't new to TVS. They were dating going back several years, early 2000s. We had projects like this one, which is the Nashville Convention Center, where they're exploring different typologies and exploring sine waves to create their geometry. They were utilizing tools like generative components and Bentley software to generate this type of forms. And they realized that with this process is that they would also have to kind of model more to understand and rationalize everything that was occurring in this building. These typologies weren't something as clear cut as just vertical walls, but now they have to be layered systems and compositions to that.
Jump in real quick. So when I was looking to put together a team, I searched around the, primarily the Northeast, because at a point in time in my career, I worked up this way. And I knew a number of different people to ask around and see who was out there that could, do some of the work and have proclivities that I felt fit, someone that could direct design computation at TVS. And I heard of a person named Emilio Hernandez that worked on this project. And I was like, we got to get him back. And I had to have a talk with him because what I understood was that he worked in parallel with HOK to develop all the scripts for the development of this project. And I think this was a changing point when you look at and talk about growth paths in the trajectory of his career.
Absolutely. I mean, this was a project that I was first doing visual scripting in 2014 for the first time as a real project. And so just dabbling, researching things. This became like the first part of the trajectory of my career, where we're trying to figure out and rationalize this design that's been kind of inherited from HOK. And being the local architect, we now have to kind of figure out and also go through a process of value engineering. As you can see, the script got a little complicated. This was originally HOK, and then this is me trying to figure everything out for the first time. So it was a learning pains, with this whole process.
So from there, we've developed a lot of different things, and Emilio is going to go through a few projects and focus on some of the work done that's specifically computationally driven. And we've looked at a couple of scenarios to implement design for manufacturing processes and workflows. And I'll let you go from there.
Yes. So a lot of our process is trying to figure out a way to participate in this kind of design fabrication process. And so one of the first projects that we had was me coming back to TVS as a computational specialist. We did a project in near LaGuardia Airport, and this is supposed to be a mixed-use tower. I think a LaGuardia Hotel and Conference Center. And this was the original design look of it, and we were trying to work in cohesion with different tools. We're trying to utilize Proving Ground, figure out utilizing Dynamo, just find a process where we can take this really elegant and iconic form into a rationalized design. We were also kind of teaming up with
Gate precast.
Gate precast, to understand what are the limitations that we're dealing with and what type of approaches can we have in prefabricating this design and putting it together so that the client can maintain the utmost quality of the design and fabrication, but as well as expedite the process of procurement and construction. That project also became the framework for how we approached this project in China, which is located in Longgang, China. And that design was something that we won through a construction company as a client. And we were trying to figure out in parallel with the designers, how can we make this form rationalize, use arcs, panelize it? How do we start to document it in Revit so that we can do that handoff, which our client was a contractor. So they want to know as much as possible what the design qualities were. This opportunity also gave us an opportunity to kind of work in parallel with the design team, but also enhance and evolve our digital practice leaders so they can become the managers of these scripts, learn from them, but also apply them to their projects.
What I'll add is that that project was probably a year and a half into some of Emilio's work. So that component logic and modular basis of the LaGuardia project that he showed, that came out of a look at an efficient way to get the model to fabrication that a couple of our market sectors should actually use and work with. We ended up finding that when it comes to people, we had 3 new resources throughout the firm that could do almost what Emilio could do within that year and a half period, just based on the way that he was working with them in parallel.
So by working in parallel with them, we were able to kind of create a roadmap, not only for them, but also to do a handoff to our clients so they can do the construction. And this roadmap allowed us to kind of also create the framework for our future designs. This process of this project has greatly evolved our DPLs in order to where they've had never opened Grasshopper before, and now they are probably intermediate experts on the firm.
The difficulty we're having with it is finding a way for this to translate into other studios and market sectors. It's easy for public assembly, our sports projects, anything that deals with some complexities of form, but the panelizations and modular approach that we were looking at in LaGuardia, we're now trying to get our mixed use and our multifamily teams to basically look at that and apply some other scripts and tools that Emilio is developing. So that leads to another thing that gets to the relationship that we have with CORE. We in 2019 created a conference, which was the first of its kind in the Southeast, to focus on talks and lectures, as well as investigations of new processes and tools. So Design Next Week was a hit for a first-time thing, and was supposed to come back shortly after, and we ended up having a pandemic. So what we're looking at is revising that, working with a number of you all that are in the room to bring it back to Atlanta sometime, next spring or fall. But beyond that, we have our research arm that's what we call now the Design Exploration Lab. And there are a number of tools that we've been developing. We're still working on that culture shift of utilizing design assist tools in parallel to the typical processes that everyone's used to. That's challenging because we don't have as many experts in the firm as we'd like. And then most of our design leadership still likes to work by hand and in more analog methods and methodologies. Anything you want to add to that?
Yeah, so in parallel with working with design teams to develop this, we also supplement our time by creating these type of prototype tools as a way to continue evolving our digital evolution. And these type of tools kind of validate a lot of what we're doing design-wise by providing data to the designer and validating whether their metrics are hitting the right numbers for their clients, and also do their due diligence with that.
Now, the challenges we're facing is that you see on this board a number of tools that span the spectrum of about 40 years of development. Mm-hmm. And the top left is a tool that we call the Easy Button that actually reads every model that we have up in BIM 360, we can pull it out and in that graphic format, go through any programmatic data that are that is nested in that model. The key right now we're finding is that, we got to kind of hold development because there are a number of other tools that are coming out that do a lot of things that we've been exploring and trying to investigate. So again, that symposium, that conference that we're putting together is to make sure that we're actually not expending resources that we don't have as a small and agile firm to develop tools that are already coming down the pike through other means. So how do we integrate it and how do we find it? And again, it's always a look at where things are going. From an evolution standpoint, we apply, an exorbitant amount of dollars to look at a tool when COVID hit. And this is our first take on an AI tool. We developed this in tandem with our other partners from Evolve Lab. And we felt that being that public assembly spaces was a large part of what it is that we do. We needed to understand when reopening came back, how could we simulate and analyze within a space, what needed to happen so that you could have COVID avoidance as needed based on guidelines. This tool was really smart, not as graphically intense as we wanted it, but we were able to apply it to a large number of different projects that were actually in process, as well as some investigative studies when it came to different market sectors. We did find that it was valuable for the public assembly sector of our markets. We had difficulty trying to get other markets to utilize it and apply it in any manner. So with that said, we're always looking ahead to what's coming next. So level 2 BIM, how AI and smart construction will impact us. That data side of things that was a part of a large amount of what we showed in that one slide. We're trying to figure out how to bring that down to a means of actually evaluating studios and looking at the progress work that the teams are doing and bring that data back to a way to find more efficiencies in process, as well as looking ahead so that we're keeping pace with how that human machine interface is going to really impact what we do. Beyond that, and this is more in Emilio's sphere of influence, these other tools that are coming out that are really going to change how we do things. I mean, I'm not going to even speculate on how any of these might impact, with the exception of Omniverse. I think that might be our first, next level research into this.
It's the only thing we can do is adopt these things as part of our arsenal of digital design tools. Just like the saying, going back as to sketching, these are just ways to create ideas and ways to explore different possibilities.
So from there, more to come on the next evolution of design next. And thank you all for being here.
Thank you so much. Inspiring presentation and a very nice segue actually to our next speaker. Last slide was about Omniverse. We now have Cobus Bothma online of Omniverse. Cobus, we know him for a while from his time back at KPF and recently moved over to the Omniverse team. And within Omniverse, there is this team, there's a few people in the room as well. They've been hiring some key architectural practitioners, bringing into the firm and to actually make a push into the AEC industry, which I think is quite exciting and great to see. So again, the project presentation and learning objectives, but really, if Cobus is online already, he couldn't make it in person, unfortunately. Then let's switch over to that. And the room is yours.
Thank you, Jeroen. Can you hear me well?
Yes, all good. Thank you.
Excellent. Let me just share screen quickly, and then we can get going. Just give me 1 second. All right, please let me know if you can see my screen.
Yes, we can. All good.
Awesome. Thank you very much. Thanks for the introduction. And this is quite exciting. I'm sorry I can't be there in person, but I have 20 minutes to explain to you quite a big concept coming forward. And I think some of you have attended some of Robert's and Sebastian's workshops during the past day and so forth, and probably know most of us already. So just a quick little disclaimer before I start. Everything's still in flux and moving forward at a super fast pace. This is the team, as mentioned. I need to just add to this, we're all from industry, as well as the fact that none of us are on the same locations. Well, Robert and Sebastian are close by, but we basically work live on real projects from London all the way to San Francisco and Seattle. So we prove really what we do, and we're trying to tell you to do with Omniverse and USD as we go forward. Also, probably not necessary to mention, but 3D workflows are in all industries and all aspects. And we've seen some development and progression very much so in other industries that we are trying to infer into architecture and construction, and likewise reverse that into other industries. So nothing stops us from using a SketchUp or Revit model to eventually go train an autonomous vehicle. And I think we need to start understanding that this is the way forward in industry and the way forward we're going to be designing and building city infrastructures. So what is Omniverse? So I'm going to show you a quick little video. It's about 2 minutes, which is on our digital twin, which relates to our industry very much. And I think it covers engineering and construction and architecture in this little concise little clip that I'm going to show you quickly. And I hope you can hear the sound. Well, as you notice, Omniverse is very much used in the M&E as well with that dramatic music. So I think we need to start with USD, which is a universal scene description, and it's developed by Pixar quite a few years ago already, 12, 15 years ago already, and very much used in quite a few industries before we even started entering this into the AEC industry. It's open and it's extendable, and it's really there to help facilitate build complex 3D worlds. Now, what we're doing on top of USD and what we help USD develop as, because USD is open and we don't own it, is to integrate all the applications that we typically use as designers. And we're not saying that you must use USD as a design application. We're saying that you must keep using your applications best suited for your needs and synchronize everything in this agnostic space, this USD world, so that others can participate and we can start growing buildings and develop buildings beyond the need of design into operations and simulations and the likes. As you can see, a fair bit of familiar names, and we have many, many connectors into USD. USD is open format. It was open formatted in 2016. And NVIDIA also developed MDL, Materials Definition Language, that we also made open source. And the combination of these two really allow a geometry data set that has the ability to have not only visual materials assigned to it, but full physical properties to it. So you can really start simulating what you are building and what you are constructing and engineering in real world terms, but in a virtual space. And then, of course, we're developing Omniverse to sit as a sort of eye or as an enabler to USD and to MDL, and as well as to all the other microservices that NVIDIA and all the other companies are developing. And Omniverse allows this interaction of USD with applications, or maybe your own applications between each other and so forth, or your colleagues or partners in the building, or as we do as a team with projects across the globe, right? We work with singular data sources on cloud servers from anywhere in the world where we want to be. Now, this is a very familiar one, and you guys are going to probably be bored by this little picture, but this is the issue we still have to this day in the industry, right? I'm in application 1, somebody else in application 2, etc., etc. You know what this is about. And we have very good ways and developed very good ways of how to interoperate between these applications, but they are still restrictive and limited, and they are still only built within our industry with our needs. And I think we need to start looking beyond this. Now, we add a level of complexity to this where I'm in application 1 because I'm prescribed to use application 1, and it has a function that I can use in application 1. But the function in application 4 is so much better. And I prefer to use the function in application 4 because it is better for the need that I have. But I cannot get 1 to 4, or if I do, there's data loss and integrity loss between it. And then I have to go back again. That's my one option. Or the other option is make do with what is in application 1, where that function is not the main focus of that software, but I have to then compute that function inside that software. Right, and this is limiting. This is not where we see the future is going. The future is basically where we want to be using the applications that is best suited for what we need to do to deliver the cities and the buildings that we are designing. So that's why we are talking about a complete agnostic open format, USD, and Omniverse allowing this enablement of this, where we are saying, well, now you can pick the software that you want to use, collaborate with that in USD, and start building multi simulations or worlds of your buildings. And then add this layer of compute on top of this, because this is the big differentiator between USD and the other really well-known and very robust collaboration platforms and databases that's out there, is that we have the ability to compute geometry and visualization as well as data machine learning on top of a single data source coming from multi-applications. So we're not forcing you to use a application, we're telling you to use your best application that you're comfortable with and that can do the task, and then allow global or server level compute on that and bring the experience back to you as a visualization. Relate to this as a way of working with InDesign or with probably with HTML or the likes, where we don't actually care where the source is coming from, and something might be completely different to something else as a source represented in a single page or in a single format that you can actually read or experience as an evaluator or reviewer as such. And I've had a lot of hard time with telling people that all designers shouldn't need to code, and even my colleagues probably don't agree with me with that. But you can agree that many times, or probably all the times you interview someone for a serious design position in your company, you look at their software capabilities. So you're almost putting them and their software technology skills above their design skills. And then you have really this differentiation between a designer that has to grapple with software and software updates the whole time, and a computational expert that's sitting on the other side that they have to interface with and work with, and takes probably time to go and compute something or set something up and come back and forth between this. And what we are hoping is going to happen, and this is with the democratization of technology and this opening of all these sub-functions that are making it more available to people, is that we're going to have a designer that picks the interface that they want to deal with. If the designer wants to use Rhino or SketchUp or Revit or Creo or CATIA or whatever it is they want to use, a pen and a pencil, they have the ability to use that interface to do the function and the task they want to do, and then allow compute and simulation to happen as a step away, and have this experience fed back to them. Because as I mentioned earlier, the experience is through visual geometry and data experience. So we can actually pick how we want to have that respond to us, and how we can see our design decisions in real time displayed back to us, be that VR, AR, web, a browser, however you want to be doing it, right? And I think this is the cycle that we are working on very hard to get in real time globally. And I'll show you some examples of where we are with that right now. This is just a brief slide on how Omniverse sits, and I don't want to lock down on this because I think there's a lot more to talk about. In the center, we have Nucleus, which is the data server as such. It's also a tracking server, so you can actually go back in variations back of files that you have entered. So it manages all your data on your files for you. And then we have Omniverse Create, which is really the creator or the advanced user's interface or entry into Nucleus. That's where you'll be sitting in Rhino and click a button and you'll live sync geometry back to the server that somebody else in Unreal Engine, for example, can view or see. And then on the right-hand side, we have Omniverse View that is mainly for review, markups. We do real-time markups, measurements, do storyboarding through it and the likes. And that's very much for project managers and reviewers of what is happening on a project and to be able to feed back to the designers to do changes and the likes. There's a lot more on this. Of course, I have to just one slide I want to show you on this because I want to get into the actual application side of this. Please ask us more. We're happy to go into the details of how this is deployed and built. Further, as I mentioned, there's an incredible amount of apps, connectors that we have that can write an interface with USD that you can view geometry inside Omniverse of. This is related to applications itself, as well as to data and libraries, materials, and the likes. And I think one very important thing to note as well that is that Omniverse is not a software, it's not a piece of application. It's actually a framework or platform that allows you to build and extend upon. And some of you may have attended some of the sessions yesterday, as well as from some of our colleagues at Heatherwick, where you have an ability to write your own extensions or use some of the thousands of extensions already developed out there. When we talk about functions, this is exactly where we come to it in a real sort of manner, where we can go and pick a little specific function that is really well done and written for what we want to do without the overload of all the other software that sits around it, right? Because we have a format, a USD file or assembly of files that we can perform compute on top of. So here's a typical scenario, just as very entry level of how USD and Omniverse works. We have a designer here. She's doing a lobby design. She's just written it out to Omniverse. She's opening it up. The standard renderer at the lowest level is a ray tracer, just so you know. And now she's adding more USD files as sub-layers to her lobby design. Now that means that she can structure the layers in terms of priority and she can structure functions on top of each other in terms of priority, like you would do with Photoshop layers in a similar manner. She's adding some sub-USDs and she's tweaking some materials on this until she's happy with it, right? And she will now go ahead and say, well, now we have this assembly of 3 or 4 files from different formats or libraries, and we're going to go and assemble the ground floor. So she's taking that assembly of files, placing it down, and then including from other designers assemblies of their files to make up the ground floor. And those could be done in any application, Blender, SketchUp, Revit, however you want to choose it, right? It could be from a consultant, it could be from your own team, a team across the waters, or however the case might be. But the great thing about this is she's seeing her design along with all the other designs. Now, we all know Grasshopper. We know that it's a very, very good computational platform. So what we're using for Grasshopper in this instance is to determine the unit mixes for apartment to answer a brief. Another designer is doing Grasshopper functions to design facade variations, so options of facade. And here we have a Revit model with multi-other applications making up this scene that you see here, and we're loading options of the Grasshopper that we have developed. So we have 6 facade options, right? And one of the functions of USD is to have variants, and we have the ability to live swap. This is real time variants from Grasshopper. And if the designer of the facade does a change and we do a live swap, we will see that change happen in real time. Now take that a step further, right? And now we actually have a variant per floor, as well as for the facades, as well as for the structure of the building. And what we have here is a building configurator, right? Running live off the DCC and configured live in front of us to be able to swap our data. And because we have that, and we have the ability to extend it, Robert, one of my colleagues, have written this counter. So now we have a configurator where we can live swap apartment mixes in relation to the facades and responding to the facades and the structure that we were selecting, and have the mixes counts happening in real time. So we can sit with the client and going, well, do you prefer this facade or that facade? Do you prefer this layout of units or that layout? What does the brief require in terms of the unit mixes that we need? Can we start mixing that live as a configuration like you do with a car until we meet the brief and then instruct the designers to do the tweaks and changes of the backend? But I'll pause that a little bit, go think about that. It's quite powerful. Furthermore, we here in Rhino, and I'm using a compute function here to do my counts and my positions of my units, of my apartment units. I do not want to overload of furniture or plants or any vegetation, anything to do renderings, right? So what I'm doing here is I'm doing a swap of assets as I go from Rhino and Grasshopper into Omniverse. The interior is done inside SketchUp because the designer preferred to use SketchUp for the specific interiors of this. I'm not an interior designer, I'm a computational designer, but the interior designer is doing all these interiors. And what I'm doing, I'm live swapping the Rhino model with a SketchUp model, right? Which basically means I'm controlling SketchUp model placements with Grasshopper. I feel like I need to pause on that one again as well. So there I have the whole building swapped out, right? And I can continue to compute the placements of the units on the left until it makes up the numbers, while the interior designer is continuing to do her work on the interior and tweaking it and adjusting it, getting it ready for client reviews or marketing material or whatever the case might be, right? Again, the applications are feeding live into the USDs while I'm configuring the USDs in the way I want to put the building together. Now, here's a further level where we go and say, well, I'm running Grasshopper and Rhino at the moment. I'm looking at a shading part on the left-hand side of the building, right? My colleague in New York, I'm in London. My colleague in New York has that model of mine open with all the other models that make up that realistic scene, right? I don't need to see all that. It's not my concern. My concern is to shade the side of the building and to use the computational scripts and feed that geometry right up to the other side. Now, in New York, my colleague is actually looking at this model in real time while I'm adjusting it from London, right? So when I do a change in geometry, he sees that in real time. But he's more concerned, he's not concerned about the computation because that's not his job. He's concerned about what the building's look and overall feel will be like. So he's starting to apply overs on top of my geometry to change materials that don't affect my geometry at all or my file or anything that I'm doing. He can go and delete those deltas or we can go and merge them and replace them. So all of a sudden, my colleague in New York can go and do 3 or 4 material variations on top of the geometry that I'm doing, live feeding the geometry I'm doing on this in a sort of non-destructive way forward. And that's another great thing about USD and how it actually operates. And we're talking about the structure and layer of USD here. Of course, we have advanced render capabilities as well. We have path traces, we have iRay, and therefore we have a true light calculation. So this is that interior scene that you can see. The lights here, incidentally, are placed from Grasshopper script, and the models come from SketchUp and Rhino, all combined together. And we have a light simulation with multi-files together. We don't need to get it into one software to do that. Now, my colleague in New York decided to have a review with my colleague in San Francisco. So on the left, on the big screen, is my colleague in New York doing the changeovers of the variations of the facade, while my colleague in San Francisco is streaming that live to a tablet. So he's placed the model in front of him as an AR model, looking through a tablet and walking around the model in a very intuitive manner. Remember when we talk about the experience of what we compute and how we can interface with that? In this case, we're picking a tablet as an AR device. There's no optimization happening here. If I do a change in Grasshopper, that'll reflect in the New York model that's being controlled, as well as the model that's being streamed to San Francisco, right? So there's no decimation or optimization or baking or anything, right? And that allows the reviewer or the person that wants to make the decisions to have a sort of very intuitive interface or experience of the building. We keep saying experience here, to understand and to experience the changes and the effect of the changes and how they feel about that and what is the best solutions that they need to pick or further develop and take on. Now, bear in mind, model generated in London, controlled through New York, reviewed through a tablet in AR in San Francisco in real time. Right. Of course, analysis is quite important. So we're running a very simplified generative script with daylight hours on the adjacent plots, and we're feeding that animation from Grasshopper directly into Omniverse. So we can kind of scrub Omniverse and look at the various building shapes and orientations and what the performance of those are. We can, of course, also go and overlay all the diagrammatic data on a realistic model. So we're not looking at this as an Arctic or a pure simplified render. We can actually see it as a full experience model that we can again stream or do whatever we want to be doing with it. as well as some of the advanced compute functions that we can lay on top of that, like the CFD and furthermore. And I'll go a little bit into that because it is a more complex interface. So when we talk about compute and moving compute slightly away, we've been developing an interface with a cloud-based compute application called SimScale. So we can actually take multi-applications, feed it into a USD or a USD assembly, push that to the cloud, have someone in the workbench there do advanced CFD compute and feed it back into Omniverse. What we're doing here is we're bypassing that last process because we want to do some more post-processing on the CFD in ParaView, and we have a live ParaView connector. So as the engineer is updating the review and the methods of visualizing the CFD, so is the designer simply seeing and feeding that data into this live model. Now, we're not feeding the CFD into a block or a simplified model here. We're feeding the CFD into a full detailed model made up of City Engine, of Revit models, of Grasshopper models, Rhino, SketchUp models, and the like. So we're getting the full experience of what this wind is actually doing to our detailed design. So we can start making decisions about where we should have air intakes for natural ventilation, where we should have maybe some energy capturing through wind, or where we should do some diffusion or banking of wind and so forth to allow that restaurant outdoor area to experience the waterfront in this case in a better way. And again, this is the point where we take scientific and engineering data and we're trying to make it an experience for those who actually need to understand and make decisions in the building. And it comes down to the point of we want to feed, and we are working hard to feed any application in to bring it all together in one synchronous space so that the designers and the reviewers and the stakeholders and the operators can actually understand the impact of their decisions and what they're doing with their buildings. Just a very quick note here. Some of the applications we have bidirectionality, and I'm running slightly over time here. This is just showing you that you can actually use 3ds Max and Omniverse Create, and you can pick any application and work in any one of them, and they'll feed across, right? And then just to cap up here, this is just showing you a handful of the applications that we've used on that project. And we're showing you those with various versions of Create as well, where the users are using those applications singularly or collectively together as they want to. But it really brings down that fact that you choose the application that is best suited for your preference and for your need and for your tasks, and then put it into this agnostic format, this open format for everybody to collaborate and compute upon. Again, just a quick little list of applications we've actively used in this project. There's an incredible amount of information, out there. Please go and dig around on it. This is my email address. Maybe Robert and Sebastian, if you're in the audience, maybe just raise your hand so people can reach out to you. Two of my colleagues from the team members are there in person, and go and discuss, grab a coffee with them, go discuss further with them as well. And please go to the Omniverse AECO page for any more information. I know there was a mouthful. There's a lot I try to get across here. But yeah, thank you.
Amazing. Thank you, Cobus.
Yeah, I can take questions if there's time. Otherwise,
a bit of a roundtable discussion. So I'd like to invite the presenters up in front. We have, I hope Sanne is still on the line. Cobus, if you want to stay on.
Yeah.
My head is buzzing from this first section already, so I'll have quite a few questions and comments. I might start with that, and then we'll open it up to the floor for some other questions here. Don't be shy, Omid. Silla, we have chairs here. Feel free, sit down, so that the people at home can see it as well. There's no specific order. Sure. Great, thank you. Thanks. First of all, thank you for the excellent presentations. I think it was a really nice spread of, all sorts of insights. But actually, what I always find most exciting with this whole AECtech symposium is that we don't actually set any fixed program or a big topic as asked to the presenters, but you do see a lot of cross links and overlaps, and I want to touch on a few there actually, which I thought were quite interesting, both at Sanne, but also actually Michael and Emilio finished with the DALL-E and the Mid-Journey images, let's say, and what we've in Core Studio with Omid and Sila are doing with the Core AI. So my first question would be, I think, mainly to Sanne first, but feel free to jump in the others as well. Really thinking about the data and how that becomes a tool, really a collaborator of the design actually. How can we push that another step forward? Can we use the machine learning and AI actually to maybe predict things or maybe read patterns? I don't know if you have any, Sanne, if you have any thoughts about that.
Yes, it's actually something that really fascinates us. We actually just had an exhibition in the Netherlands Architecture Institute showcasing our archives, our first 400 projects. And we all know this, that during our daily work, we generate a lot of data. And the question is that we're asking ourselves is, can we learn from ourselves, learn from our own data, analyze all of our own projects from the first one on, and try if we can do any forecasting through backcasting. So that is definitely something that we are looking at, we're exploring to see if we can learn from ourselves and how that can help us further evolve and develop our projects.
Is this working? Yeah. I think I'd add to what Sanne is saying, because one of the tools that we showed on that slide, the easy button as we call it, was an initial look at all of our projects in our different market sectors. And we were trying to pull out as much data as we could to inform design on other projects that were similar. To me, the difficulty is getting designers to engage that data. I mean, we were able to extract it. And if you were starting a new conference center, we could actually apply that against 25 to 30 other conference centers we've done before, look at a program mix, and even generate different programmatic layouts. And many of them did not want to engage that process. So I think a part of it is getting the cultural shift to designers to understand that data and these different machine learning and AI tools can actually help inform design decisions and or validate them. Do you want to add?
Cool, thank you. Omid, Sila, perhaps, or any ideas?
Well, something about this data and machine learning process that has been very exciting for Core Studio, I would say, is we deal with two different types of data. One is like organic data, which is what our company has built over several decades, which has a lot of value. Several hours has been put on designing every beam and column and structure. But what we also like to explore at our team is synthetic data. So with the power of digital twin, you saw some great examples with NVIDIA Omniverse. We also try the same approach and explore places in the multidimensional design space with help of the new cloud computing services that maybe a single engineer, no matter how many years of experience they have, they cannot. So I'm not saying the organic data and the synthetic data, you should pick one, but I feel that for our industry, in structural design at least, a combination of two can be a very powerful thing for machine learning applications.
Jeroen, can I just add a note there? I think that's very, very valid. I think there's a difference between generating data, synthetic data, and segmentation of data to train, like we see with autonomous vehicles and likes. But we actually have some clients asking us to incorporate human behavior real human behavior into virtual human behavior to be able to predict how people will start using the spaces that they actually design. And I think that's an interesting space going forward in terms of machine learning space. And for that, you need this kind of a direct simulation of what the real world would do, but before you build it, right? So yeah, absolutely. This is very much a blend between the two, very much a blend between the two. I think that's going to inform it.
Yeah, I mean, I would like to add that we are also learning continuously from data. Like we are using ML model and we are feeding the data, like feeding the model with our current data, current experience. So like our data increases and it also helps us to do this continuous learning process.
Great, thank you. And then the other thing I was seeing is still data and information, but bridging towards Chris and perhaps Cobus as well, actually, to your point, like how do we reduce the risk and cost and safety? It's actually just knowing things, let's say, right? Like embedding that. And it's great to see all of the efforts you've been doing with all the digital tools as well. Still, I'm thinking, do we need an overarching thing? And then thinking about Omniverse, could an environment like that be the correct place? Again, then the question also comes, who actually owns that model or who curates it? Should that be the client, owner, developer, or should that be the design team? Not sure if you have any ideas on that.
Well, I mean, very interesting. It's obviously the ownership of the data itself becomes a challenge, you know, in general, because a lot of that data that we've generated, for example, is hard-earned, you know, through a lot of blood, sweat, and tears we've been through a lot. It's cost us a lot of money to encounter those problems. And so our ability to share that data has to be through a process that is mutually beneficial for all of us. We do have a philosophy, though, that if we can do better, for example, in solving for those problems early during the design process, it makes us all as a team, the best projects are those that everyone wins financially in the end, as well as creating great projects. So to the extent that we can set up processes that enable us all to be successful, and we can share that data in a way that has those tangible benefits, that makes a big difference for us. Obviously, our ability to have a mechanism by which we can all interface with the various tools that we all use during the process is critical, and of course is up till recently been a large stumbling block for all of us. But I mean, we're getting there, right? It's exciting.
Good, exciting. And then the last bridge I wanted to make with that I noticed, and then we might open it up for questions in the room, is I think the notion of Michael and Emilio in terms of the geometry and is it a new way of setting out, or are we rationalizing crazy curved geometry? Like, is there a refined way to put that back into design in a way? And as well, to your comment that you were mentioning of actually reviewing and QA/QC, or have leadership looking over the shoulder and changing things. I think that also brings us back to Ellipse, and where we were also coming from, where the 3D models are getting crazier and crazier, but senior people in the firm still might not actually be that native in 3D. Right. I guess the 2D drawing dead, yes or no? Perhaps it's not. There's probably still a place for it, and we hope to bridge that part as well with Ellipse, let's say.
We hope that we will evolve to that point where the 2D dies a little bit and goes more to 3D, but the reality is things have to be kind of redrawn and constructed on the manufacturing side. So in the end, all our designs has to be created and brought into fruition to the real world. So really, we have to always play this game of rationalizing the design, but also satisfying the design intent. So that we will always have that scenario where we're going to have designers hovering over us, but also maintain a kind of communication with manufacturers and contractors in order to get these things real.
Or do we need to change the contractors and fabricators?
Well, yeah.
Educate them.
Well, and I think, yeah, there's two things addressing there. That senior level design leadership, they look at what's constructible, or, you know, when it comes to efficiency of construction, they're going to tend to shy away from the curvilinear forms and the more complex forms that can be created with these tools nowadays. So I think when the industry shift changes where we're able to mass produce more shapes in an efficient manner that it can be comparable to things that are more rectilinear, there's an openness at senior levels to accept, you know, those challenging and more complex designs. But I think too, where you were going, Ewan, with the point of ellipses or ellipse, is that I think where we run into problems in our workflows is that most of our senior designers, except for a couple, don't use digital tools. And the one that does primarily is working mostly in SketchUp. So seeing that now the interoperability issue is not really an issue when you look at Omniverse and other tools that are coming out, and even Ellipse, to move things together in one environment, we still have a disconnect from design review and evaluation. And to that point, I think where we're going is maybe there is a more universal place that the design model and even sketches can live, and maybe certain tools that can go from hand to 3D models soon, you know, start to become more prevalent. The key is, again, back to kind of my earlier point about getting our designers to be more open to embracing those things and putting the time in to develop new habits and new processes. So that's the biggest challenge, but the tools are there. The experience design-wise can be creative with all the things that we have in place and the things that we've been talking about as a core group.
Just briefly to the 2D drawings, I'd say I've been ice skating up that hill for a long time and decided maybe it's not the right hill to climb. And I'd say the evolution on that thought process is not to try to shift the industry when it's appropriate away from a direction or another, but instead to try to maintain that data and information parity as much as possible. So, you know, whether the appropriate medium is 2D and 3D and, you know, background in architecture as well, it's talking to the fabricators or the constructors, whoever it is first, like, what do you need? What do you want? And then let's not deliver things you don't need. You know, that to me, one of the big points of discussion that's come out in Ellipse quite a bit is how much of the kind of annotation or informational level that's static and refined can actually be moved to a digital medium to augment the drawings themselves. So the drawings can be about design clarity and basically communicating intent, but the actual information, whether it's a dimension or a spec or, you know, the source of something, can that be moved to something that's live and connected so that as you develop things over time, if you have a sketch from the beginning of the process, could it still relate to where that ended up in the final design rather than trying to completely supplant one part of the process or the other?
But David, I have a help there as well. We can actually, which is interesting enough, we can actually from Revit publish the Revit models with drawing sets, and they actually come up in location in 3D in Omniverse. So you can have a full visual model with a Revit drawing sitting in its space. So while you understand what it's going to look like in real life, you can actually also interrogate the detail and everything like that has been documented in Revit. And that's where we start getting into this hybrid world. We still need those drawings, I think, for the years to come, but the understanding and the decision making and moving forward is what we want to get to, that experience level. So, and that includes, like you said, sketches and 2D as well as the full 3D.
Great, awesome. Any questions in the room, perhaps? We have 2 roving microphones, so perhaps wait for that so that the audience online can listen in as well. Hi.
So this is a question, I guess, primarily for Suffolk, but maybe for everybody out there. It seems like the vast majority of the data sources we have in the industry are manually generated. Not just manually generated, but they're very laborious to generate. It takes hours and hours for use an estimate, schedule. So I guess I have 2 questions. The first is, does that reliance on manually generated data, is that a fundamental bottleneck, maybe keeping us from getting to using all of the kind of tools that require a lot of volume? And then the second part would be, what can we do to get around?
Yeah, so you are right that a lot of the data we are generating today is, as I said, painstakingly extracted. It has to do with the accuracy of the person writing. For example, if we just were to take the example of RFIs, right, which are could conceivably be a great data source for understanding where problems lie in our projects that we can then focus on to better execute during the design phase that will improve our overall process. That depends on the ability of a project engineer who's just out of school to have written a good RFI in good syntax that also is attached to particular sets of data and metadata associated along with that, so that we can extract it and make it more useful. And so one of the things that we've been talking about a lot of is how do we not make it just an SOP around how to write an RFI, but actually make the writing of the RFI itself more intuitive, so that the mere virtue of issuing that as a particular question requires the inclusion of particular amounts of information, of data in that process. It's still largely manual. Our processes in the field that we are generating, whether they be cost estimates or what you're seeing is a fragmented industry, right? With subcontractors galore all around, with various people in the field and various trade partners, and then our own design partners all working together. It is a fragmented process. So to the extent that we can create mechanisms that are more intuitive and not painstaking to capture that information in a way that is organized upfront, we've found that that is probably our best vehicle for creating clean data without having to do extensive scrubbing and dubious natural language processing tools that may or may not be as effective as we would like them to be. I think we're doing a pretty good job on the cost estimating front now. By generating a cost estimate, that information is auto sort of updated into our databases, which then makes it real and makes it live every time, right? So there are certain ways we're doing a good job of it, but we do need to keep on with that process. I think the one thing to keep in mind is that when you look at the scale of our industry, it's so vast, and literally hundreds of thousands of data points coming out of out of our projects on a yearly basis. There's a lot of data out there. It's just a matter of how do we coordinate that between all of the different trade construction partners out there so that we can collect a sufficient amount.
Any more questions right here in the middle?
Hello, thank you so much for everything. My name is Nate from Outer Labs, and Michael, you brought up a really good point about, you're making these decisions on when to use external tools and when to develop them internally. And then we have a different case in the case of Sanne, where you're actually developing internal tools, very customized. And then this other model that Core Studio has that develops, that has a whole team that's developing tech tools. So I guess my question really goes to about, are architecture firms well equipped to develop their own tools internally? And at what point do we say, have these maybe tech companies developing these tools? And what are you kind of seeing in the future there?
I would say yes and no at the start. Many firms, and a large number of people in the room work at firms where persons in, my role and other roles similar have certain budgetary constraints. And when it comes to development of the tools, many of us can see what might be the right hammer for us to use at TVS versus your firm or any other firm. And the question is it feasible for us to explore the development of it? Because that means that we've got to bring in an entirety of a development team and other application specialists to create it. If we can find a means to quickly patch an API and tie things together, then that's the easiest way to create that tool with limited budget outlay. So to your point, when I say yes and no, it varies because whatever it is that you're addressing that you might need or you see a need for in your firm, the landscape is changing so much now that as soon as you start to explore, get the budget together, get the resources connected to make this thing, you find out that there are one or two other things out there being developed that are parallel to, what it is you're looking for. It may not be the exact same thing that you need, but, it means that being aware that it's there, I might be able to take that and add to that and spend less development time and money to get it. So it's a yes and no question in that, depending on the infrastructure, as far as the firm's concerned that we're looking at, the budgetary constraints, the resources you have in place, like for us, we're limited. We don't have anyone on staff that's directly set as a programmer that could help us with development. So we have to go outside. We have to find the partnership, externally to do those things. There's a very finite amount of things that he and I can create by ourselves. So it's tough, but I think what we're seeing is that, from the old days of the idea of just open source and who could connect to what and reuse pieces and components of software, there's so many different tools, like what's coming out of Core, what's coming out of Omniverse that, like right now, I know that in my strategic plan for the last 5 years, there were some things we were supposed to develop that we stopped because now I see a better way to do it with the means and, what little methods we have internally to connect and create it. What Corbus showed us is an idea of a design portal that we have been talking about developing for years. And, the cost to do it, to tie Revit, Rhino, SketchUp into one environment for design analysis and review, if we had expended that, I might lose my job because, as soon as our board finds out that there's another tool that we could get that universally does all of what we put all that money into, it's tough. So to your point, I think it varies across the industry as far as what can be developed. And then, those of us that are in leadership roles to determine how to outlay the budget and time to create internally, as well as what can we patch and pull together from the universe of AEC that might give us the tools we need. I'm finding that patchwork approach is just more effective for us. That makes sense.
Yeah, just quickly to build on that, I think there's a real opportunity within there to bring the domain expertise into these types of platforms. So as things like Omniverse and these other systems come out that are looking for modules, to plug in, what you're good at and what you can actually bring, I think it's an opportunity for any AEC firm to think about it not as a loss leader but a revenue generator. Like, can you actually turn some of that knowledge itself into value directly and begin to contribute that to the larger community?
Yeah, maybe to add to that, it's of course also a question of scalability. And you can't expect a small office to have their own R&D tech hub or unit within an office. However, we do see that specifically in our firm, our buildings are really as much projects as they are research projects. And therefore, we also have the need to build these hyper-specific tools that are all trained and built to solve a specific challenge. On the other hand, of course, we see the need for scalability of certain tools, and that together with, let's say, the current discourse of what we are teaching students in universities, there is a momentum to start exploring what are indeed the deliverables of the future, like with Omniverse, what are the collaboration models of the future, and how can we better equip architects with the skills they need to have. And I think you also said it before, 2D is probably going to end, but what are the skills that we need to develop in the future so we can become capable of building our own tools in order to realize our projects? So I think there is definitely a transition going on And we, at least as architects, need to start developing a curiosity towards custom tooling and strategic use of tools.
Excellent. On that note, I think we should break for coffee, because otherwise we're squeezing that too short. I'm sure there's many other questions. Let's discuss them over coffee, and we'll be back at 10 to 12. Thank you very much. So we're really excited to have this next panel discussion, machine learning and practice. So I think we have a good group of cross-section of the whole industry. Dan Reynolds leading the panel, posting a few poignant questions, I hope. Dan has been bickering around with AI for quite a few years now. He's the AI product lead at Walter P. Moore. Many years ago, actually, Core Studio member as well. Maybe even starting the whole things that Omid and Sila were showing earlier. So yeah, very pleased to have you present the panel. We have Onur online, Martha, Sergey, and Pablo here. Brian in the room as well from NVIDIA. He's on the roster, let's say. Anyway, without further ado, Dan, I'll let you introduce the rest. Thank you very much.
Thanks for having me. I'm sensing a theme to this symposium, machine learning and data being pervasive. So where do we start? Lots to talk about, and I think a lot probably was touched on earlier. So maybe we can add to that conversation. Let's start maybe with the panelists just introducing themselves so we all know who you are.
I'm Martha from Foster & Partners. From Foster & Partners. Okay.
I'm Pablo Zamorano from Heatherwick Studio in London.
Hi, I'm Sergey Pigach from Core Studio.
Hello, this is Onur Yücegün from New Balance.
Okay, can you talk a little bit about what you're doing with machine learning? And is it maybe more on the research side, or are you able to operationalize it in your firms?
Okay, I'll start. So we are we're at the moment where we are exploring it. We are lucky to have a small group of people in the studio that can do a bit of research, and we've been engaging with the technology for some time and trying to test it from the design perspective. What is been kind of key for us, it's been trying to kind of implement our key design values and try to find the usefulness of these tools to kind of implement them across the studio and our projects.
Yeah, I guess at Core, we've been playing around with AI for a while now. I mean, Dan remembers, he was there. And I think we're coming to a point where we can actually start to use those tools in production, so to speak, or at least to automate and accelerate certain repetitive tasks that will hopefully make us more efficient. And that's one main focus of research. This is what Core AI is currently focusing on, developing microservices and micro apps for specific engineering tasks that need to be regularly performed. On the other hand, we've been looking into DevOps, the DevOps side of things, kind of the plumbing that goes behind, running more complex AI-enabled projects so that everything is streamlined and we have transparency and we can kind of put together much more complex applications and run them smoothly.
We have been using machine learning in different domains. So we started with surrogate models. So we have a known problem. Can we find the solution faster? We're creating small applications for that can be used directly through the office based on generative data that we create. We have been exploring quite a lot the use of machine learning as a design assist model. Most recently, particularly with diffusion models. We have been doing quite a lot of things in a more office-wide scale. So we have been investigating the use on NLPs for search engines within the office to facilitate transfer of knowledge. We are 1,800 people, so now that becomes even more pertinent. And finally, we have been developing quite a few applications around business insights in terms of what we're doing on a board level and how using a machine learning and statistical methods can help us kind of get some insights of what we can do better, what we should be exploring, etc.
Yeah, for us, hello everyone. Again, sorry I wasn't able to be there, but yeah, great panel. I'm pretty happy to be here, first of all. It's a good question, and I think like you know, the application comes with research, and the research has to be there because I think this is a time which is very reminiscent of, let's say, when you know, parametric design tools started picking up and people were trying to kind of like employ that. So at that time I was in architecture in the construction industry. Now I'm you know, working for a footwear company. And again, you know, when you look into such a company, the application area is really broad, maybe too broad, because we have designers. So you know, whatever you can think of about design, you know, make it like pattern recognition, creating, you know, inspirational images, which is done by everybody now, or you know, trying to kind of like, let's say, understand the styles that we have been developing in the past, right? So that's the design side. But then we have, you know, data analytics, which goes to the consumer side, because, you know, you produce a consumer product and then you get feedback from them. And that feedback goes to, you know, like it has so many data points, right? So you have, let's say, the fit, you have the color, you have the likes, you have the dislikes, and so on and so forth. So the question is, how can you get this from all around the world and reflect back to the product is another question. The third one is about sports research lab we have at New Balance, through which we collect a lot of data, right? So we create custom solutions for our athletes, but at the same time, we try to kind of like, you know, create better working products for everyone, because you cannot fully customize everything for everybody, right? So again, there needs to be some sort of automation. There needs to be some way to kind of like interpret the huge amount of data. Maybe the fourth one that I can mention is, of course, about manufacturing, right? So because we create consumer goods, we have to deal with materials. We are really conscious about the materials we use, the scrap material we create. We need to be as sustainable as possible, you know, and as efficient as possible. So, you know, it's a long answer, but again, I think it's a pretty exciting time to look into all these problems, apply whatever we can for now, but also look for the opportunities for near future.
And okay, so there's this sort of a cross section, I guess, between research and production. What sort of sources of data are you using, and does your firm have a overall data strategy, and particularly about maybe how it grows and how you govern that?
That's a very interesting question, actually, because we found out we are a 50-year-old company and we have a lot of data, and it's actually very, very hard to use that data as is, because in order to retrieve it, put it in a format that can be readable, tag it, augment it, et cetera, that process alone takes 90% of the time that it takes to create a training system, right? So creating a machine learning model right now to train for anything, for a single surrogate model, is actually very simple. Things are out there, you can just use it, but the data itself, to get it, to gather it within the company is very difficult. And that's why we found that for a lot of things that we're doing, we're actually creating generative data sets that become a much more easier proposition to do things very fast, kind of create a proof of concept and then move on. Having a big strategy around data on an office scale can be quite challenging, particularly when you're a global office like we are, and I guess that this is true for many people in this room. The moment you start discussing data lakes and where the data lies, how you can retrieve it back, some of that data is in cold storage, some of that data is live, it becomes in and of itself a problem, a huge problem. And I feel that unlike other industries, this is where machine learning is held back in our industry because the data as it stands is not in the right format and it's so dispersed through different typologies, untagged, random, that makes everything almost an impossibility unless you're kind of really keen.
Yeah, actually, I think that we're pretty much in the same boat because, lucky for us, we're an engineering firm, which means that a lot of the problems that we're trying to solve are very well defined. And for the most part, those problems have right verifiable answers. So instead of trying to, go through the horrors of, scraping Revit files off of our P drive, because again, Thornton Tomasetti has been around for a long time, and we do have a lot of projects, and we do have tons and tons of what one would consider data, which really isn't, because it's really hard to extract this out of the sedimentary layers of projects information that's been accumulating over the years into something usable. So what we've been doing for the most part is we've been writing our own solvers and exporting synthetic data sets, which allows us to have very good coverage. Again, from a structural perspective, most buildings don't vary as much as they could, right? So you would have a lot of data in particular areas of the data set and then just gaps on the extremes or in some particular regions. And also we can generate as much data as we need. So we found this to be very useful and very helpful.
I mean, so I think we're closer to Martha's case in this case, although we're a much smaller firm. In the way we're doing it at the moment, we're just trying to kind of restart our process of retagging all the information we have. And what has been quite interesting for us, because we work not only, let's say, with information that comes from kind of 3D models or images from projects or renderings, this is quite tied to what happens in kind of the makings of what we do and kind of our physical archive. And as we are trying to digitize that information, now we're trying to use the opportunity to actually merge the information we have as one and trying to kind of retag everything. But it's a process that we're starting from scratch now.
Thanks. Owner, before we go to you, I just want to introduce Brian from NVIDIA. Give you a chance to introduce yourself.
Hello, everyone. Brian Pertall from NVIDIA, senior data scientist. I actually had a chance to attend this the hackathon for the AECtech group a few years back, and it's great to be back again and be able to participate in this panel today.
Great, welcome. Good to have you. Just to catch you up to speed, the question we were just asking was about data strategy. So owner, I'll give you a chance to answer, but we were asking if your firms had an overall data strategy and what sort of sources you use.
Yeah, I'd say it's in the making for us, because interestingly, New Balance it's a cultural thing. I would say it's this 8,000 employee company, and the design and like technical stuff is a very, very, very small portion of that. And shoes are very conventional things that to make. If you look at the cutting edge stuff, it's maybe 1 in 10,000. Like 0.01% of what is being done in the industry. So, but as we move forward, I think what's interesting is that again with all this AI and ML stuff has been cooking for a long while. Actually, what is interesting about last 5 years is finally we are kind of like seeing these tools in fruition. They are becoming like mature. So the nice thing is also, I think, like again, because, it's fast to make shoes, they change all the time. The data collection methods change all the time. Now we have to adapt, right? So we have to find the right solutions. But the nice thing is, again, maybe I can refer back to Sports Research Lab. We have, we are looking into new ways of collecting data immediately because there's a new tool that is going to, enable us to look into the problem or reshape the problem in a different way and find, again, new or novel solution. And so the short answer is we don't have, at least for design, we have IT, we have consumer insights and so on. So those are like different studies. I cannot talk on their behalf. For design, it's in the making, I would say.
Great. A few of you mentioned that we're essentially building on the shoulders of giants. Machine learning has been around for over 50 years. And I think in more other industries first, but we're seeing a lot of momentum these days. So especially with, it was mentioned before, but the Midjourney and DALL-E, and I used to think that machine learning wouldn't get to the creative space. And so now that we sort of see that it has, even in a very maybe premature sense, is this an opportunity or a threat? And what will this do to the future of design?
I think to a degree, any powerful technology is both an opportunity and a threat. And right now, I understand the creative professionals who are unsettled by the fact that, the foundational belief that members of so-called creative class can't be automated out of their jobs is being shaken by things like diffusion models. But in the meantime, I don't think that Midjourney or DALL-E or Stable Diffusion constitute a radical departure from where things have been going for a long time. If you guys remember the original Jurassic Park, there's a scene where they explain that raptors always hunt in pairs, and there's one raptor that stares you in the face and distracts you while the other one attacks from the side. I think for me, like machine learning and the advancements of AI, they're kind of like this raptor that's staring you in the face, and everybody's looking at it because, it's there and it's very loud and obvious, and it produces very spectacular results that are hard to ignore. But the proverbial smart girl who's attacking you from the side is literally everything else that's been happening in the domain of computation and automation for the past, 20 years. And if we're asking ourselves the question like, okay, can a designer as a professional be automated out of their job? We have to define what a designer is. And you can ask 10 people what makes a good designer, you'll get 11 answers, but I think the answers could be roughly clustered into two big categories. On the one hand, you have a designer as a problem solver, a person who just finds solutions to well-defined problems. On the other hand, you have a designer as a poet. And I guess the argument for a long time was that we'll never have a technology that can automate the poet. Unfortunately, you don't need the poet to make a competent building. And 99% of buildings that are being built today are competent. They're not outstanding. They stand up. They don't leak. They maybe are even environmentally efficient. And that's good enough for most developers who pay money to build those buildings. Those aren't the buildings that we read about or talk about because we don't find them interesting, but that's most of what's being built. And my projection in the long term is that we'll see kind of this Pareto distribution taking place where the middle evaporates and we no longer have architects designing, let's say, mundane buildings, or the majority of the buildings configurators that can do it 80% as well for 1% of the cost. And the majority of top firms will just work on the 1% of high-end kind of specialty projects, which I know is grim, but
I'm so tired of this question. It's like it's non-mending, like always that question arises, and it's like, my answer is maybe yes, so what, right? When I was in university, like I did most of my classes with a rapidograph, and I've been told computers will never pick up because, you know, doing it by hand is a completely different thing. Now, I don't look that old, but I am. And then I left and, well, know what happened there. After that, I said, I'm going to do computational design, parametric design. And they were telling me, this is nonsense. Nobody's going, like, this is not going to catch up because a true designer is a true designer who sits there and design. And we all know how this ends up kind of wrapping up. And now everything's about machine learning. Oh, we're going to be kind of taken out of the equation. Okay, take me out of the equation. I don't mind, you know, things may go there. It's fine. It's absolutely fine. You know, these things come and other opportunities arise. And I think the problem is that now we're trying to see how we're going to remain in the equation. And unless we decide to see where we're going to be when we're out of the equation, what is the next thing that we're going to be doing? How is these things going to drive our creativity? New opportunities, new positions. Nowadays, there are positions out there in the industry that never existed, not even 10 years ago. So I think it's just a bit childish to always kind of see these things with fear. It's not about acceptance, it's about vision. And I think we're lacking the vision. We have like tunnel vision in terms of where we think our role is. And our role is ever changing. Creativity is ever changing. If a robot comes and takes my job, fine, I'll sit on a beach and I'll do something else. I find something more creative to do.
And you say that, well, an AI is translating you behind you, you know, doing a speech recognition. I mean, you know, it's just that it's obviously here and it's going to stay, you know, and I don't think there's any point in being scared, you know, by it. I think, you know, I've got an 8-year-old and, you know, she's designing stuff already, you know, and, you know, the games that she plays, you know, either it's Roblox or whatever, you know, and AI is here, you know, it's just, or all these kind of diffusion models, you know, are just proving to be very intuitive ways of interacting with you know, a new technology and a new platform. So I'm particularly really excited about what can come out of this, you know, these new kind of platforms, you know, and tools. And I think, you know, in a way, our role, you know, as long as we can, you know, it's to explore them and find new opportunities. You know, I don't think we're either problem solvers, you know, or poets. I think our role is more often than not to actually come with the problems as well that we want to solve, and find the next kind of type of problems is always going to be an open job, you know, and controlling and using these platforms, I think is just a great way of doing it. You know, I'm quite excited about
just that. Also, that one thing to say is that, like, the machine learning this is the third wave of the machine learning evolution, right? This has been happening, as you said, for 50 years, and every 10, 15 years we get overexcited. Oh, this thing is coming, like robots are going to, and then nothing. And then something changes again, and then nothing. So I will not hold my breath about somebody taking your job. All I'm saying is, like, look to the future.
Okay, I will jump in. Somebody's looking at me, you know, like Pablo just looked at me, so I'm going to jump in here. I think, yeah, the machine learning, I'm going to increase your 50 years to 90 years, actually. And then I'm going to give an example, which is, again, reminiscent of the parametric design madness that happened 15 to 20 years ago. Exactly 15 years ago, I was at that, you know, desk kind of like presenting, and Robert Otani was there, and I was presenting 2 buildings that we designed at KPF by using parametric design. The question was, are we going to use parametric design for everything? Are the computer going to generate everything, and then we're going to become creators? We are not designers anymore, and so on and so forth. Okay, and I think there was a lot of leverage. There is still leverage. I never liked it, and I used parametric design to the bone, scripting to the bone, but I was always kind of like kept my distance too, because it was, I think we created a lot of noise too, right? So maybe if I take anything that is designed using parametric design and all the models that has been generated, maybe 1% or 5% is good. It's like art, right? So humans, we just do lots of stuff, only 5% of is good, 95% is noise. So the good thing now happening is, it's happening so fast, I'm so happy, right? So Midjourney, because if text-to-image tools were as slow as parametric design, if they required such high skills, this would take another 10, 15 years to people to get over it. And then, we would be swimming in this, muddy water for a long time. So now, all of us can sit in front of Midjourney. You type sharp, shiny, octane render shoe. We all design amazing shoes, right? So if it is designing. So the beautiful thing is we are all posting, like buildings, shoes, this and that, cars. I mean, this is just noise, right? So what we need to do, I'm telling this to you now. So earlier we realized this, it's going to get to a better place. And I agree with Marta 100%. So about the question. So I think the last thing that I would like to add is like, I think it's none. It's not. I mean, it's just a tool, right? So I don't want to highlight it as a threat or an opportunity. It's just another thing that appears in time, and the human values will remain the same. We will always want to be healthy. We want to make good things. We want to, and so on and so forth, right? So go back, like, I don't know, 200 years ago, 100 years ago, when people invented like steam-powered engines and then, gas-operated engines, and so it's same thing. Right, horses being replaced, the horse carrier driver being replaced, and so on and so forth. So the first image that I created with Midjourney was AI bandwagon, and I posted it on LinkedIn saying, okay, I created a huge bandwagon so all of us can hop into that, right? So that's like and it was again a replication of the parametric design era. This is nothing to say demean anything about text-to-image stuff. I think it's amazing. I think it's wonderful. I love doing it. I do it every day, right? But the question is, as Marta said, it's like, so what? So some people will answer by creating noise. Some people will look into that so what question, which is the 5%, and will dedicate their time to answer that 5%. So I think interesting thing will emerge from that 5%. So that's my take.
I'll jump in here. So I know the appearance of this, DALL-E 2 and whatnot seems quite shocking, but just like Onar was saying, I've been watching this grow since its introduction for deep learning on GPUs in 2009. So neural graphics has been around for quite a while, and this is just not so new, but it is evolving very quickly. But you do have to work with it. It is an art form. So, just like in programming, junk in equals junk out. You have to start working with these tools and learn how to use them. And a lot of the tools like DALL-E from OpenAI, now allow you to work with interactive labs. But the first time you use it, you're not going to get what you want. It is, basically, language phrases that are very descriptive of the scene that you want to generate and in the style that you want to generate it. But it definitely has a syntax. And as far as artist input, you may not be aware, but there's a lot of what they call one-shot or zero-shot learners that will take your artwork as input, your 2D sketches, and use them as additional inputs into these neural graphics primitives, and then use that input or your personal style to flavor the outputs to be more in your own art form, artworks, I should say. So this is going to be a burgeoning field, and there's going to be a lot of green grass for folks that are sitting in seminars like this one today. So I would suggest let's all go out and start using the technology and see how it helps our everyday job. It's by no means going to be able to replace people. It's just going to be an assistant.
I think we're running out of time, so I want one more question. It seems that, and many of you sort of touched on this, but machine learning isn't something that's scary. It's not something that's super revolutionary even. And in many ways, we're a lot like machine learning algorithms. We view the world, we interpret what we see, and we build on that data. So my question is, will technology just accentuate our own abilities and weaknesses, or can we use this technology to create better versions of ourselves?
It's funny that you say we are like machine learning algorithms, where actually they were built to be like us. So I think that in and of itself should answer your question, right? These are relationships that kind of are bidirectional. As with everything in this life, you can use technology for good purposes and you can use it for bad purposes. So it can make you better or it can make you horrible. And that's true for everything. So I think if we're now talking about machine learning because it's the flavor of the day and everybody is excited and amazed by it. But if you think that same question kind of is true for every single technology in our industry and any other industry. So at the end of the day, it's up to us to use it for good rather than for bad. And I'm sure, like, given human nature, most of us will use it for bad, but that's okay. That's what human nature does, and that's who we are. And
yeah, I want to echo that. I don't know whether we'll be able to use AI to make things better or worse. One thing I can guarantee that we will push this technology to its breaking point, just because as a species, we have a pretty abysmal track record in terms of exercising any sort of restraint when it comes to a powerful technology that falls into our hands. But I think generally, technology tends to take on a life of its own, and it's kind of futile to try to stand in the way of the steaming locomotive that is a technological process. Doesn't generally work out well. And they tried burning factories back in the Industrial Revolution that didn't get them very far. So the technology will evolve, and it's not a question of whether or not we will be, like, we don't decide how we're going to use this technology. The technology will kind of just evolve on its own, and we'll be forced to figure out how to live with it and how to work with it and what we can use it for. But yeah, it's gonna get weird.
Well, maybe just to pivot with one more question would be, there's a trend in other industries that have been maybe a bit more mature with machine learning over the past decade towards responsible and ethical AI. So what does that mean for architecture? And if machine learning is just a tool, then who is going to make the decisions, and how do we push as an industry towards responsible use of AI?
Well, I think it all depends on what you use it for, because as in the design industry, we love being biased, right? So having or trying to explore a language, used to be a big thing, right? So you can get more bias than that. You're writing yourself your own kind of alphabet, to design. So if you're using these new tools to do the same, then you really want them to be quite biased. And when we're training our own data sets, we're doing the exact same thing, right? So I think it's more about how you control them. And, there's always an ethical question, when you design something, because you're not designing it for yourself, but for someone else, and I think that's not going to change, much from how it is right now. These kind of new tools may give us more power, or maybe more kind of speed in the terms of how we get to the final result, maybe, or they may just give us more kind of options to get more and more and more options, in how you get to the final kind of place, but I don't think necessarily they will kind of derive much in terms of, how you engage with kind of ethical design, let's say, across the way.
But it's interesting that you use the word control, and actually with a lot of this bias is embedded bias, a bias that you have no control over. And that is something that you can do a lot of ethical kind of questioning of what's happening, but it's going to still be there. And the test that they've done with the judiciary here in the US is a very telling story, and we don't have time for me to tell you that, but go ahead and search it. Basically, the bias was against Black male men, right? So, and it was embedded, and they didn't realize it. So control is an interesting but potentially a little fraught word in this context, in my humble opinion.
May I jump in for a second? Just 2 minutes. I want to combine your last two questions, and because I want to give something really optimistic too. I used to be very pessimistic about parametric design, which is proven in my view, right? But for AI, what is interesting is I think your last question is all that question will be answered whether the big brother, controls the system or the larger population controls the system. I think that that's going to be the answer will be revealed that way. It can go anyway. One of these two ways. But what is interesting about your previous question is that, and why I'm optimistic is this. So we always, from the initiation of the Turing machine, we try to build human consciousness or human intelligence using machines. And then, in the last 10, 20 years, we always talk about, automation, machines being intelligent, solving problems, and machine learning giving you the amazing answer for optimization and so on and so forth. So we all as designers use that. And then Midjourney came and they exploded Discord in like 1 month. 1 million people started using it. Last time I checked, it was 3 million people. Now it's like tens of millions of people are using it. So it turns out the real use or the spreaded use of this technology has become, by nature, this is a point in time in humanity's, like our lifespan, where everybody is using text to, image prompts and making images. It's an interesting result to me because humans, at the end, in my mind, people picked ambiguity over precision, right? So, of course, the algorithm is trying to create more precise images, like replicate photographic images and so on and so forth. But the artwork, the images you create, embeds a lot of ambiguity in it, and we are using semantics, the words. We don't even understand each other, right? So every word means 2 different things, and the sentences mean 5 different things, and so on and so forth. So that's a big potential in my mind, right? So just people visually being engaged with this and visual ambiguity being so powerful and being explored is very interesting. I wouldn't expect, for instance, such a tool to pick up, this much and, go over the discussions of precision, efficiency, and so on and so forth. So that's interesting for me.
All right. Well, I think with that, we're out of time. Thank you so much for joining us today and giving your insights. I really enjoyed the conversation and hopefully you did as well.
Thank you, Dan.
Thanks, everyone.
Thank you. That was a great discussion indeed. Where are we? I'm going to leave it there. Time for lunch. We have our lunch boxes up here on the side. We'll be back in an hour, 1:30. Thank you very much. So the format this afternoon will be quite similar again. So we'll have 4 presentations, discussion and questions afterwards, little break, and then we go into the final roundtable discussion, and Robertani will then close the day. So next one up, we're really excited to have Pablo Zamorano amongst us and present. Pablo is head of geometry and computational design at Heatherwick in London. Here in New York, you might know them from projects like Little Island, The Vessel. And yeah, we're very excited to hear what Pablo and the studio is doing in terms of computational design. We heard about the machine learning already, so let's see. Welcome. Thank you. Thank you.
All right, thank you, Jeroen. And thank you everyone from the AECtech for having me here. It's the first time that we're actually presenting on this conference, but it was yesterday actually the first time that we also got to run one of the workshops. So it's been quite an interesting kind of a couple of days. And I'm super excited to see, what's going to happen, during this afternoon. So as Jeroen mentioned, I'm part of Heatherwick Studio. We are a London-based studio. And today I'm going to be talking about how we kind of use technology and how we engage with kind of different tools related to kind of design and making. So we have, as a studio, for the ones that are not familiar with our work, we have a quite kind of diverse portfolio. We work across kind of geographies and kind of locations, but also scales, and kind of we can design anything from kind of a bridge, to kind of larger scale transportation kind of vehicles. And we can also focus in different programs, as let's say museums, or something as small as a perfume bottle. What we really care about, it's really to create better human experiences and really places that can connect people and create emotional engagement. This is how our studio looks like in London, although I have to say that we just left this amazing space as we're moving into a new place, but you can see it's filled with kind of really interesting kind of objects and things that we keep there to kind of pick our kind of brains and give us kind of slightly kind of weird perceptions of let's say what design can be. The studio is about 240 people big at the moment. We have our main studios in London, and we only have another studio in Shanghai, which we opened just a month ago. So we still, let's say, a fairly small studio in comparison to other kind of firms that have been kind of presenting today. Although small, we do have kind of a very diverse group of people that work in the studio, and we have product designers, interior designers, industrial designers, architects, makers, filmmakers, and of course computational designers. And we always try to kind of work together, not only thinking about what can happen in terms of a sketch or on a screen, but we try to think in how design can actually hit the real world, and making for us is a crucial part of what we do. In a way, we always try to have this connection between what happens digitally and what's happened physically. The group that I have kind of the luck to work with, we call it Geometry and Computational Design, and currently looks like this. We have a smaller group of, let's say, specialists that kind of have the luck of working not only on projects, let's say normal projects or architectural projects, let's say, but also to focus on applied research projects. And they get some of their time kind of allocated to explore kind of farther really, really interesting ideas and technologies. But we also have a group of people, of designers that may have, let's say, a particular interest in complexity or a better understanding of it, and also kind of a high level of skills of computation. And they, in a way, lead these kind of complex areas of different projects across the projects that we have in the studio. The main three areas we focus on are, geometry primarily, then where we kind of, do advanced modeling, optioneering generally, rationalization, analysis, and a lot of prototyping. But then we do have, the opportunity to do applied research, where we take some of these ideas further and we try to not only talk or research about one specific project, but more than that, thinking about solutions that can, in a way, help across different projects and even beyond, at some point, beyond the studio. And we do still do a fair amount of knowledge sharing, through kind of talks and workshops and trainings that we do internally and externally. So let's say in terms of geometry, I think maybe a good example of this will be Little Island, that some of you may be familiar as is located, here in New York. For the people that hasn't had kind of the chance to look at it, I think go and have a walk. It's a nice park. And really the idea came from working with a peer as a series of little kind of objects, using what was there in a way to kick off, this kind of formal idea, as, let's say, cells that can connect, and obviously some of the geometries that may kind of derive from that, are pretty old and, kind of boring for us, like, things like Voronoi and things that are been kind of overtalked for so many years. But really when we come in, is when we can start looking slightly more into detail and trying to understand how we can rationalize these geometries in patterns that can be kind of repeated, and hopefully pave kind of the way to prefabrication. So in this case, for instance, using, the Cairo patterns and understanding kind of very repetitive geometries, at least in plan, that could, let's say, open only 2 degrees of freedom rather than, being a completely randomized pattern. And this really kind of enable us to look into more details and really find the expression that materials can give, into these elements. And again, what we try to do very quickly is to take these ideas and prototype them very quickly. Small scale, maybe slightly larger, trying to understand, how different materials may behave. But what we often come up with is a series of very complicated geometries that still, although could be rationalized somehow, will still become kind of a large catalog of one-offs. And because here what we wanted to do was to produce something that was going to be prefabricated and hopefully locally prefabricated, we had to kind of go back to the way we thought through this, and really work with the fabricators here, say in New York, to kind of revise the different kind of patterns we were working in. And really this unlocked for us, for instance, processes as, VE, so going from something as varied as, almost 260 different pots to something that is closer to kind of 130 without actually noticing, only because we not only could control the geometry very well, but also we were able to kind of test, where exactly, in space we will see it or not, the underside of these structures, and this is a one-to-one mock-up that we did in the studio in London. And this is kind of the stuff that we try to do as much as we can across different projects, and really all this kind of workflows for us kind of are unlocking, kind of simple systems that can then be applied, on site. And when you have kind of a fairly rationalistic kit of parts, you may be able to achieve kind of these things with at least some level of ease. These are some of the kind of images from the park. I really encourage you guys to have a look. Maybe another good example will be the Maggie Center in Yorkshire. Maggie is an institution that works with people that's been diagnosed with cancer, and they try to kind of give emotional support. They're basically the first place that you can go, after you've been diagnosed, and they sit inside hospitals. And this is kind of the site that we were giving, and very kind of briefly, the idea was to kind of take that little green land, and because there is not enough, not much green on the side, we try to just somehow approach it in a way that we could provide both this little kind of shelter for people and some counseling areas, while kind of preserving the green space. On the interior, it looks like this. It's all, or it was all supposed to be timber. So the cores are CLT, and then all the things you see there are glulam. And these particular items, I think, were the most, let's say, complex part of this project. We work closely with Bloom and Lemon in Switzerland to kind of build these pieces, and really all the computational workflows that we put together were trying to always be driven by the fabrication constraints. We even had one person from Bloom and Lemon to sit as part of our team for a couple of months in the studio. Some pictures from the fabrication. images as it's now open. One interesting thing about this project is that we use, for instance, game engines not to visualize this, let's say, for a client, but rather for ourselves, just to picture, how a space will look at one-to-one and how, in this case, the landscape will or not work, So to iterate basically the design options through this was very helpful to get to something, very, in a way, in a sketch mode like this, to something that could become reality in a similar way. We also do some kind of other tasks, a lot of automation, obviously. When we deal with, kind of large scale projects, we try to automate, whatever, as much things as we can, from tagging to kind of drawings, controlling different design options through kind of, complex curtain wallings and stuff. But always kind of looking into, how this complexity can land to a site. Of course, we do a fair amount of environmental analysis as well, and I think for the past years, we've been kind of focusing on what happens, during the design process, let's say the middle portion of this, so in-house environmental tools, and then, and, kind of with workflows like look like this, to kind of what happens beforehand, so before we start designing, and we've been kind of working on a series of tools that help us to understand the different sites we work on as part of the site analysis that we run now before any project starts, and little by little it's been kind of growing across the world depending on the projects that we've been working, and we're looking into something that is becoming a little climate atlas for us, that gives us a very good way of starting a project. We've been also kind of working with AR for, well, XR, including augmented reality in this case, for some years. And again, the key for kind of this type of technologies for us is to understand one-to-one scale. We make a lot, but not enough. It's never enough, So to test more, let's say, options or things that cannot be made, in the studio, we use this type of technologies, And obviously through the kind of the pandemic year, it was quite key for us to still be able to let's say, make virtually at least, from home or wherever we were, In the way we use it for design, we always try to kind of engage everyone from the studio in this, and even though we may have people that is younger or older, people that, I don't know, sometimes you will think that will not engage with this. It's never the case for us. We always try to make everyone to use these technologies with our team. We're also taking this to site, and again, for us, it's most for kind of the design purposes. So that's one of our technical design leads, and really looking into options for kind of one-to-one mockups, let's say, that are not yet built, and we're now testing with, projecting options for mockups that are actually built on top of them. In terms of collaboration, we've been using for quite some time now a tool called Spaceform, which allow you to, let's say, help in a way virtual conversations and meetings with different players and kind of and stakeholders in the project, and allows you to kind of make drawings and comments and everything kind of live in a way while we're kind of designing. And we're also kind of using some of these tools for making, So sometimes, we have to make something that cannot be represented bidimensionally. So, I know we are not yet ready for, stop making drawings, but really some geometries cannot be drawn. And, what's been quite keen in the past couple of years is also start working on tools that are not focused on specialists, and the best way, to do that to do our job, let's say in the studio, is to make everyone do it for us. So most of the time, when you work on kind of very complicated tools, what happens is that people don't engage because, it requires some level of knowledge that they may not have, or just, they will get scared of, I mean, simple stuff like, even Grasshopper files are scary for a lot of people in the studio. So the type of tools that we've been kind of putting together are just, let's say, a Rhino icon that all of a sudden, magically, will give you kind of a lot of real information, out of any massing you may be playing with, and not only extracting metrics, but also allowing you to kind of add more data into your models. All stuff from like metrics to kind of automatic, again, automated drawing generation or navigation. In terms of AI, and I think I really enjoyed this morning's conversation. Our first approach really to working with AI was through visualization. We thought, like, what's this kind of a very simple kind of process that we do over and over and over again in the studio that requires a lot of time, and it seems like it could be kind of, I don't know, template somehow. It's the way we visualize things, and in our particular case, what we usually do is to do hand sketching, on top of something that has been much more detailed, or could have been much more detailed in 3D. So we're kind of dumbing down, what we've modeled, and that was kind of our first approach to it. Unfortunately, this is the only slide I'm going to be able to show today, but hopefully next year it's going to look much more detailed. But for the past, I don't know, 4 months, or after the explosion of all these diffusion-based models, we've been also looking into those. And I think the value that these platforms bring to the studio are more in line with how we can leverage this to explore our own design values. So if we care about complexity, if we care about detailing, and we do optioneering and options after options after options, or we care about materiality, can we use these tools to expand in a way the possibilities that you can, or some of the limitations that time may have, for instance, or to help you as an extra kind of pair of hands. The kind of the incredible thing about things like stable diffusion is that these are kind of open source software, and they're open for everyone to use. You don't have to pay anything. You just have to engage with the technology, and you may want to use it, build your own AI UI on top, or tweak it as you like. So it's perfect to explore. So we thought we should kind of explore it, and what we do is working in 3D, and we have our tools that we love, and maybe we don't have enough knowledge in-house to actually leverage these tools in the best way, so we decided to kind of team up with TT just or a month ago to do a quick hackathon. And I think what is key in the work we do is that we're not afraid of collaboration in any way, and because although we still have a small team, we're always trying to kind of push ideas out of the studio so people can kind of play around with them, and hopefully at some point we can also use them. So for instance, here's a stable diffusion-based model, working with our massing in Rhino, where you can kind of add any prompt you want and control a few things, and then wait for a little bit, slightly more than what you will be waiting on this video, and then kind of get several options back, and really, it's quite fascinating to see. And I think it's not something to be kind of scared of, and I don't think it's a matter of like, hey, is that option better or worse, or good or bad, but it's a really good starting point, to have these conversations, and as they become better, and they become 3D, maybe we'll have even kind of more interesting conversations, and finally, we're also kind of doing or using these platforms for analysis, trying to, again, understand the designs we produce from the perspective of our design values, so what are the things that we're looking at when we design something, when trying to extract those, and then use these tools to actually tell us, hey, are we on the right path or not? Or at least, again, to have a bit of a conversation started for, to have more critical thinking. So in essence, we are kind of an internal lab, or a sandbox in the studio, and we care about, exploring ideas, but not only because we like technology, it's because we care about real projects, and in a way, what we do care, on top of everything is to create better human experiences, places that can connect people, and generate emotional engagement, So we do everything from kind of a human-centered point of view, but, we have the luck to at least try to look into the future of this. That's what we do. Thanks.
Thank you, Pablo. That's great. So we'll plug this back in. And we'll have vision back in a second, hopefully. Thank you. All right, there we go. That looks better. Thank you, Pablo. And we'll discuss a little bit further in the panel discussion after our fourth presentation. For now, I'd like to introduce James Coleman. He's innovation vice president and looking after innovation and R&D at Zehner, and specifically looking at computational fabrication, mass customization, and all of that at an architectural scale, and how to apply that. James, thank you very much. He'll change the presentation. Oh, we can do it here. Whenever that's the advance presentation. Okay. Cool. Thank you.
Well, thanks for having me. Try to get a little closer here. So I work for a company called Zehner. We are fabricators. We do fabrication, engineering, and installation. So we work across the full length of projects, and we're fortunate to work on a lot of exciting projects with many of you. Our specialty is sheet metal, typically exteriors, enclosures, the complex exterior of the building that has tight tolerances, a lot of visual intrigue, as well as a lot of tight and tricky elements to deliver. So the last time I was here, I talked about file to the machine and how there's difficulties in delivering your designs. All the tools we've seen today are super exciting, but all of those workflows will die if you don't think about where it goes afterward. And so what I showed here on the last time was this is the control computer for our punching machine. And the punchline was that there's a portion of the paint that's actually worn away from interacting with it in a certain way. And so if you're able to generate thousands and tens of thousands of unique files, but it comes here and it ends up in an interface like that, it's likely not going to make it through. So the punching machine and digital fabrication in general has promised us no penalty for variation, right? The machine itself doesn't care if a triangle is this way or that way, if your pattern is one way or another. It should be able to provide us with that. But there's always a disconnect between parties. Oftentimes the design team has never met or spoken with the person who's going to be operating that machine. They don't understand the implications of some of your design decisions up front. So the project I spoke about before was trying to bridge these groups together, going all the way upstream, working with HKS and HKS line to tailor the design information in a format that would be delivered more successfully later downstream to the actual manufacturers. And on this project, we actually worked all the way down with the machine manufacturers themselves, got access to their API, and was able to program in the machine operation software in a similar way that you would with Grasshopper and whatnot. And so it was that kind of bridging of roles. And then the lines above here are important to look at, where on most of the times as projects progress, you've got your computational tools start to dwindle and die off as you work your way towards the field, while your costs start to skyrocket. So the good news, LA Stadium, this is the image that I left everybody with back 5 years ago. And at that point, we were starting to make panels. There's 37,000 unique panels on this project. And at that point, we had made 1,000, installed 0. So it was sort of like, well, let's hope it works. Good news is it worked. We delivered 37,000 unique panels, 35,000 unique panels.
We had a couple of remakes just because panels got lost, but we had sort of a really beautiful coordination by bringing all those different roles and groups together. And so ta-da, mass customization, case closed, we've got it. So it's there as long as you bring all the relevant parties together and you have that conversation early. There's the SoFi. So in a similar vein, the last few years we've been working on unifying roles again, but this time going further downstream. And so if there's a gap between your manufacturing and your design, there's a massive void between your design and your installation on site. The tools you have out there are string, levels, things that the Egyptians were using. And so while we have complex tools and we can come up with really innovative strategies, right now it's paired with conventional delivery that is just, it's a match that's made for disaster. If we zoom in on that red line, why does the cost get expensive? This is sort of looking at Zaner specifically, but if you're early on in a process, when you're working in the sort of engineering zone, your costs are pretty small, right? Changing the model, pushing things around, it's more or less free, it costs you time. If you jump into the shop, now all of a sudden we have material, we have time on the machines, we have scheduling, we have labor, we have crating, we have all this information and all this time and energy that's invested in these parts. You change it there and you're 10x to 100x. You change it in the field after we've shipped a prefabricated unit that has been made on extremely extensive machines with craftspeople, you might be at 1000x. If you're renting equipment and all the insurance, everything that goes on site. So there's a huge problem here where we've got such huge risk at the end with not a lot of tools to deal with that risk. So I'm going to talk about an unknown project here, but I thought it's nice to be after Pablo. Working with architects upstream is the way we prefer to work, getting involved as early as possible. With Heatherwick, we were really fortunate to be involved early on through Design Assist and working through mockups and prototypes and getting really deep into the modeling portion for delivering this. And so the scope of work we did on this, and I'm going to use this project as an example of what sort of the trajectory it sent us off on. There's a lot of survey and a lot of field work that was done on this project that has led to the tools, which I'll wrap up with. But the two scopes of work we had on this project were the perimeter bolt nose here. So this is 14 gauge stainless steel, these clear story ribbons that aligned with the glazing units, and then these nodes that kind of are all the sort of self-resolving elements of the project. So business as usual for us. We model everything. We talk to the shop. We have a really tight feedback loop between the artisans who are working with the material and the way we model it. We embed all that information via parametric modeling. Parametric production is the terms we use at Zaner, where we're collecting information about material, about labor rates, about time, about schedule, embedding that all into our models to deliver parts like this. Then we cut them out. We form them. We engineer the tooling, we do empirical testing to make sure the material is going to behave the way we expect. We take that back to the model and make sure that our models are actually fabricatable. We use parametric jigs as well. So this is an interchangeable jig where things slide back and forth. So with two pieces of information, the craftspeople can actually go through and validate that part's going to be just what you expect. And so in the shop, we've got great control over the geometry. We model things in multiple orientations. We model everything up to shipping, fitting on trucks, delivering those trucks sequenced and ready to install. So that's kind of business as usual for us. We've 30 plus years, 50 projects at once, doing wild and interesting geometry. So the sort of bits to atoms part we have covered quite well. The part that we've been really digging in, and two members of my team are here, which we'll be here for the hackathon to chat more about, is how do we take that file to the field? File to the machine, we've got pretty well solved. But unfortunately, all the benefits of prefabrication disappear if you don't coordinate it on site, because now you've invested a lot of money and a lot of time into these parts that are not mutable. So they show up on site, you can't cut them, you can't grind them, you can't adjust them. So you better have that coordinated well. And this is what we're dealing with, right? So we're literally mountain climbing, trying to pull dimensions and trying to coordinate pieces being installed on a project like such. And then there's a lot of different parties that come together, a lot of disparate tolerances, and not a lot of coordination that happens. And so it's nice to see platforms that bring all this different disparate data together, but we need to integrate people further down the stream and further down the line in order to kind of deliver that successfully. And then there's a level of quality that's really important to us, but also obviously to all the owners and designers and everybody else, that is really hard to attain, right? When you've got steel that can be plus or minus 3 or 4 inches different directions, and you want to have a 1/2 inch joint around that, which you're kind of seeing here. So the way on site, you typically interact and gather information. The measuring tape is the default one, but oftentimes the total station,
where you've got a measuring device, you've got a survey target or a retroreflector that's giving you a point in space. You're collecting information. And what that normally looks like is either layout points or reference points that the surveyor comes out, plots that for you, then you use that as reference to lay things out. Or it's a comparison about what's been built versus what should have been built, which is the right-hand side, which is typically a PDF report, a stack of drawings, and dead data. The trouble with both of those approaches is that the job sites are really volatile. There's huge pressure to deliver on site. The people who are actually building and putting these parts in position are asked to do the impossible, which is deliver a schedule with to install these unique pieces on a site like this, where you've got pits and holes and bulldozers and you've got all these things in your way. And so while you might have a reference mark, you may have to do several offsets and go around things. And every time you do that, you incur more error, and oftentimes the sort of dimensional drift can happen as your tolerances stack up. And the majority of communication that happens, and this is a funny photo that was captured by my super, where this is Mark Garner, one of our craftspeople on the roof, calling me as he's making this drawing to try and figure out what the heck was going on. And so he's transcribing some 200 measurements for me from a laser measuring down. I'm trying to interpret what he's seen, comparing against the model, doesn't match up. I sent him something, he looks at it and he's like, that doesn't make sense. And so we go back and forth, trying to deliver these really complex buildings. On the clear story elements here, and we're going to talk explicitly about how we installed these ones. Our units mounted to the glazing units, so our positioning was really dependent on their success. They had plus or minus 3 inches in the back of the units on the jack bolts. And then we mounted to these clear story brackets using survey points and coordinating names. So it's not easy to determine where things are. As this building was being loaded, it was changing shape. As the sun hits it, it stretches and grows. And so this building is a really active thing. So as you're surveying it, it might be surveyed many, many times. So if you're working in PDFs and you're working with a low fidelity version of the data, then you're going to be having all this overhead to review it. So this is the overall positioning in elevation. So I'm color coding them here, looking at how these things change. So every bracket's going up and down. And so all of your directives for how you install it needs to basically respond to this variability. If you do it via PDF, then you're looking at this, you're calling somebody, you're trying to get that information to them, you're doing it 10,000 times. Instead, we coordinated all that point data, brought it in raw from the total station. And so instead of them taking the point data on an SD card, making a report, sending me a PDF, we requested they just send me the point data directly, plot it in. And when you have it plotted and you have data and you've got automation, then you can start doing a lot of other things. Chuan and Robert were helpful, and they provided me all the deflection data for the units. We could also include future deflection. And so we could say, okay, the roof has this much load right now. It's likely going to go further. So we need to set our units higher so it lands in the right place. A solution that's really only possible if you're in a modeling world and you're interacting with data. The result of that was a pretty simple directive. Before the units flew up in the air, we provided them with a dimension for the jack bolt based on that survey data, based on that projected deflection. The units flew up into the sky and they magically landed exactly plumb, just where they should be. It was a good process validation that I saw that they actually wrote my values on the back of every anchor. The first bay, they didn't trust it was going to work, but after they installed the first one in 40 minutes and projected 3 days, then all of a sudden they wouldn't hang unless we provided them with that data. So it proved that we could, if we think about survey and collecting information and get a feedback loop back to the field, we can deliver pretty astounding results, faster, safer, less time up on the roof. And this is actually the rough set of these units. Here's the final. This building was particularly tricky because everything was self-resolving. One edge of the bay impacted the next, which impacted the next and the next and the next. And so there's nowhere to hide. Some buildings you can just grow it a little bit or cut off the edge. There's nowhere to do that here. And so this coordination was incredibly important. And we were via this collaboration with the surveyors, we were able to do this quite well. But this feedback loop is not ideal. So if you kind of follow the path here from survey, crews installing parts, that survey information got taken to an SD card, made to a PDF, came back around, and that's the typical way. It still happened as data too. And all the tools that I had built for deflecting and reviewing all the parts and pieces really only sped up that last bit, which in reality, what we wanted was why couldn't I just talk right across and just short circuit that whole loop? especially when the people who were involved in that conversation, when there were problems, were scattered across the globe. It was really hard. The feedback loop is really long. And so we were constantly having to delay installation to have conversations. And so there's still a big problem with that feedback loop, even though it is possible. I'm going to zoom through this because I think I'm running short on time. But if we look at sort of construction as a control system, the target is the green line. Survey happens periodically, and in between, all hell breaks loose and construction happens, and the air starts to accumulate, goes further and further and further out. And eventually, typically for us, the steel or the concrete or something is so far out, but so big that it's not moving. And so then people come to us and say, well, we can't move the steel, so what are you going to do? We're forced to then reconcile that change and figure out how we can, with our prefabricated parts, still fit to things that are in the field. Well, the tools we've been building is trying to do is treat it more like a typical control system where you're getting, faster feedback, you're getting quicker review, you're embedding some knowledge into that. And so you're staying closer to that target as you work. There were two things we had to do to make that work. One was getting the information from the total station or from the site or whatever your sensor is back to the model faster. And so we're using a Leica total station here, and we're broadcasting the survey data to the model directly. So once we had that sort of information directly in the model, we could do that thing that I was doing on the Google project in real time. The other thing is, once it's in the model, you still need to have everybody, all the stakeholders review it, and you need to have intelligence on how to interpret that data. So the first part, broadcast the data, and then get it to a model where everybody can review it. The second part came working with a company called Z, and they do compression algorithms to get large data sets into the cloud. And so from the browser, we can load this model, and we started to build up tools. Once the data is in there, how do we interpret it? The dream being to provide basically in situ, in real-time directives for how to correct your positioning. So the way this works is we continue to sample, we take those measurements, those things are plotted in the model, compared against a target plane. And it's not just a XYZ global coordinate system, it's actually to a tailored plane. So it's giving you relevant information for how you need to move. So it's not giving you some arbitrary vector, it's telling you exactly how you need to adjust to hit a certain plane. A couple of projects that we've deployed this on. This is one that's actually active right now. The steel, once again, was close, but not quite. We validated that via scanning, looking at the scan versus the target model. They don't fit up. So your options are what? You ask the steel manufacturers to take these pipes down, take them back to their factory, re-roll them, and then bring them back. It just doesn't happen, right? It's not a realistic thing. So instead, we started doing what we were even calling reconciliation modeling. So how do we take our parts and actually fit them and test fit them against the target model? Bringing this back, there's lots of different solutions. Once you depart from it being binary, is it the theoretical, is it not? Then we can start to do some solving. And so we can find a best fit example for how we can take our parts and reconcile them against the real world. Pretty exciting, right? If you're doing this in real life, you might take the parts up there, fit them, see how they fit, go back and adjust them, go back and adjust them. But the parts are big, this required a lot of welding. And so it's not really feasible to do that many times, right? But if we're doing this in the model, we can do it 10,000 times and find a perfect fit that reduces the total potential error and also finds the best solution aesthetically, whether that's tangencies or something you're looking at. What this looks like from the model that we mentioned is now we've come up with an optimized solution, but how do you get that information to the field? Well, so that's where we started deploying the browser-based model and that survey link, the total station tie, which we've been calling survey link. So now we have all these individual planes. We go out there, we use a prism, we locate things per that model. It is achievable because it's now been fitted to the real world. They went through then and welded the studs on, which we'll zoom through. The second part of this was locating the ends. So knowing your adjustment and how to coordinate that and how to use your tolerance is a tricky thing. But here we can come up with a very specialized solution that's been optimized and then deliver it to a very high tolerance in the field. You can see here it in action. So each of these parts were installed without a measuring tape, right? You plug these two prisms on the two ends, you compare your position in real time as you're working, it drives it into position against your model, and then you're done. The proof of it is that all the parts fit. These are all prefabricated, so we're not field measuring anything. All of our joints worked out. Everything maps to that reconciled model. So it is achievable. It just takes a lot more coordination downstream, and understanding that feedback loop is really critical. Was that a one-off solution? No. Another project that's had to be withheld, but this has worked out really well on geometry that's bananas, that like just traditional tools don't work, right? Like there's not a single plumb or level piece in this entire project. Each of the units had a lot of adjustability that's hard to explain to somebody in the field, and how to pitch something in a compound rotation. If you ever try to explain how to do such a thing, it's challenging, especially over the phone. So instead, we used the same survey link model, and instead of using complex directives, we send a single link. They use that link, they measure the points, they shift them into position, and because it's automated, you can measure this 200-300 times as you're moving into position, so you get better and better quality. Once again, proof of this one, fins all went up, skins all fit up, joints remained intact. Then we did some quality control scans to verify. We were able to hit extremely tight tolerances with our installed parts against our target. Skins fit. And overall, it's an exciting future, getting the field involved with computational tools, getting solvers downstream, solving some of the problems that are the most expensive in a project and also the most risky. And so the consequence of not coordinating that is that things get fit differently than you expect. Your performance is different. Your aesthetics are different. The costs are different. Your schedule is busted. Things are more expensive. So in some ways, I feel like the field is actually the most ripe for delivering these new tools, especially tools that bring different data sets together. And that's what we've been trying to do, and happy to continue chatting about it. Thanks.
Thanks, James. That's pretty amazing to see, and also see that push through the whole construction on site. Actually, next one up, Nick Cameron. Nick is digital practice director at Perkins&Will, and overlooking for the global firm computational design, digital design, and how tools and workflows can be implemented, improved, bettered, etc. And I think we'll move over to your presentation right away. Thank you. It's going to load it up, and that's the advance.
Okay.
Once it's up on the screen.
Oh, so okay. Perfect. What's great is I don't know what's going to come next, so it's going to be a ride. I named this talk to 2030, and then I put at the bottom there what a long, strange trip it's been so far. Because it's really great to be out with everyone and to see you all again. But first, I'll mention a little bit about Perkins&Will. We're a global firm. We're in 26 studios. We're 2,600 designers focused on many different types of work. And my team's charge is to affect all that work. Not that we're focused on just the top 10%. Projects that are around design excellence or healthcare or CI, it's all the projects. So we have this complexity of scale. Anything that we're trying to do, we're always trying to scale to all of our projects and to all of our clients. So like I said, it's been a while. You might remember back in 2020, it was a new decade. We were all really excited. We wrote this big blog post about what we thought was going to happen in the next 10 years. We're thinking we're going to move things to the cloud. We're going to collaborate with a lot of people. And then a few short months later, this happened. And we all kind of went to work from home, and it didn't feel very good. But we got on with it. And this is a graph that I like to show. I go back and show this to my team pretty often. In March of 2020, we took something that we thought was going to take till the end of the year. And we did it in about 3 weeks, and that was to move everyone to be able to be fully remote our projects, so people could work from anywhere and we could deliver for our clients. And we did not miss one single deadline. And I found this to be really empowering, that you can make change really fast in a large organization with a lot of people working together. So I kind of bring this back, and when our team says, that's going to take 6 months, I'm like, I think it should take 3 weeks, because we've done it before and we can do it again. So what has that changed in terms of how we're thinking about the next 8 years? We have these really major challenges, housing crisis across the globe. How will we address that? Climate crisis. How are we going to address that? These are things that weigh on us and our clients. And I think as designers and as architects, how are we going to make these changes to better everyone? And that, 2030 will be here really quickly. And to put that in perspective with technology, that's 8 short years. In 2006, which was 16 years ago, this happened, the iPhone happened. And how much has changed in 16 years? Technology is definitely moving at 2x. And the reason I bring this up is what we hear back from the folks in our studio is there's been too much change in the last 2 years. There's been too much that we've had to deal with. And we have to repeatedly go back and say, it's not going to slow down. We probably have to speed up. So we have to get comfortable with this change and the tools if we want to make real difference in the world. So in the last few months, my team and our research team have come up with this kind of mantra that we're using, and that's that we're a collective of designers who harness technology to unlock new value for humans and the planet. It's not technology for technology's sake. It's to make a better experience for everyone. And that what we've learned is that we can be bold and go fast. And we need to do that. And I think the last example is to partner up. And I want to talk about 3 projects that we've done in the last 2 years through the pandemic that really started like right in 2020. And we've brought them to the firm, and we've been sharing them inside and outside of the firm. And it's through amazing partnerships that we've been able to make, like with James here. I'll stole some of his slides. So the first one I'll talk about, drawings are good. I think they're amazing. And we can learn a whole lot from them. There's a company called AECtech. It's a really small startup out on the West Coast. We started talking to them in January of 2020 about what can we do in our process to automate this? What can we do with what we have that's existing already? And one of the things that became kind of a breakthrough for us was to say, we know the models that we create as designers to deliver are not very good. We've talked about that, I think, a lot today. There's a lot of unstructured data. People aren't doing things consistently. And when we took a step back, we said, it's kind of consistent is the drawing sets. They are structured. People tag everything in there because we build from those. And that if we could start to extract the data from our drawing sets, that we could then index those in a database and then apply Elasticsearch. This is all going to AWS, and then put them into the web for our designers to go back and look at. And we call this Artifact. We launched this, I think, in December of last year. It's actually a product. You can buy this from AECtech. I wholly endorse that. But what's been getting really interesting is, this is an old video. Now we're over 100,000 drawings in there. What we're starting to find is what's being repeated, because we can use computer vision and the metadata behind all the drawings to say, we sure do a lot of the same drawings over and over again. How can we save time? How can we reuse those to make time to do the things that are really important? What I think in listening to the talks today, which I think are excellent, is, what kind of comes next. So you put this in there, you use it, you put it back in the project. Now it goes back in the database. But what if you replaced Elasticsearch with Stable Diffusion? And instead of creating these really beautiful rendered images, we can prompt for design solutions for details and things that are in the drawing sets. Again, to really save time in the production where most of the time happens, to do higher value work like LCA and carbon calculations, things that'll make a difference to our clients in the future. Second project I'd like to talk about, we'd call this modeling intelligence or model intelligence. This is a collaboration with Nate Miller and the Proving Ground. I think a lot of folks have seen the work that Nate's done with a Power BI plugin called Tracer, which we think is really kind of amazing. it takes something from Revit and Rhino and puts it in a place that is more accessible to our stakeholders. And we collaborated with Nate and the team to take some of the code and build out a tool to extract from 26 studios into the cloud. So what we saw as a challenge really is that we have a lot of people that are the folks in the team called, you know, the planners. They're planning the work, large hospitals, office buildings, things like that. And they're working in Excel essentially. So you have this one data set that's at one side. And then you have the folks modeling and designing in Rhino and Revit. And that's where we think of simple business terms. You have the planned versus the actual. But there's actually no easy way to compare that without doing a whole bunch of work, especially if, like James is saying, there's a team spread out across the world. So we needed a way to bring those together. And what we originally thought was, well, we'll put everything in BIM 360 now. We should be able to extract that really easily. That's not the case. So we had to come up with another solution, and thank goodness there's people like the Proving Ground and Nate that are making some of these solutions. But once we have that, what's become really interesting is we create a dashboard that our stakeholders can use, our clients and the leadership on the project who have never had a view into this in almost real time, right? So if the client calls and says, how large is this building? How big are we now? They actually can't answer, like without calling someone else and having them open the Revit model and getting a schedule and then putting in Excel and comparing against the program. This happens every day at scale. So right now we have about 200 projects running this, and it updates every night or on demand. One of the things that we're trying to solve also is, I think everyone in this room knows, you know, getting good data. You all see this bad data in or bad data out or whatever. I don't really like that saying, but what we took a step back and said, like, hey, everyone really seems to like their Fitbits and Apple Watches. Somehow everyone's walking around like 10,000 steps a day. And the way that you do that is to form a habit, right? And you measure it every day and you try to adjust to that. So we ran this experiment about a year ago where we were doing these daily syncs and then went back and showed the team, like, this is how your gross square footage is changing day in and day out. And when they were starting to take a look at this, they're like, oh, we know what day that was. We had a meeting, so we poured all this stuff into the model. This is when we got an initial cost. We took it all back out. And that's what we're trying to avoid is these cliffs. As we creep through the project, we really want to avoid rework. We want to avoid VE. That's like bad iteration, is I think what we were calling it last night. So this is a way of us trying to understand how often do we have to sync? How often do we have to push this all back out to the team to make a difference, and then also to validate the data. So if they see something that's not right, they'll change it, and it's not a big change, it's just a very simple change. And then we thought, well, we have this database that's running in the cloud. We can then start to apply cost, living design data or resiliency data, healthy building network data, or benchmarking data. Everything else can be in there. If that's where the source of truth is, we have it in a modern stack that we can work from. And it's pretty simple. This is our kind of MVP at the end of last year before we really started kicking in. We took a small project with the design team, and this is what we were syncing out every night. There's an Excel file, there's a Revit file, they feed into our database, and then they're compared in Power BI. The reason we're using Power BI right now is every client is different and wants something else, right? So we don't have enough development power on our team to write this all out in D3. So we allow the design team to go in and start to customize this. There needs to be flexibility to make this work. And then we think it can get kind of interesting where if this simple model is almost the DNA of what could become a digital twin, that's whatever the client defines that as, but that they can layer in their building system data, IoT, and scheduling. Where we want to bring this further is data on demand, where they need it, where the team needs it. We see cost coming into this, building out cost models, building from the benchmarking and the data that we feed back in from our estimators. And then really the big one is around embodied carbon, operational carbon. So our teams are always talking about, we want to go back and benchmark. And what we've been saying to them is stop going backwards, go forward. In 12 months, if we all use this tool, we'll have more data than we've ever had before. And that's the journey that we're on right now. We call that Area Sync. So that's been out in production now for since the beginning of the year, really, but we're moving that up. The third piece of work I want to talk about is a mantra that we had within the firm around what we would call deliver different. How can we start to deliver our projects differently? And luckily, you know, we had a relationship with Zaner and with the team to say, how do we do this? How do we institutionalize this? Not on a project or two projects, every project. What can we learn and what can we instill and put into our design teams? And we really started to take a look at the process, but we had these goals that we wanted to reach, and it was change the industry. You know, and that's why we're here talking about these things. Develop a digital first process of design and delivery. James was showing, I think, beyond. And then short circuit some of it. We want to chase work with Zaner and win work. We don't want to do it even just with a GC. We want to deliver the design and, you know, the best possible outcomes. We think we can do that together. We can think about the business model a little bit differently. This is a diagram that talks about where is the sweet spot? How do you find that? And, you know, if you ever worked on a project without working with a fabricator or closely with a cost estimator, you're kind of flying in the dark. You may be able to hit two of these, but you're never going to hit the third. And that's where having a really close relationship with a fabricator, especially like Zaner, comes into play. And we thought about how can we continuously shrink the communication gap. So this is, you know, what it is today. So typically, you know, we send something out, someone says, yeah, it's okay, you can send it out. The team receives it, they make comments, they send it back. And what we really wanted to do was have this even flow, have a common data exchange playing field to share information. So we've built out templates that we share, Rhino files that we share, and have built tools together so that very quickly we can go from a concept and within literally hours, get back, you know, constructability and pricing. So these are some of the tools that the team's built. And like James said, folks that built these are going to be at the hackathon this weekend. I'm going to go pretty quick here. You'll find unique panels. These are all things that experts know, but maybe architects working on the models don't know. And it's not telling them they can't do something, but it's just letting them know there may be a better way. This is my favorite. If it fits, it ships. How is things going to fit on a truck? And if you think about this in the long term, it's like, if we use less trucks, we probably use less carbon. That seems like a good thing. This is just quickly a little project that's up in Toronto that was worked on through the pandemic in the beginning here, working with an Indigenous design group. And we were told about this story of something called a star blanket. And we took that concept and we built this, this model here. We had this very heavy felt. We scanned this, and this is before we met with the team at Zaner, and it was like, how are we going to do this? And we introduced them to the team. We've set up the platform with Zaner. And I think this neighborhood that really is an underserved part of Toronto is going to get this really beautiful jewel box. This is what that will look like. This is a white paper that we put together. This is available on our websites. And the questions come up, and there's a presentation of this going on right now in LA, actually. Why are we sharing this? And it goes back to that goal. You know, we want to raise all the ships. We want to change how we're delivering work so we can be better stewards of the environment and deliver for our clients. So this is something that a colleague of mine wrote in Vancouver last week when we were together, talking about the future will belong to firms that are able to harness technology and data to their advantage, but should change this and said, for the good of people on our planet. And I think that technology is that vehicle that can get us there, especially with how many smart people we have in this room and the firms that we represent. And that we can all be bold, go fast, and partner up with one another. Thanks.
Thanks, Nick. Great. Let's partner up indeed. Very positive, very nice message. And now next up is Martha Tsikari, Fosters and Partners. She's a senior partner and leading the applied research and development team over there. Mainly based in London, I think, right, the team? But only in London. But Fosters, of course, global firm, so I'm sure you show project all over. Well, we'll see. Welcome.
Thank you. Yep. Okay.
Right.
I promise you there is a body under this head that is kind of hidden by this thing, which is very bad for short people. I'm Martha Tsigari. I'm from Foster and Partners. I was not very modest, and I didn't put many things about Fosters because I assumed that you all know who we are. We're a global firm, 55 years, going strong. Our culture is rooted in sustainability, but it has actually been technology, which is effectively what has allowed us to do a lot of the things that we have done for the past 20 years. So the title of the presentation was The White Rabbit, and that's because for me, technology, innovation, disruption is the white rabbit for the AEC industry. And we can choose to completely ignore it, right? Or we can choose, like another Alice in Wonderland, to just go down the rabbit hole. And down that rabbit hole, there is a lot of uncertainty and uneasiness and failure. There is a lot of failure, but there is also quite a lot of possibilities. And I think this is good. It's good to take ourselves outside our comfort zone, because outside our comfort zone, there is chaos, but there is also opportunity, creativity, and sometimes a little bit of magic. And I love chaos like Wisława Szymborska. Did I say that correct, Marcin? Yes. I prefer the hell of chaos to the hell of order. And I'm actually very, very lucky to have a team. 3 of them are sitting here with us right now who are into the chaos with me. And they want to bring disruption in our industry as soon as possible. So we are the applied R&D group at Foster and Partners. We are 16 people for 1,800. We've always been less than 1% of the total company. We are all architects, engineers, or both, but our common denominator is that we're all programmers and that we have a lot of different interests, starting from complex geometries to performance-driven design, collaborative design tools, ML, IoT, smart buildings, you name it. We probably have done it one way or another. So I show these slides just to say technology is not something that is new to us, that we're like, wow, it has come. We have been doing it for over 20 years. From Swiss Re, that most of you don't know, has been developing Excel and VBA because there was no parametric toolkit at the time. To 15 years later, Mexico City Airport, where the entire space frame was algorithmically defined in order to be performative for all the different things that that airport required. So how do you scale up like that within 15 years? We basically said, okay, all the things that people think is a challenge, technology, disruption, innovation, let's take those and let's develop products and services to effectively create an agile process like DevOps, right? And in that, we're wanting to do what the IT industry has done, which is taking effectively development and operation and put them together in one concise space, one process. But then we're now taking it a step further and we're going for design ops, which is what we're trying to, again, align with the way the IT industry has been developing, where UX and UI is trying now to keep up with the development that is happening in the space. And therefore, we're now trying to operationalize design itself. And when we're talking about design ops, the principles are you're orchestrating people, processes, and tools. And in our industry, these are the processes more or less, and they can be cyclical. And these are some of the people in that industry, and these jump all over the place as well. And these are some of the tools that we have been creating in order to be create that DevOps design ops workflow within the AC industry. So I will take you through a little journey through the different stages of design, from conception to completion, up to operation. And I'll start with performance-driven design. What you see here, we've done more than 15 years ago, and it's effectively our effort to say, design is not linear, cyclical, and you want to have feedback all the time. So what we're trying to do here is effectively break the boundaries between physical and digital modeling, where you're actually moving a model and capturing it in real time. And as you do, performance analysis like daylight, CFD analysis, connectivity are being analyzed in real time and projected in the model, which what it does effectively is allowing designers to make intuitive yet informed decisions early on in the design process. And of course, as technology evolves, our tools evolve as well. Nowadays, with games engines, we're creating different applications that work like Minecraft in steroids that allow users to, again, do real-time design and analysis in whatever hardware they choose to do it, in whatever context. So from headset to touchscreens to their desktops. And this is very important because you're allowing people, as they design, to understand the repercussions of their actions. This is the software working, and as you're kind of creating the massing, you're calculating the volume, the area, you're checking your daylight, you're checking your views, but also you start having the opportunity to not only calculate hard criteria, but soft criteria. So nowadays, we're not only looking into like sunlight hours, but we're looking, what is the well-being index in these spaces? What is the operational carbon? What is the embodied carbon? And even what is the financial value? What is the ROI of that particular design when we work very closely with our clients? Our current tool within that framework is Thalia. And Thalia is very interesting because it actually worked with this idea of a very intuitive UI that harnesses the power of all the simulation engines that we have developed in the office. One of which is Cyclops. Oscar, my friend there, my tall kind of Swedish friend, is the architect behind Cyclops. And Cyclops was an idea that was developed in the group like 15 years ago, which said, how can we actually calculate what a good view is? And how can we give that very, very quickly to the designers to appreciate how to shape the building? So that started by using the custom render in our software in MicroStation like many, many years ago, turned into an OpenGL viewer with C++ analytical engine, and is now using a CUDA-powered optics API to be able to run actually a tremendous amount of views in very, very little time. And not only that, but we're able to not just look into views anymore, but anything that is ray trace based. Like in this case, you see Oscar is moving this model around, he's moving the trees, I can see the daylight in real time, I can see the views in real time, but also at the end of the day, a report is provided, which is done automatically for every single project. So that reports on the left-hand side would be reports that the team would get with a click of a button based on the analysis that we've done. And you see the acceleration of these tools, right? 2007, 24 views per minute. Nowadays, we're doing 600,000 views per minute, which is the equivalent of 10 gigarrays per second. And this sort of acceleration actually allows us to create quite a lot of information very, very quickly. And can we then scale up? Can we create distributed computing and optimization as part of our design process? I mean, optimization is not something that is new. We have been doing that for many years. UA Pavilion, inspired by the desert, having a reaction diffusion algorithm create panels that are all different inside, but have all the same perimeter. And therefore you can pick and choose how many you want to create to deliver that pavilion and put them any way you want. So, okay, run optimization, see how many panels you can get, minimum number of panels, but maximum differentiation in terms of their placement in the pavilion. But if you start thinking about objectives for a building, there are a few, right? But you go down to the city level, the city scale, these objectives explode. Everything from like sustainability criteria to financial models within a city. They drive the way we think about urban space. And for that, we now have Hydra, which is our distributed computing system, the architect of which is Martin, sitting there with a nice little thing on his jacket. So Hydra has allowed us to effectively scale up optimization. And rather than thinking of the idea of like, how many options can I create for a city and analyze before my time is up? We're doing the opposite. We say, okay, we'll set up the criteria and the objectives, and we'll allow the computer to do the heavy lifting for us. So we set up a model based on design aspirations, and we allow it to run effectively in parallel and create hundreds of thousands of options on a city scale. These options are then being analyzed for the different criteria. In this case, we had the area, we had visibility, we had connectivity and views. And as we analyze them, the solution converges to a pseudo-optimal space from which we can pick where we start from. We don't pick the final solution, we pick where we start from. And we can do that through our own kind of web applications. And that is actually a really cool thing to do, because we have all this fast analysis, we harness the power of all this analysis, and we're actually creating an interface that is based on parallelization on the cloud, on our on-prem cloud with GPU and CPU empowerment, with a web dashboard that allows people to visualize all these options that sit like on the left and right-hand side of a REST API that allows us to also create a huge database of different options. To understand the number of options we're talking, if you were to create one option by yourself, that's the equivalent of doing 90 options using just Cyclops and doing 260 options at the same time using using Hydra. So we're talking about 5,000 different options that are analyzed around in 4 different simulations within 24 hours. So the amount of data that we're producing just from these generative models is insane. What can you do with all that data? I mean, we had all this discussion about machine learning in the morning. I thought it was a great panel. I talked briefly about us kind of using machine learning as surrogate models in search engines, as design assist models, and for business insights. Surrogate models were some of the earliest models that we kind of explored because it was easy, because we had Hydra, and we could create, for example, hundreds of thousands of floor plates that we could then analyze through Hydra, create our data set, and actually train a system to kind of directly understand what the spatial and visual connectivity for a space would be, which is very important when you're doing offices, and actually it's very, very time consuming. But not just doing it for the fun of it. Okay, we've done a machine learning application. The point is, how do you put this in the hands of the designers? So again, there you're going into that process, that design ops process, where we're creating tools directly sitting on the Rhino, where people can go create the space, click the button, there you go, that's your analysis. And as you've seen, the delta of what is actually calculated to what is predicted is minimal. So for early design processes, this is absolutely fine. We have a huge amount of data in the office, and that data is not just about images, it's about a lot of documentation and a lot of knowledge that sits in the minds of people in the office that may be old or young or whatever. Our current kind of crusade is around the democratization of that knowledge. So we have developed applications that allows effectively using natural language processing to be able to retrieve answering questions like, what is the best kind of material for a window for this fire regulation? And you will get the answer, and you will get also the PDF in which this answer sits. And that allows people to now not try to find in a huge office who has the question, but directly retrieve that answer 5 minutes, very quickly. Midjourney, we talked about it. We're not so much into creating something directly for Midjourney, but using it as a composite of where it sits with our actual designs. And you can obviously do things like that with a lot of these models, and I'm not going to go into that too much, but the way that we like using diffusion models is like that. So this is an app that my colleague Sheriff did within a week, where he has the model viewer on the left-hand side in Rhino. That model is directly passed in a stable diffusion, and then comes back all the different options in Rhino around different potentials that say, oh, give me a nice sunny building sort of prompt. We talked about performance-driven design, we talked about distributed computing, we talked about machine learning, but at the end of the day, we're doing all these things to create buildings. And funnily enough, we're not so much in the business of creating buildings, but we're in the business of creating experiences. So to do that, we want to put people within the experience. This is a project that was done like 25 years ago with UCL. Headsets cost 100,000 per person. Obviously, the hardware was not there back then, but the ideas of how we can use this technology were. So nowadays, we use this sort of tools not as a visualization tool, but mostly as a design collaboration tool. And at a fraction of the time, our current tool product around that is Glaucon, that allows for real-time experience of a space as you sit on the space with like real-time mock-ups that we're investigating with our clients and contractors, allowing us to not spend money on true mock-ups and also cut down on CO2 emissions as it comes to that. And also allowing us to give people like our clients an iPad and go on site and check options yourself. But also it had been really interesting during the pandemic as well in terms of how we collaborate. So Glaucon has become the basis of our in-house collaborative design tool, where you can have different people from all over the world running like real-time reviews in something that resembles our office. And we're talking about people. We can't talk about interoperability. It's all about how you put everything together, how different people collaborate. And we have all these discussions all the time in this room. And everybody has their own flavor of interoperability. We have Hermes. Hermes has been very interesting for us because it has allowed us to deliver projects like the Lusail Towers on time, where the entire kind of project has dropped by 10 floors, like literally a week before delivery. And dropping that tower by 10 floors doesn't mean that you just chop off 10 floors. Everything changed, structures changed, MEP changed, everything. But because all these different disciplines, including external consultants, were hooked through our Hermes software, that meant that that change propagated simultaneously throughout all these packages, and the tower was delivered on time and on budget. And of course, we are looking into what else is out there. We're not trying to reinvent the wheel. Rhino Inside, you all know, going directly from Rhino to a BIM model, or like NVIDIA Omniverse, we have developed our own custom tools on that for digital reviews. I will close with something that everybody talks about, and I guess like if you ask 100 people, you'll get 100 different options of what this is, digital twin. We're trying to understand what it is, and to do so, we are effectively eating our own dog food, where we have created our own IoT toolkit and digital twin for the office, having our own smart campus application. Anders, again, sitting here, is the person to talk about that. With our IoT toolkit, our application can monitor our entire campus, and we have the possibility of not only visualizing that data, but actually looking at it in 4D and understanding how operationally it's going to change our building, which we scanned ourselves in order to basically check as built against as design using this fellow here. We were the first architectural firm to have used Boston Dynamics Spot, with Brian Wrigley being a huge help on that, and trying to understand how that sort of technology, disruptive technologies like Spot, can effectively change the industry, not only checking as built against as design situations, but also on creating 4-dimensional models of spaces that have to do with data changing over time. I'm between you and a loo break, so I will leave you here. We're talking about the white rabbit, about disruption, about the fear of the unknown. This guy on the right-hand side is Steve Jobs, offering the first Mac computer in Sean Lennon in 1984. Keith Haring is on the left, and then you have Andy Warhol on the right. And they're all looking at this thing, thinking, what are we possibly going to do with it? Well, I think we know where that went. So I think I'm preaching to the converted, but if you haven't done so, just please follow the white rabbit and know that we're hiring. So we are a little bit of a white rabbit as well.
Thank you very much. Pretty amazing. I think we had a nice group of presentations together. I'd like to invite all the presenters over for a little bit of discussion, Q&A. Get the mics here. Thanks again. Thanks for your presentations. As I was saying, as actually what it kind of was trying as well this morning is to find a few bridges between the presentations. I think there were a few clear ones with James referring to Heatherwick's projects, and actually then Nick referring to some of James' work. So thanks for that. Thanks for doing my work in that respect. Maybe we'll touch with that first, like how these projects go to site for these facade panels, and then how can we make a feedback loop back? Is that happening enough, let's say, to actually the stuff that we learn on site and all of that quite complex setting out, making sure that everything fits, etc. Does that feedback enough in the design models, or can we improve some of our workflow there?
I mean, Nick, you want to jump in there?
Sure.
I don't think it happens at all.
Right.
It's one directional.
Yeah, I think what started our conversation with James and the team was we saw an image of that app that he was showing. And what stuck in my mind was, how'd that model get there? Where did it come from? And thinking that it probably came from or could come from one of our designers, or should be informed by one of our designers. So that's how we wanted to start going upstream and having these conversations. And I guess, thinking about how do we get to the machine, or how do we get closer to the machine? We don't have those machines, but we have friends that have those machines, and we want to partner with them and learn so that we can make more informed decisions earlier on in the design process, so that we can deliver the design intent at the highest fidelity, with less waste and faster. And you can only do that with working with really smart people that know how to make these things. So that was, it seemed very simple in our minds at the time, and we kind of got along and started down that path.
But Pablo's diagram of the hammer and the computer is, I think, the factory and design world are closer. I mean, in schools, it's ubiquitous to see fabrication machines and curriculum now. The field is still that last frontier, I believe, though, and it's the most costly and riskiest one, which that's where that app that I was showing, I was going to do a demo, but ran out of time, is really trying to bring that state back. Things like Spot, I'm curious to know what's happening with that data, like what decisions are driven by it. We're trying to get the data right to the people making decisions in that moment, which is tricky because it's both timely, it has to be prescient data, it has to be clear, it has to be accessible. So I think the factory, I think, is coming back to the design team. I'm hoping the field we can kind of bring it back to. It offers a lot of opportunities. Things that are considered unbuildable are buildable if you plan that far ahead and you have that sort of nuanced strategy.
And then go ahead, Pablo. I'm curious then, that connection, that improvement, it sounds like it often happens on project to project level. Can we, I'm thinking about Marta's presentation now, can we actually bring that then into more like workflows and actually more like a pipeline in a way? Are we there yet, or is there more work to do?
Well, there's definitely more work to do. Each of our projects is different, and so every solution is wildly different and somewhat unstable. Like, it's the minimum viable to get the project done. Anything past that is extra investment for us. And so that app is something that is deployed, specifically on projects that have certain requirements. So I would say there's lots more work to do. We're not a software company as well, and so maintaining it is also a burden that is difficult for us. We're in the business of making things. It has helped us perform better, deliver better, deliver less expensive, making us more competitive, which is something that's hard. I mean, there's lots of things get outsourced from the production side. You can't outsource things in the field, and so while our labor might be more expensive than other people who are outsourcing things, we can perform better in the field and make our overall delivery more competitive.
Anyone else wants to join in there? Or
I think it's something else that's come from the pandemic, is to collaborate across great distances and maybe not be there and be able to interpret the data. So something like Spot, or another group we work with called Dusty Robotics, where we want to understand what is the built condition and then make those decisions, and not a super or someone else on the job site. It should be back to the designer to make those decisions. And it doesn't mean you have to be on site.
I mean, for some things, obviously as complex as what you were showing, but for other simple things where, you know, there's mistakes that are made, it's 1,000 times more expensive to, you know, fix them. So we make adjustments, and it should not be in the form of over to RFI with, you know, within 8 days. Like, let's just do it now. You know, turn the FaceTime camera on, shoot as the drawing or shoot as the model, and we'll make the changes and everyone will be happier.
But it's interesting because when you have the workflow in place, what you were just saying, it makes all these things very straightforward. So for example, I was talking about the Hermes interoperability tool, and we use that when we're doing the mobility pavilion. And what happened was that it would create directly through Hermes on site the entire kind of documentation going from our Rhino scripts to the Revit documentation, right? And they went on site and they were doing point checks every day. And they ended up, I don't know if you know the mobility pavilion, is really beautiful. It has this blaze all around, it's very curvy. And they had the beams on the top and they did point checks and the beams were like, what, I don't remember, 15 mil off, 15 centimeters off, something crazy. And then they had put it, they couldn't do anything and everybody was freaking out. So they came back to us, but because we had the process, we effectively said, okay, no worries. We're going to rearrange everything. So effectively we did a small adjustment in our parameters, run the entire script, deliver all the documentation within a day, literally. And then because they had started putting everything from the bottom up, all the different blades, and they needed to align with the top, and that was done. So when you have the process in place, all these things then become mainstream. They're not things that they're not an afterthought. They're not things that can be problematic because you proactively have a solution for them.
Well, but you have a set of solutions.
Yes.
That's a fascinating example there. I think oftentimes we get stuck thinking that there's one solution. It's the model. Is it the model? Yes or no? But really there's a solution set. And as soon as you add tolerance to a project where things can be here or there, which is required, you know, otherwise nothing will fit. As soon as you have tolerance, you actually have a range of solutions. And if you can navigate that solution set and make really tactical decisions, there aren't problems. But that feedback loop is rare. I want to learn more about the mobility pavilion. I've seen it.
We don't work with you have to also make sure that you work for the worst possible scenario. So when we do these things, we don't think that we'll work with the scenarios of this world, right? So we work with the assumption that things are going to go horribly bad. So we're proactively doing kind of damage control effectively. But it's okay, it's fun.
But it also sounds like in a workflow like this, and well, I don't know, at least in our case, you know, what happened often is that you are in control of things, but then you find yourself kind of bypassing the contractor and going straight to the fabricator to kind of speed up things. I wonder, you know, if with the tool you show, kind of every single party is actually involved and making kind of important decisions along the way as well.
Absolutely. I think this is a key point, right? And a lot of our, it's interesting because we talk a lot about interoperability and data exchange. The reality is that and don't get me wrong, like having Omniverse, for example, having that visualization of all the different principles together is wonderful. But when you're talking about production, right, the structural engineer doesn't care about my BIM model. They only care about center lines, data. That's all they care about. We worked with front on the Lusail Towers, and the Lusail Towers to do that facade in front are great. They needed particular things. They didn't need the entire model. So it's also about understanding what is the cleverest way of exchanging the minimum amount of data that produces the maximum effect. So you want to have impact at scale by minimizing the data you exchange, not maximizing it.
I think this is something that James and I talk about all the time is communication and asking those questions. What is it that you need to be effective? And if I can understand that, I'll probably save myself some time too, because I won't take everything and move it or generate everything. It's edge of slab. That is the most important thing. Okay.
Which has been funny working with Perkins&Will, because oftentimes we get these large bid packages that are actually more burdensome for us to interpret and understand. And really, I just want a surface. Just like send me the model, I'll interpret it in seconds, give you a cost. If you give me like a bunch of meshes and solids and things I have to interpret, it's likely going to be wrong. And it's going to be then lead to a higher price. And really, it's more work for you as well. So we can carve out time for the design teams by coordinating our efforts between each other.
But that's why if you're kind of building within the design ops kind of framework, you're building effectively the operational side of things and the development side of things into one holistic kind of journey. And therefore you start, by default, you have to ask these questions. By default, I have to understand what each person needs in order for this chain to work seamlessly. Otherwise, it's very easy to get stuck in your own silo, and architecture can be a silo and structural engineering can be a silo. And that helps nobody, because at the end of the day, I think all the parties want to create the most beautiful thing that is out there, the most performative one. It's a reflection of their work. And I don't think that anybody wants to kind of have these big fights in a design review, right? They all want the same thing. So if you put these things in place early on, and we are very, very lucky because we do R&D, but we do applied R&D. So a lot of our R&D kind of comes from the needs that we see in projects. So we work to solve problems in projects, and then we have, like, I'm very lucky because I'm basically shining in the light of my colleagues who are incredible, and they kind of solve these problems with me. And then they suddenly say, you know what, why don't we just do this? Why don't we generalize that? And also that it's an interesting problem in and of itself, because it's so easy to fall in the trap of, I've done this thing, it's so fantastic, you can't imagine. And actually it's useless. So many times we kind of create things that we think is the best thing after sliced bread, but we haven't done our proper product inquiry. And it's like a shitty thing nobody ever uses, right? Pardon my language. I've said worse. But effectively, at the end of the day, the moment you try to listen to what people need and you try to adjust little by little by little, some of these tools, as I told you, Cyclops started by my colleague Adam 15 years ago. Now Oscar has kind of completely put it out in the moon, but this change was gradual. It took 15 years to reach where it is.
But that communication gap, I think, is the whole problem. Like, you put a lot of energy in something that becomes useless because the people you expect to use it have different ideas, right? I mean, Nathan and I have tried a million things with our SurveyLink tool. In the field teams, some of them stick. Other ones are like, oh, that's annoying, get rid of that. And we thought it was going to be this, life-changing event that was going to make all of our problems go away. And so that communication back and forth between users, installers, people who are downstream participants who aren't typically part of the conversation.
If I may say, so though that's a problem of our own making, because in a room like this with so many talented people, modesty is really something that is lacking. So I think we need to be very introspective sometimes and trying to understand what it is that we're offering to others, not how we can say, oh, we've done this incredible thing, right? Because you can do a lot of incredible things that nobody really cares about.
Good point. Because that kind of, it also leads me into the next question, actually. In terms of, actually I have many questions, but in terms of, we're all building these tools as well, let's say, right? To connect, to interop, etc. all in-house, let's say. Should we actually work better together in terms of even sharing these tools? To Nick's point in the presentation, like, should we actually search for collaborations within the room with our competitors, with other consultants together, and actually build on that and push the industry forward as such?
Capitalism is a difficult thing.
Sorry?
Capitalism is a difficult thing when you're working on, anyway, you talk about.
It is hard. And I think it's about getting the right group of people. It can't be too many. That, the old saying, there's too many cooks in the kitchen, is totally true. And to your point earlier, what do people actually need? And it's usually simpler than we may think it is, and not go 10x, but only go 2x or 5x. And understanding that and then tackling the problem, and then looking for the feedback. Are they using it or not using it? So having these regular stops of, is it useful, not useful? What would be added or not added? And are we done? Or stop, go to the next thing, because it's actually so prescriptive for one particular client or one particular practice type that it won't scale to the rest of the firm or to all these other firms that are out there.
I mean, I totally agree with you. I think in the first place, what we're trying to do when we work on tools is to solve problems. So first, to get started, you need a real problem to solve, and then after that, you need to come up with something that people is actually able to interact with. And more often than not, I think the type of tools that were coming out of these groups were kind of tools that can only be used by specialists. And it's not until you look for that feedback, is when you realize that no one is using them. Why are they not using them? How do they interact? How do they think? What do they see on their screens? But I think it's crucial, and if that happens internally, I think to me, externally is even kind of a bigger problem, because internally, at least, I think you're certain that the problem you want to solve, may be familiar with you, and so I don't know. I think going back to kind of the first thing, the first point, I mentioned before is that, when are we bypassing someone, along the way? I think it's probably because naturally we try to communicate with the people that, kind of speaks for things alike. And that kind of in a way, makes the problem bigger, because we miss a lot of people along the way. So I think collaboration is key, but it's still a big, kind of gap there. And I think it's far to be solved.
Yeah, I think building tools for people probably in this room is way easier than, like you're saying, to the rest of the firm, or to scale it up where, UI and UX becomes so important, and what people will tolerate, and I do think that if the back end, we can start to make these decisions or use the machine learning algorithms to select the ranges for them, so they're not doing all these inputs, that's where it'll get way easier, and the tools will get better, and we'll be able to share them, or we'll see them develop equally, and someone will take this idea and build it into something else.
I mean, I want to clarify, I'm not against collaboration in general, but I feel that we keep talking about it, and it's a beautiful idea, but the realities of it are much more difficult. If you're doing a collaborative thing with everybody, you need to get buy-in from any board of any single company. You need to actually invest money in it, money that don't go towards your competitive advantage, but the kind of raising up of the entire industry to make these points, and to actually then, and even if everybody decides and everybody says, yes, we'll do it. All our companies come around, they say, yes, we're going to do it. Then it becomes this problem of like managing it amongst us. And there are some people who are fantastic and actually taking input, and there are some people, like the worst thing that you can do, and I was discussing this with David before, is making decision by committee. And that is a horrible place. You don't want to be in that place effectively, right? So is it good? Yes. Is it very, very difficult? Absolutely. At the end of the day, also somebody has to pay the bill. Who is that somebody?
I mean, I think some of it is scale. You're both coming from companies that are quite large. And so I think as larger you get, you have more resources, you can fund R&D projects that are bigger. Being small is kind of nice. And we build a lot of just side channels. Like we had a direct channel unofficially with Heatherwick throughout the entire Bayview project, where we just solved issues. We shared models, we got things done. If you went through that larger contractual and risk mitigation set of conversations, nothing happens. I mean, months go by and then things crash in the field and everybody's upset. So I feel like it's informal collaboration is what we need to dig in on here, and we need to share better. And we try and publish work as well, both in white papers and just blog posts, as a way of getting the word out there, and then setting up those informal conversations.
And also, before anybody thinks about it even more, I would suggest that they go talk to the NVIDIAs and the McNeils of this world of what it means to actually have a software out there that needs to be supported, needs to be troubleshooted, for which you have to identify yourself. And I'm only scratching the surface of the problem. So that's not because I'm pessimistic, which I am by default, but that's because I'm just trying to be a little bit realistic about where we are in this space. I think all of us, not just us.
But I think we also have the potential of changing, whatever software is happening outside our companies, so especially when you are not from a large company, so if you don't have the internal resources to actually develop, these tools yourself, you still have, at least the opportunity to actually beta test whatever is happening outside, and these kind of, let's say, instances like this one, for instance, are great, great opportunities to actually get your hands dirty and understand what things work, what things, may work, and what things definitely won't, and we can talk about, all the kind of large companies and big softwares that are being developed at the moment, while we're actually shaping them, it's good for them. It's business, it's good for us because it's useful, so I don't think it's necessarily always, about being kind of let's say, looking inwards, and I think collaboration in this way, I think it can be quite powerful.
Thank you. Any questions from the room, perhaps? Two right in front. We got some roving mics here, so let's wait for that in a second.
So, here you guys. Can you guys hear me out there? Okay, it's easier.
I'll repeat the question for the guys online, but
Yeah. So you said that you guys are not a software company. Yet I keep hearing you. Oh, you need to bring the customer as early as possible. Need to iterate. That sounds a lot like agile. I mean, are you so like switching from waterfall specifications, etc., into more of an agile process?
I had a slide like that, but I had to remove it because the presentation was late.
Yes. Waterfall is so 1990s. I mean, and the design industry doesn't work like that. So you have to go agile. So that's DevOps is agile, but design ops that has been kind of up and about in the last kind of 5 to 7 years. And that is where you want to be. You don't want to have like the development and the development operation systems together. You want to have the people and the experience of these kind of tools being integrated. And the problem was that UI designers were completely detached from that process up until kind of 5, 6 years ago. And now being part of the process creates that design ops kind of workflow that works for everybody and makes things easier. And that's exactly the example that we're following, at least within ARD, in how we want to develop these tools to make them directly available within the company, because we are internal consultants. At the end of the day, we are providing solutions, which are products and services.
Check. So having worked on projects where I've worked with fabricators and we had side conversations of delivering the model kind of under the table, and then they deliver the Excel spreadsheet under the table, and we could do, shop drawing reviews, like, overnight versus, taking a week and everything. Like, those are great, and they help build the strengths between the different firms and all that. But you made the comment about, let's not get into that contractual side of things, and because it is very ugly and very litigious. But at what point do we start to take these side conversations and bubble them up to a point that they become solidified so that we can remove half of these drawings and like all these hours behind like, a damn Revit screen to actually deliver that single surface or that centerline model or that spreadsheet or that CSV file that you need? Like, at what point can we break that barrier of just having side conversations?
I think Nick and I can answer this. We've tried to formalize it with Perkins&Will by creating a master service agreement where we're actually more or less a consultant to Perkins&Will. And that way we can share information easier. We don't have to go through NDAs every single time. It makes that smoother. I'm hoping it doesn't formalize it so much so that it then goes back in and gets churned up in the bigger machine. I don't think it will, especially with the way that we're working and the way that we're sharing data. So I think there is ways to formalize it. It's a much bigger conversation and a lot more people had to be involved in that than a quick model share or whatnot.
Yeah, I think some of it's incremental in terms of who's the team and who the client might be, and then showing the value that comes from that. So it can be, delivering the design intent, delivering earlier. It may not be cheaper, but earlier is better. So where do you see the value in that to let it be short-circuited? So it's always asking the question, how do we do this different? How do we do this better? It should never be cookie cutter from one project to the other.
On Bayview, there was an interesting relationship we had with Benson, who did all the glazing. We had no contractual tie to them, but for the betterment of the project, we realized that if we installed our parts on theirs on the ground, then we could remove a huge amount of labor from us having to go on the roof. The trade-off was we provided them positioning information via the survey I showed. And so I think in some ways just working earnestly for the betterment of the project, which is easier said than done. I slightly disagree because I do think there's quite a few people who can benefit through ambiguity and masking things and hiding things and change ordering their way into profitability. So I think we have to solve the earnestness problem and qualification of other subs and some minimal technical ability that you review early on might help do that, so that everybody is kind of joining and being a part of the same team.
But there is an accountability issue there, right? Because again, not all contractors are like you, and you're signing a contract, and that contract says that you need to deliver something. And if, let's say, I, from the kindness of my heart, send a model without checking anything else, and somebody takes that model and creates something from it, and the model was wrong, that accountability has not been transferred to the contractor. It's me who's responsible. So if things go horribly wrong, then I'm at the deep end of it. So I think a lot of these discussions are wider industry discussions that have to do with how is accountability transferred? Is it the blockchain thing that we need to look into, which can be sustainable because currently it isn't? What are the ways by which this can be made possible? Because currently it's really not with the majority of the contractors. Again, not everybody's like you. I think that's an important kind of differentiation there.
That is true. I think we like to work at the kind of edge of what's reasonable there. I mean, on the SoFi project, they delivered us, we presented 2 drawings, just 2 pages for the entire stadium cladding, because we had worked with HKS and figured out a way of exchanging data. But there was a lot of trust built in that. But we're not in the business of getting egg on the face of our customer either, which is HKS in that case, and making sure that the design was delivered as best as absolutely possible. So, I mean, if you want, I guess if you want to work in this business, and Zaner is a 120-year-old company and they're interested in building relationships and delivering, exceptional buildings, then it doesn't benefit us to be nefarious in that way. So I don't know, be nicer is the theme of like how to work better together, but.
It's a quick question. It was something that I think Martha and James also mentioned was, have you ever imagined a method of, let's say, every single subcontractor write down the 10 things or 20 things that they need to price the project, to build the project, and we just give it to them. We check the box. And the responsibility is clear of like when that thing gets exchanged. Because right now it's an interpretation, a deep interpretation, right, of thousands of drawings potentially. I think that'd be a lot easier. But let's just say that. For everybody.
But that's a project management problem there that you're describing right now, because I think from the contractor side, usually it's fine. And from the architect side, it's fine. And from the engineering side, it's fine. But whoever does the contract and the project manager, it's not fine for them. And I think that's why I'm saying actually, I find that for a lot of these changes to be enacted, it's not the people in this room that need to change. It's contractually how the industry works that needs to change. And therefore that's a different fight. And I'm not quite sure how we can fight that fight apart from like showing the right way of doing things and hoping for the best.
I think timing gets tricky there too, because if I participate later on and decisions have already been made, then my solution set gets narrower. And so that solution set field of moving conditions, everybody has their own optimal and it may not be shared. And so sequencing that information and getting it in the right timely manner, I think is also tricky. But yeah, it does come down to project organization, delivery method and strategy, whether the contractor's at risk or not. Like, so many of these things start to play. The locality changes a lot for us depending on, we're a union shop, so we have to deal with different labor rates in different places. So it gets very complicated when you start shifting between places.
So if I understand correctly, what I'm hearing is more data would be great, but there's obstacles to sharing that data to the contractors during the build process. Would remuneration or compensation to the architects benefit both parties? Like, it doesn't have to be out of the goodness and kindness of our heart. It can actually be something that could be that could provide more currency, more value, obviously, to the contractors, the people doing the building, but also something that the architects are getting paid for, so that increase their margins a bit. And then I think in this way, it's a win-win scenario. Like, we don't have to be afraid of capitalism, right?
Definitely not.
I don't know if I'm being naive here, but
no, I don't think so. The trouble we found is that we only do each project once, and so we don't have a good baseline to compare against and say that we delivered faster, right? I mean, even some of the survey information that I've used on projects, it's seen at the end of the project as a waste. Like, well, we didn't really need that, did we? Even though it was foundational to the successful delivery of it. So unless you build the exact same building twice, you don't have a baseline to compare against. And so therefore it's hard to argue that you did it better and then therefore deserve more money. Sometimes with schedules, we can do that if we can accelerate our schedule and get ahead of something. And that's a proven thing. Like at this date, if you can deliver these things, but everybody slides and schedules get murky and it gets really hard to say, look, we did our job, give us the money, but the project as a whole is behind. Does that make sense? So,
yeah, I was wondering about the second stage, though, another type of agreement above and beyond the delivery of the plan, saying, look, the architects are taking care of data and they're providing an additional service, perhaps. I'm looking for opportunities for them to make more money, actually.
I think it's from not doing more work and not doing the rework that comes with value engineering, where it's on our dime. If you have the information earlier and earlier, you can make those decisions about, I didn't know that this was a long lead item. Thanks, James. We're going to change that now instead of, within a week when we have to slash our design, or how panels are optimized for the least amount of material. That saves a ton of money. There are these small things that we can learn from the folks that actually fabricate and construct these things that will save so much time that we don't have people in the studio that have 30 years of experience doing CA. We don't have them. So you have to go to the folks that do know. And I think that's where the value is for us. And then, like I was talking about earlier, creates the time so that we can do these other things that are important or becoming more important around carbon calculations, operational carbon, embodied carbon, life cycle assessments, things like that, instead of redoing the facade design because we didn't know it was going to cost too much. Everyone wants zinc. That's my big joke. Everybody, oh, this is going to be zinc. No, it's not. But I didn't know that zinc is 3 times more expensive than aluminum. Okay, now I know.
It only comes in 1 meter sheets.
Yeah, all these things. I make a joke with James when we meet with the teams. Like, I give it 5 minutes before they say it's zinc.
But that also can be seen from a different perspective, because one thing is understanding how much your design costs, which obviously is important, but sometimes we also don't know how much we can actually spend, and so there is a level of clarity that sometimes we don't have when we start a project, or make change along the way as well, from the client side, that may affect this. So I don't think it's kind of a black and white, where there's one single solution, let's say, and so whatever the solution is, it needs to be quite flexible, and even when you're trying to kind of use your kind of past experience, So I think what happened very often to us is that because we work directly with the fabricators, sometimes we know how to do some of the things, and the fabricators definitely know how to do it, yet the main contractor may disagree, and so we team up usually, with the fabricator and actually with the client, to be on our side, to actually convince the main contractor about the change. So the bottleneck sometimes, is not on one or the other end, it's right in the middle,
Well, and the contractor is going to want to have multiple prices to make sure that they're competitive against one another. And so while you might have a solution from a fabricator, the other group may have a different tool or a different size of tool that blows up all your assumptions. So I think it is just a communication problem in so many ways, but it is a interdependent variable one, where you're kind of always chasing your tail a little bit.
Any final question, perhaps? If not, that's fine as well. Fascinating discussion, but let's grab a cup of coffee, I think. Thank you very much. So next session, we're going to have another roundtable discussion talking about vertical integration. So we're going to have Chris Diggins, Matthew Comber, Chris Sharples, and Clifton Arnes. feel free to come up front and pick a seat and a microphone. And we have our own Charlie Portelli moderating the discussion this afternoon. So Charlie's been with Core for quite a few years, coming from the architecture world before. And it's been one of our struggling with my words now. Vice President in our application development team, specifically looking at a lot of Constru lately. And today talking about the industry and vertical integration. Over to you, Charlie. Thank you.
Perfect. Thank you for the introduction. As Jeroen mentioned, my name is Charlie Portelli, Vice President, Application Developer, whatever that really means. I went to architecture school and somehow found my way here. When we first put this session together, we called it vertical integration. And then part of the way of organizing this, speaking with the speakers here, it kind of came to our attention that we weren't really thinking about the full picture, because vertical integration is just one dimension. So there's also this concept of this horizontal integration. And then during lunchtime, having yet an even deeper discussion with some other folks, it almost came to my mind that really it's not even vertical or horizontal, just those two, but it's actually different dimensions of integration as well. Having done some application development, both internally at a firm and kind of at an industry-wide level, integration is kind of the hard part of developing applications. So it kind of scales in a lot of different ways. So with that being said, we have four amazing individuals here. Christopher Diggins, he's head of research from VIM AEC. Matthew Comber, Vice President, Architecture and Engineering at Project Frog. Chris Sharples, co-founder of Assemble OSM, and Clifton Harness, CEO and co-founder of TestFit. So with that being said, the first question I want to pose out there is, what is this concept of vertical integration, horizontal integration? How do each of you define it, and how do each of you kind of find yourselves in this world of integration?
I guess I can kick that one off. And I like the way that you pose the question, how do each of us define it? Because I guarantee you the answer is going to be different for each of us up here and everyone else in this room. Project Frog, those who don't know us, we're a prefabricated structural core and shell kit components engineering and delivery company. I would call us multi-directionally integrated. We do simplify it to vertical and horizontal pretty often, but I like that sentiment. So, Frog, we started as architects, eventually incorporated engineering to design prefabricated, mostly wall panelized systems. We partner, actually, this is where our horizontal comes in. We partner with a national network of decentralized manufacturers to manufacture our kits. And then we are working on a similar partnership network with installers. So, we're going up and down the delivery chain from project conception and design to occupancy, and then spreading out horizontally in different areas along the way, as it makes the most strategic sense for us. So that's our definition, how we approach the vertical and horizontal aspects of integration in the physical building delivery process.
So when I had to study up on what vertical integration meant, at first I thought, well, what role does software have to play? And I realized, well, software is actually part of the supply chain for the design process. So as architects, you're consuming software. And it's very exciting to see that many of you are actually writing your own software. And one of the questions that's been kind of skirted around, and I believe one of the folks in the audience is asking it directly, is should we be selling the software or should we just be giving it away? And so there's kind of this open question is, could architects move into the software industry? And from what I'm seeing today, most definitely, yes, they could. But another question was brought up, another point was brought up about collaboration. And collaboration doesn't just mean two people are getting together for free. It means that there could be a mutually beneficial partnership. I think that there could be more consulting with professionals in the software industry and to say, well, let's work together. Let's figure out how we could productize what we're doing. Because, you know, as someone who's spent close to 40 years coding software, I don't know anything about your workflows, only at the most superficial level. But I guarantee you, you don't know as much about software and computers as I do. So working together, I think we could perhaps come up with something that would benefit the industry as a whole and would help you to be profitable. Because you know, Michael brought up a point. He's like, well, it's risky for us. We have thin profit margins. And if there's an opportunity to use something off the shelf, we will, because that might be too expensive. But I challenge you, do you know for sure that something's too expensive? Consult with people, work in partnership, and try to figure out, because I think there's a lot of opportunities here for architects to move into software and potentially software-based services as well. So that's my spiel on how I see vertical integration working for you folks.
Yeah, I sort of come at it from, 25 years ago when we founded Shop Architects. And there were two things I remember seeing. One was a show at the National Gallery of Renaissance Models. And you will, if you're familiar with Renaissance models, I like the dome of St. Peter, it's 25 feet in diameter. You walk inside and you know the stories of Brunelleschi having a model of the Duomo. And people didn't really look at drawings. They really looked at, these physical models, including the client. There's actually a great quote from Alberti says, if you really want to, I'm paraphrasing him, really want to understand, the whole scope of the project, models are the best way. He also says it's a good start in terms of costing out the project. And then, in 1995, there was a show on PBS on, 4-part miniseries on the whole development of the 777 by Boeing, all based on model-based delivery. And, sort of watching this, you saw the model as sort of the vertical element in terms of how it draws everybody together, from not only the design and engineering team, but to the fab team, to the customer, to the mechanics in the field. And that was a very powerful thing, for, me in a very disaggregated, siloed industry. So fast forward to 4 years ago when my brother and I founded Assembly OSM, which is a volumetric modular company that, develops, mid to high rise modular buildings. And we learned a lot from what not to do on our Dean Street project in Brooklyn next to the Barclays Arena. And so for us, it is sort of multiple sort of dimensions where the model is the platform and it's the single source of product data. Everything is captured in there, and it's an iterative model. It's organic. It's not fixed. Some of the things that Martha was talking about really rung true with some of the things that we're thinking about. But the key is you want to be able to open that to as many people as possible, not only the design team and the engineering team, but the open source supply chain. And that is sort of the horizontal relationship, whether it's in real estate, in design, in manufacturing, in post-occupancy, is understanding how that model can be consumed and understood by or acted on by many different people. So it is sort of these two worlds coming together and sort of growing this sort of volume of interaction. So that's sort of how I see it.
As a startup, you're looking for a niche to enter a market and then to grow from that niche. And when you can start with a niche like housing, it's a very much horizontal effort. So being the co-founder of TestFit for the last 5 years, growing this company, we started in multifamily, just automating basic architectural concept design. And I don't think that anyone is ready for vertical integration excellence until they have horizontal excellence. And you can build valuable things off of something that already exists. You can't just go up and say, hey, we're going to vertically integrate this whole process. And the reason why you can't just say and do it is because you don't understand what you don't understand. So you have to have excellence at one point, and then that enables you to then grow into other parts of the value chain. So for us at TestFit, where we're getting into vertical integration now is we've got the multifamily excellence, we've got industrial design excellence. Those are our two typologies in the design space. And we raised a significant amount of money to then invest into the verticalized play, which is there's pro formas and then there's pricing. Those are the two other documents that need to be done for any plan that we generate to be successful. So for us, it's more about verticalizing the different stakeholders into one software solution so that they can collaborate and get to a better answer faster.
Okay, so that was sort of the, how do you define it? But now the next question I want to ask is why? Why are you folks are looking at it? Is this something that this concept of integration, whether it's vertical or horizontal or maybe some other dimensional, why should we be looking at it? Why is it something that is pertinent to you that you've taken that step to make that change? And why should we, maybe follow in those footsteps?
Should I lead off again? Yeah. All right. So I want to tie that question back to kind of a theme that I've heard throughout the day here around the benefits that everyone in this room is striving for around collaboration. That comes in many forms. It can be achieved in many ways, but ultimately, the running theme I've heard in this room today is we all want to be working together, be it passing data back and forth, be it, standing up partnerships, whatever that means. We want to be communicating better, working better together to get out of all of our individual design silos that our industry has been built around for eons in order to ultimately deliver a better product for humanity. Okay. For us, by verticalizing, that means that we are bringing all of these traditionally siloed aspects of the building delivery process into one ecosystem, not necessarily one roof, one ecosystem where we are all working deeply, deeply together in order to start capturing a lot of the benefits, again, that we've been talking about all day. By doing that, not only does it allow us to leverage drastically different areas of expertise all across the delivery process, but it also allows us to start automating that delivery in ways that we haven't seen done before. So we build a lot of our own automation tools to get through the process that go all the way from, I've got my engineering team, we've got a building on X site, look at the geotech report, run the hazard analysis, and that data lives true all the way through to the installation of that building, right? So that data gets passed through the structural engineering process into the production models, into the fabrication facilities, and ultimately onto the job site for installation. So by verticalizing, we've been able to capture a lot of these benefits, and we've done so in a very, very niche market where we've seen a lot of need. And I'm excited to see, a lot of the concepts we're all talking about here start to expand into some adjacent markets.
Yeah, I would expand on what you were saying. I haven't been here all day, so I haven't heard, but it's great to hear that collaboration has been one of the words that's been spoken about throughout the day. It's like, relationship building is all about building trust. The other thing, I think I heard this last night at TT, was the word empathy. If you read, Adam Smith's first book on theory of moral sentiment, it's all about being in the marketplace and empathizing with your customers' wants and needs. And the thing is, we've got empathy through the whole chain, whether it's from the developer owner all the way through, the consultant team to the manufacturers to the people who end up taking care of the buildings. So it's really beginning to sort of open that up and start to understand what are those needs and defining what those are, and then ideation. It's really what the design thinking is all about. And I think it's definitely one of the things that is we're challenged with because our process is the wrong process. It's not about projects, it's not about products, it's really about process innovation. By changing process, we can affect behavior. And that's the biggest problem right now. We're all worried about our bottom line. And the margins, as I heard in the last panel, are very tight. And the fact is, we're providing a lot of value and we're managing, in a way, risk. And so the thing is, really having these conversations either with ownership or with your fabricators or with everybody within the value chain, this is how we can start to sort of collaborate and move forward. Again, it's a very, general abstract way of talking about it, but I do believe that changing the behavior through these processes of using these tools could have a big impact on how we can accelerate some of these changes.
So companies are only three things: people, products, and processes. I took a management class one time, and that's what the person said. It's relatively true, I think, if you do the kind of a thought exercise about it. Products and processes don't have empathy. Humans do. So in order to get to a place where at test fit, we could understand how to deploy Thornton Tomasetti's, structural AI from an API call, which is fancy for saying they coordinated in the cloud without a human present. It took 90 days of just coordination calls with that team for us to have enough empathy to understand what the structural engineers really needed. Our goal was, hey, instead of having coordination calls 6 times a year, let's have an AI do it right now, all the time, continuously. And therefore we can reduce risk. And, I think that's maybe an example of a vertical integration, but it did take that empathy for the products to arrive at a place where people could actually trust it.
So my personal story about what kind of drives me towards wanting to increase vertical integration, but in my context, which is I want to encourage more architects to take control of the software development process, is I feel it's kind of sad to hear that. I think it was Pablo who said, well, we're a small firm, we're going to have to wait and maybe we can knock more on the doors of the big software companies. But I look at the software, and I've been in the industry for a long time, and I've worked at these companies, and it's really frustrating that they are not really equipped to serve the needs of the users, of yourselves. They keep the data to themselves, and they're making oodles and oodles of money off of the data that you folks are creating. So there's an opportunity here, and I understand it's hard, and we look at some of the larger companies, we say, oh, well, they've got a big budget. But I think it was Nick who said, well, you know what? We assumed it would take 6 months. I said, I think we can do it in 3 weeks. And they did it. And that's been my approach to software development too. Everyone else would make an assumption. No, you can't do that. Only a company this size can do that. And I say, you know what? No, I disagree. We can increase software performance by 10x, and then we can be just a team of 3 people. And it's possible. You have to not be afraid to fail, as Martha says. It's just, follow the white rabbit. You are going to fail. You are going to fail again. But then you are going to have some amazing successes. And I find that so inspirational. And I wanted to, kind of encourage all of you to go out there and do it. But you will have to partner with people. Again, that's my message.
Piggybacking on that topic of the idea of failing, Chris and I, you and I were on a panel earlier this year in Chicago, and one of the questions that came up was failure, and that's kind of like shunned upon in many places. And I'm sure within this room, it's kind of okay, right? We won't be stabbed by it. But if you go back to leadership at the firm, like, what do you mean fail? No, we don't waste time. Every minute is billable. Every minute is accountable, right? How important is it that we actually discuss these failures and understand when it's okay to fail in order for us to actually be able to move forward?
I want to take this because I'm an expert in failure. It was interesting because I was involved in several hackathons at a previous employer, big company, starts with letter A. And it was really shocking how the best ideas of the hackathon weren't acted upon, because as soon as it got to leadership, they were like, all right, well, how are we going to guarantee success? I was like, it's impossible to innovate if you are managing risk. If you are, and this, I hate to say it, but I saw a lot of projects fail because they were too big to fail. They're like, you know what we're going to do? We're going to spend $10 million and we're going to hire 100 people. And then the project's guaranteed to fail. It's the small projects that you leave them that room to risk. The one other thing I'll say is really fascinating. The way to inspire innovation is to reward the innovators with the opportunity to do more innovation. Something to think about. I think I've lost a bit the question, but I just wanted to say, fail.
Yeah, I cannot overstress the importance of failure and allowing failure in a measured manner and learning from failure. Success just does not come without failure. Challenge me on that. I'd love to chat over a beer, but I firmly believe that success does not come without failure. Failure should be encouraged, again, in a measured manner. To coin or borrow a key phrase from the software world, failure is good, just fail fast and learn from it, right? That's the key. Don't keep, if you're up against a failure, admit defeat and learn the lessons and move on, and iterate from there. Anyone in the room who's been following Project Frog for our 16-year history probably knows very well Frog is very good at failure. We've done it a lot, and we've learned a lot, and we've made a lot of pivots over the years in every aspect of the business, from what our product offering is, to what the delivery model is, to what the right market fit is, and how we approach that market. And through that history, we've been able to really hone in on a really successful model that we're proud of today.
So I think as a person that grew up in America, you kind of idolize people that are successful, and we have a whole lot of cultural issues with failure, especially I think in the architecture world, where people that grew up in Chris's generation, do red lines all day. What is a red line? Failure. Every red line you write or every red line you correct, it's just something that was failed and needs to be fixed. Failure, I think, is the default state of the universe. And I don't think most people are comfortable with that. The fact that humans exist on this planet is because failure didn't happen once, right? So bring it back to TestFit. In 2020, we shipped a hotel tool to a market that had 4% occupancy. That was a huge failure of leadership on my behalf to understand or not understand what the hell I was doing. And then 9 months later, we shipped an office tool to a market that wasn't building new office. And then finally we got wise and we looked at what was actually being built, and it was housing and it was industrial, the two markets that in the commodity space were strong and still are strong. So I think if you find the right investors or the right people you put yourself around you, you can not fail at the sort of 10,000 foot level, but you need to fail at the 5 foot level a lot to understand what is actually meaningful. And what I mean by that is I did over 2,000 sales calls myself in the first 3 years of this company, and I had an 8% close rate. That is a lot of failure, and that will train this biological neural net, like how to do what you ought to do, and you start to intuit better decisions. So if you are discouraged because you failed, I'm sorry, you need to fail a whole lot more so that you can get better.
I second that. For me, failure was a very early part of my life because my brother and I are dyslexic. I didn't really start to learn how to read until 4th grade. There was nothing more depressing than going from the 4th grade down to the 2nd grade for reading class in the morning. Anyway, what I realized after a period of time getting some special education help was that, you know, I looked at things differently and I needed to create my own system. And then I went on to liberal arts and, you know, got a degree in fine arts and history and a minor in political science. And then I went to Columbia for graduate school. And I remember the list of stuff I was supposed to buy for graduate school. You know, the electric eraser, the Mayline, all this stuff, the rotoring pens. And I set up my desk. And I started, and you know, if you come into well, some of you may have been in the office this week and you see my desk, it's covered with things, documents, books, drawings, sketches. And the thing is, I couldn't keep even my desk clear. And my bar actually was the way I would clean my desk. My drawings were always filthy. And then I got an internship at Richard Meyer's office where I had to draw on Mylar with a rotary pen and nothing could be on my desk. So it wasn't working for me. Like I could draw a straight line without a Mayline. And I saw that Mayline as a ball and chain. And then when we all graduated and we're all working, I'm like doing all these 2D drawings. And the thing that I really excelled at was building models. And my brother, and we've been building models since we were 6. And I'm like, basically the system was failing me. The process was failing me. It was holding me up in terms of how I could design, how I could visualize things. And so, yeah, it took a while. And I agree, you know, Larry Page said, you know, if you're going to fail, fail fast. And the point is, you do need to fail in order to innovate. So the key is on every project, you should be trying to innovate something, not the whole goddamn project, just a little piece of the project. And you learn from that. The other thing that we did was we would have these little micro projects like the Carousel House or the Camera Obscura or Wave Cave. And they would be small enough that we could execute them in like a 3 or 4 month period. And it was the intelligence from those projects that would inform the bigger scale projects. But the key thing is do it quickly and recognize that things aren't working. Don't let it drag you down. And then, you know, the other thing is when you're the leader of your company, you have to really inspire this kind of thinking. It can't come from the bottom up. It eventually will if everybody on the floor understands that this is an important part of the spirit and growth of your practice.
So kind of, you know, continuing a little bit on that thread, we've seen a number of, you know, firms come into our industry and integrate, and they integrate at some, you know, exponential scale, you know, and we've had some, you know, charts that go off the slide and everything, and we've seen them belly flop, you know, as miserably as they may have done. How do we know, you know, because every time we integrate, right, we're theoretically stretching ourselves a little bit, right? We are still the one person or the one firm or so on and so forth, right? So at what point do we know that we've gone too far, or should we, or where is that point that we know we should stop to not stretch ourselves too thin, that we'll fail to a point where we can't come back?
Clifton made a comment a minute ago around you need to fail a whole bunch of times at the 5-foot level, not at the 10,000 foot level, right? You know, how do you eat an elephant? One bite at a time, right? Manageable growth, manageable pieces, one step at a time. You know, never take on any more risk than you are able to handle. You know, it requires a lot of vigilance and a lot of self-awareness around your risk profile, risk tolerance, and a lot of education around how that will change at every step you take on your verticalization path.
Yes, exactly. You have to ask. One of the challenges with creative people and innovative people is they're often told they're wrong and they can't do it. So if you have one of these people and you're like trying to encourage them, they're used to people telling them that their ideas are bad. So when their idea really is bad and it's failing and people are telling them so, they don't listen. They just keep going. So that's true for probably everyone in this room. We're all creative individuals. So what happens is you have to ask people and you have to evaluate yourself very critically. And it's tough because you're going to be, am I onto something brilliant or am I, failing fast? So you have to use metrics and you have to be very open to what other people are saying, especially the customers. Be prepared to pivot quickly and evaluate frequently.
Yeah, and sort of follow up on that, it's like, I don't like quote Warren Buffett a lot, but he did say, don't overextend yourself. 3 or 4 things on your plate is enough. And I think in our space, like, visualization is definitely part of it. Generative design is another. Understanding, how, we interface with the supply chain through, a model-based delivery process is definitely another one. And then, how do we deal with the real estate marketplace? And so those are sort of like the 4 categories. What encapsulates that is just doing quality design and producing something that really means something to the built environment. That's sort of like a given because we're all architects, and that's part of our spiritual calling. But in each one of those categories, you sort of focus on certain things that you feel are important for you to achieve success on the projects that you're doing at that moment. Because, it's an iterative process. Again, to sort of, Martha was sort of alluding to this. It's not, the model is an organic, open architecture that should, buildings should get better with time. They shouldn't sort of decay and fall apart. Well, unfortunately, that's what we're seeing with a lot of buildings. But quality, it's treating it like an aircraft is, you constantly update the infrastructure. And that's sort of where this is all going for us. There are things that tie into this then is like, ethical sourcing of materials in the supply chain, worker welfare. If you remember, there's certain very famous architects out there who said, this isn't our problem. So this is all tied to the whole issue of means and methods. Again, there's these big umbrellas that really we have to get back into, but then you target within your in your office, what are the things that are going to allow me to access and have some kind of impact? And the thing is, there's going to be short-term, mid-term, and long-term. And ideally, you like to capture that all within a 5-year period, which is basically how long it takes to do a, decent sized project.
That's one of my pet peeves is when I hear a designer lean on, oh, that's means and methods, let the contractor figure it out in the field. It's like, well, if you can't figure it out now, then you're setting up the contractor and therefore the project and therefore yourself for failure when things ultimately go wrong in the field. So yeah, that's a mindset that I highly discourage out of anyone in the industry. Understand how problems are solved when they are actually solved, be it in the field, in fabrication, whenever that is. We can't design for success until we understand how all of the challenges are solved end to end.
Are we still on the Katera question?
Was that obvious?
So it's okay. He was off mic when he said it.
Yeah. Buildings are the hardest things that humans endeavor to create. I mean, you might say like the space station or something, but those are like rocket scientists. Like normal people make buildings, right? And they're complicated and they're complex and they change people's cities, and people live in cities, and cities are things that they're attached to, an emotional attachment. So it doesn't shock me when, $2 billion just disappears. When you attack the problem of buildings with money, it's not going to go well. So we talked about empathy the other night. I seriously think there is a huge lack of empathy from the architecture community to the engineering community. There's a lack of empathy from the engineering community to the architecture community, and also to the development community. Developers don't understand what an STC rating is, or what an R value means, or what a U value is on a window, but they know that it's important. If they actually knew, they would be like, yes, I care about that a lot. Like, please make sure that it's not toasty when I want it to be cool in this room. But it takes education and it takes empathy for anything in this future that we want to build together to happen. And I think historically, architecture has just been kind of an industry without a whole lot of hope. Because buildings are so complex and hard to make, the contracts that we sign, things made, do not enable innovation to be something that is first and forefront on people's minds. And it's also a per project industry. If you were to sit down and say, hey, I'm gonna, in my career, or this was me, I sat down and I said, I want to do 20,000 units in my career as a developer. And that was in 2015. And I looked around and I saw, okay, there isn't a great process out there to achieve that. And even worse, the architects that I was managing would spend 2 weeks to draw a site plan that I was just going to throw away because I needed the numbers to be confirmed so I could tell a broker that we can't buy this site. So they didn't really understand why I needed what I needed from them. And that was frustrating too, because they're just wasting time. So, you know, in TestFit, I see a lot of like automation, but I see a lot of hope too, because it's automation that is controlled by people. It's not a black box that you ask, oh, magical AI, tell me what this thing needs to be. It's actually a collaborative effort. And so I hope there's more tools like that, I think, from the technology side. But at the same time, I hope that the leaders in the AECO world start to really shift the contracts in a direction of progress.
I'd also like to add that any verticalization strategy is only going to be successful with the right market fit. And if that strategy is tailored to a market objective. You know, we've seen the rise and fall of a lot of small and giant companies by trying to shoehorn a solution into a market that wasn't ready to receive it, or you know, they struggle finding the right market. You know, Chris and I are working in different markets, and you know, Shop Architects has a very different verticalization strategy than Project Frog because of that, because we understand the markets that we're in. We are laser focused on those markets, which again, Frog failure many times on that front, I'll admit it, okay. But through that failure, through those lessons, we've learned, nope, this is the market for our approach, and this is how we can tailor our verticalization strategy and our product approach to best fit the needs of this specific market. And that is where we are focused. We're going to learn this. We're going to figure it out. And then we're going to start taking baby steps into adjacent markets to apply slightly different variations of the strategy.
So, and I just want to, you know, so what you're hearing right now is what we're talking about within our own space, but they're not talking about this in the academies. It's you know, it's a really huge problem. You know, I taught a studio in 2018 up at Yale, and with Anna Dyson, and she created this fully immersive environment called Beam Lab. And I did all my desk crits in this space. I can't go back to regular desk crits anymore, because to have students surround you with their work on the wall, and each student would choreograph their projects the way they wanted to present it. You know, when I started going back to teach, PowerPoint was the thing. So you would sit there and you would look at the project and you go slide by slide and you say, could you go back 3 slides? But when you're in this fully immersive space, your senses, except for, necessarily smell, are pretty much being touched, and you are sensitive to so many different things. So this is where empathy really impacts you, especially when you're working on projects in other countries, and you see how people use things, how they make things. And so we need to take a lot of what I've been hearing in the last couple of hours and really bring it not only back to, the academy, but also to high school students and even grammar school students, because visualization and some of the things that we're talking about here really can accelerate this idea that, people can bring change. They can actually, have an impact and do things in a shorter period of time. But right now we're all sort of caught in this situation where we're just trying to affect the disaggregation that we have in our own industry. But we have to start getting that thought across to the people who are going to be coming into it, so they don't have to think they're going to be doing any red lines.
I want to take the opportunity to open up to the audience if there's any questions. No? Go for it. I think the microphone's in the seat in front of me.
I think, well, Matt and I met, I don't know, a long time ago at a steel conference. We were talking about body carbon, like 2012, that's how we connected. But maybe 4 years ago, we met out there, and you were just starting like some automation software development. And so maybe can you walk us at least what you can tell, where you started and where you are now?
Oh boy, that's a big question. So Project Frog it has now become a separate business unit within the organization. So we have an enterprise software. It's a Revit plugin that enables designers to curate and manage repeated designs across multiple projects that are fabricatable, if that's the objective, but really that are just repeatable and properly curated. So that is a piece of software that Frog has built within the physical building solutions space. We have written, organically all sorts of different types of plugins that impact our own very specific workflows, again, around our specific market, around our specific verticalization strategy and our specific delivery approach. And I mentioned it earlier, we will take data from the onset of a project, okay, and literally pass that data through all the way downstream to the job site. And it's through a series of things as simple as Excel spreadsheets to C# plugins and Revit, Python scripts, lots of Dynamo. But it's a homegrown suite that ultimately allows us to greatly reduce the risk of manual information transfer from one environment to another. Again, and that's what I mean when I say bringing everything into the same ecosystem.
So just follow-up question. So what is your typical cycle from design conception to map drawings, say?
Yeah, well, so the niche market that we have landed in is in decentralized distributed building programs across large geographic areas. Repeated buildings that are built again and again and again and again. Think freestanding retail, convenience stores, fast food, anything where we can stand up a product, not a project. We stand up a product. Our building is a product that is repeatedly deployed with minor variations, structural optimization, site to site to site to site. So once we have stood up a product line and the infrastructure to support that product line, which is a process, it takes a long time, but we've done it successfully many times over. So once we get a project in the door, I can have a staff of 2 turn out a stamped set of structural drawings ready for permit application in 4 hours. And in a period of 2 days, I have it on the shop floor in production if that needs to be the case. Thank you.
We have one question in the middle there.
Props to my team for that.
First of all, I'm just super impressed. I'm seeing co-founder, vice president, head of research. So it's really incredible. And that's part of my question too, is just how did you get to where you are today? What did you do? What was that? Yeah. How did you get to where you are today?
Well, that's fun. I quit my job. I was so frustrated writing software, and I was like, darn it, I could do so much better. I could do so much better than working on this 20-year-old software code base. And I just left and tried to develop my own software. And it's kind of a stubbornness thinking that I could do better, that we could do better. And just looking at, like, for me, it's a lot about computation. Like I look at how far computers have come in 20 years, and then seeing that software has barely, inched forward, and understanding why that is, because basically it's refactoring old software is really, really, really hard. At one point, you just have to start and design from scratch with the knowledge and the understanding of how computers are working. As a result of that, I found a partnership with Vim, and then eventually they're just like, oh, no, this is not a partnership. You're coming with us. And so I joined forces and became the head of research there. So it's kind of serendipity, but like I said, just because I was determined for something better.
Yeah, as I said earlier, I wasn't the only one who sort of came from a non-architecture background. A lot of the other, Greg was in finance and Corey was in business management. My twin brother was an architectural engineer out of Penn State, so he's probably the closest. But when we all got together, I remember we were around the kitchen table and we had two projects. We had this waterfront park in Greenport, which we had won a commission for, and a fashion showroom in Soho. And, we didn't have an agreement in place. We said, I remember Greg saying, well, let's see how it goes. If we stop having fun, we'll break up. We actually didn't have a partner agreement until 15 years later, because then we started realizing we had to be, adults here because we had staff. And then a year and a half ago, we created an ESOP. But one of the key things, I think, to how we grew the practice was listening to our talent in the office, and when they had things that they really thought were important, and not to sideline that. The other is because we didn't all come from this architecture background, we had all these other skill sets that we were able to bring into the practice. And, some of it was thrown right back in our face, because I remember, you're working with developers, you've sold out, but the conversations we have with really smart developers, it says, you want a successful project, it's about creating a great public realm, because you'll not only get the tourists, but you'll get everybody else in the neighborhood coming back to your place. And so we kept thinking about things that you normally wouldn't be thinking about. And some of the stuff that we're all talking about here is really infused the way that we sort of crafted Shop and then spun out other companies. One of them failed, Shop Construction failed. But we're looking good on assembly. And so the whole idea is it really is, and we also took our names off the door. It's just Shop, and that was another important thing. So it really is, at the end of the day, it's not one person. Of course, that's what the press wants to see. It's really about a collaborative of people coming together and how that collaborative reaches out to the whole group of people that we've been all talking about.
Yeah, absolutely agreed. I've learned, particularly through my time at Frog, that success is not achieved as in a silo. It has not succeeded at the individual, or it is not achieved at the individual level. It requires the right group of people always. So, I learned the importance of surrounding yourself with the right people, the right like-minded people, and the right, the properly diverse skill sets in those people, be them your bosses, your peers, your team members. Seek out the right people, and when you find them, good things really happen.
The funny quick answer is I was asked to draw manually just way too many parking garages. But the deeper answer really is that I grew up in a very conservative real estate development family, and I decided to go to the University of Texas at Austin School of Architecture, which is the exact opposite of a conservative development family. And for 5 years, I really struggled with why doesn't this group of people, like my professors, care about hitting the right metrics in a building, or following realistic constraints? Like, I would go do the crazy shop building, and then I'd be like, okay, can I make it what I want to make it now? Which would be a more realistic 3-letter acronym firm design, or so I was just frustrated because my dinner table conversations were, we need to provide housing for America's people. Why doesn't the architecture community want to play ball? And then you go to ProPrac, and there's grad students teaching us that know absolutely nothing about the real world, saying that the reason why we don't have housing is because real estate developers are greedy. That's not true at all. Yeah, they have to be greedy, because if they fail once, they're bankrupt. They lose their entire track record of making money. So for me, it was just seeing that disconnect and thinking okay, if I can move the needle a little bit by trying to get these two people to sort of play ball in the same sandbox, then maybe we can show a bit more empathy to one another.
Perfect. Please join me in thanking our panelists for a great discussion.
Thank you so much. Feels like that discussion is totally not finished, so let's continue that later on across the street. Final presentation of today, Robert Tani, CTO of Tomasetti and leader of Core Studio. Couple of final words.
Cheers. How do I get to?
We'll change it for you in a second. And that's the advance.
Okay.
As soon as it's up there.
All right, cool. So first of all, I think another big round of applause for our presenters and speakers. I think pretty amazing stuff, and a lot to talk about in the next session, which is across the street over a few beers. So I'm gonna do a 2-part presentation here after we go through some big thank yous, more big thank yous. And the presentation is called AECtech Graph and Self-Disruption. First, I'd like to thank our sponsors, our big sponsors here, TestFit, Bentley, and Autodesk for funding some of the events. We've sort of upped our game in terms of the number of things that we're doing. And so we've reached out to these people, and they were extremely generous to provide their support for these events. So thanks to TestFit, Bentley, and Autodesk for sure. These are the people and the firms that are involved with this event. So it's pretty impressive. It's like a who's who of what's happening in the world of technology and AEC. Which is why sort of that's, if people ask us, you know, how do you guys do your events? And it's just like, we ask really smart people to show up, and that's it, you know, and then sooner or later, and you know, I think you start to, you get a sense. I mean, every time we do these, there's like a trend that starts to appear, do these presentations in various formats. And I think we all learn from that, and we all sort of, you know, make our own trajectories of where we're going to take our next project or our next development or our next career path potentially. So I think this is like a really nice place to, you know, to see that and sort of absorb all the things that are going on. So again, a big thanks for these firms that have put their effort into this event. Huge thanks to Dave and Giselle. I mean, there is a ton of work. So Dave's been doing it for a couple of years, so he kind of knew what he was getting into. Giselle just started, and I was like, oh yeah, it's like just a couple hours a day, or, you know, it's like, you know, whatever, you know, it'll be nothing. But, you know, I feel like, you know, this, and Dave as well, it's like, there's a lot that goes into it, and there's a lot of pain and there's a lot of ups and downs, but when it comes to fruition, there's a lot that comes out of it. And I think that's what we do. That's why we do it. That's why we get so much effort and great work from these folks. So again, big thanks to Dave and Giselle. This is, by the way, this is like a 6-month effort. This is not like we wake up one day and say, we're going to do an event. No, we actually started thinking about it the day after this event essentially will happen. Big thanks to the team. We've grown over the years. I show this, you know, sort of when we started Core Studio, which is 2011, and I started my career at Thornton Tomasetti in 1995, which is sort of part of this story, I would say. The folks highlighted in red are the core AI team that works every day, but really all of our AI tools is a complete team effort. Everybody on this slide here has participated in those efforts, and which is why machine learning and AI is really hard. It takes a full team and a super diverse group of people and talent to pull this stuff through. So just getting onto this really quickly, I'm calling this an AECtech graph network. And I was sort of, in retrospect, thinking about, this is our 10th anniversary, by the way, of doing this. And I should also thank Tomasetti, by the way, that funds this thing. So, you know, that's, I shouldn't, you know, but the reason why, and you know, a lot of people, a lot of this story starts to happen. It's like, people ask me, why does Thornton Tomasetti, you know, keep sort of pushing the envelope and you know, growing this group? And the reality is, it's return on investment. We have been able to demonstrate that, you know, again, not what you're seeing today is very advanced tools, but when we started, it was just Grasshopper. We just did Grasshopper. We made projects better. We made clients happier. That's worth it. That alone is just worth doing. So if that's making your clients happier, that's winning you more projects, you got to do more. You know, it's not a specialty. It shouldn't be a specialty anymore. It should be just part of the process. So that's how it sort of started. And I'm going to just tell a little bit of, again, little retrospective of like why I think these events and actually, and this is also something I've been seeing over the pandemic, is that people have sort of pulled back their sort of personal touches with events or with people or with coming to the office or whatever it may be. And I don't think we're ever going to go back to the 100% office environment, but you need to know what you can get out of the people that you communicate with on a daily basis, and what you should be striving to get out of people. It's not about doing your work well necessarily, because I would argue if you do a really good job today and you do the same good job a year from now, well, should you get a raise for doing the same good job really well? No, you should be doing your multiple other jobs really well. So just to talk about the personal connection, I worked on JFK Terminal 1 in 1995, my first structural job. And the funny thing is, it's going to be demolished in a few years. So we're redesigning the new one. But the critical thing about that was that I worked with two really incredible engineers, probably the top two engineers that maybe two of three engineers that I've met in my entire career. Paul Liu, both of these folks unfortunately have passed away. Paul Liu was worked on the Crystal Valley Curtain, worked on a paper bridge. He was always doing something really, really complex. But he would sit in his office and with the yellow pad and simplify the most complex problem on his yellow pad and draw it in front of me. And I was like, damn, why structural engineering is so simple, you know? And then he was also, I think this is 1995, we were still doing Mylar and hand drawings. Paul was doing 3D AutoCAD, drawing details for Terminal 1 in 3D AutoCAD. And I was like, why the hell is he doing 3D AutoCAD, right? I barely knew CAD. I didn't know CAD actually in 1995. So that was also something. I was like, why is this guy doing this crazy 3D AutoCAD? You know, I didn't come to like realize until like 5 years later, but you know, it was something that I took away from that. And of course, Lee Petrella was the master detailer. Lee can explain how to put something together better than I've ever seen anybody do. So back in the day, shop drawings were actually done by hand. So the shop drawings were actually drawn by hand on Mylar and we would get blueprints. And the fabricator for that project was a company called Canron, steel fabricator. The stuff that Lee worked on, there was never a question. They just copied what he did. And so I took that away too, because it was like, most engineers would not go to that level of detail to demonstrate the project. They would give the sort of the guideline of that project and let the contractor figure it out. Lee was not that guy. Lee would show every single thing. And so again, I kind of walked away from that, like detailing is the shit, right? I got to know how to detail. So, you know, that sort of led me to like where I am now, you know, special structures guy. I used to lead special structure at Thornton Tomasetti, computational design. I'll get to that in a little bit, and detailing. And that kind of led to Core Studio, to be honest. So I want to talk about this event, and actually owner Jeroen actually teed it up a little. In 2007, I had left ETA, went to Arab, and I was part of Sione, the publications committee. And I kept hearing about computational geometry, computational design. I was like, what the hell is that? So I said, I should, and Matt Clark, who's here, I think here today, I believe, was doing some of that general component stuff in the office as well. I still didn't know much about it, but I figured we should do something. We should have a presentation about that, like just exposed to the community. And we had, I can barely read it on the screen here, but we had Neil Katz and Kat Park from SOM, Matt Clark and Dave Farnsworth from Arab, Ian Keogh and Heish Laboro from Gerhappold, Owen Ragoon, who was at KPF, and Steve Sanderson from Shop. It was actually Steve, it was Federico Negro, it was Dave Fano, and it was Josh Amig. So that's like an all-star list of technologists in the industry. So, you know, the things that I saw was just like phenomenal. I said, I'm like a dinosaur, right? I'm drawing AutoCAD straight lines. Maybe I was doing Revit at the time. But, you know, Owen Ragoon was showing curvy stuff. It was all parametric, and it was just like way beyond what I thought the standard of care was in the industry. And that sort of catapulted me like, I got to do something more. I just got to do something. So, and then you could see sort of how it has moved on, right? So Ian was up here, Happold. He created this app. He was doing Dynamo actually then. He was doing Dynamo scripting, playing around the Revit API back in 2007. So he basically is the primary inventor of Dynamo. He's now at Hypar. And then I think it was 2014 at AECtech. Andrew was there. A lot of people there that are here were there. I think they might have been on the same team. I don't remember. What were you? So Andrew was here today. You know, there's a connection. There was like these graph connections of people and technology and inspiration that has come from these events. And I think that's why we do it. That's why I'm so passionate about doing it. And that's why I think people should do it. Go as many events as you possibly can. So, and then I would say, in terms of the hackathon, that has been like a huge inspiration as well.
The reason why we did this, the hackathon in 2013, I sent 4 or 5 people to, I think it was the first AEC, it was called AEC Hackathon. It still does it, I think, based out of Seattle. And our guys went there and learned something called the web development. And their hackathon was to move a single point from the desktop, spin it up to the web, and the point moved from, one point to that point. That was it. They came back so jacked, so excited. I was like, I don't know what they're feeding out there, but whatever it is, we gotta have some of that food, right? So we started our own, that's when we started our own hackathon. And so many ideas have been spun out of the hackathon. Mustafa had a hack called Pollinator, I think it was called. Pollinator became Design Explorer after I met him at the hackathon and hired him like a year later, right? That was it. Chris Mackey, I think because Mustafa was at TT, he came to TT as an intern. I think because Mustafa and Chris were at TT, Mingo came to TT. So there was all these connections of AECtech being at the center of this. And that has spurred like all these ideas, from a 2-day event. So there's no replacement for that, Rhino Compute. I remember going to Seattle to meet up with the Rhino folks, and Steve Baer was out there. I was like, I got something called something like a headless Rhino. I'm like, what? This was 2018 or something, I forget. And I had Sergey and I had Dave and I think Emil was there, and light bulbs started to go off. So at that hackathon, those guys worked on something called Rest Hopper. Rest Hopper is a remote compute. We spun out our own thing called Swarm, and then because of that, we actually merged with Shapediver. So Shapediver is here as well. So, and I would say we also met Shimizu. So I think in 2017, maybe Shimizu and the Algorithm Design Lab. So Satake and Tamako are here as well today. We met them, and then they said, we want to do things like Core Studio. So, okay, whatever, right? And we decided, they decided, I should say, to hire Construe to integrate a very popular Japanese software called Snap. And we're at the final stages of that. That's going to be released as a beta pretty soon. So again, these things would not have happened if it wasn't for this event. And Dave talked about sort of what we learned over the years about some of our web apps, and now we have Ellipse. So I think, after thinking about it, these are the things that we want to achieve from these events. And I have some quotes from Peter Drucker, maybe this old school project management, that's what I learned, no one's going to sort of feed you, your career. You have to go and get that career yourself. And it's coming to these events, it's talking to people, it's getting uncomfortable potentially, it's failing potentially, but you need to take that risk, or else, no one's going to give that to you. But the sort of outcome of that, you can see from even from the people on that list, is pretty amazing, right? They are the leaders of the industry in this tech world. So the other thing I want to talk about was what I call self-disruption. I don't want to go too much, but there's a lot of challenges in this industry. And not to get into every single one, because I can talk about 2 hours about this. I say Gen Z, people are laughing about Gen Z, it's true. So I'm Gen X, I'm almost boomer, like, okay, boomer, right? But people in Gen Z are not going to have the same, they're not going to do what the boomers did. They're not going to do it. They grew up in the world of gaming and automation, and they're not going to do 1,000 shop drawings to learn, to master that craft. They want to do it like they're playing a game engine. So that's a real issue. There is a huge dichotomy between who are running the company and who's actually coming up in the industry. So that is a challenge. I had talked about this in another event, and this was something that came to me recently, that this is where we are. I would say, Revit and things like that came around 2004, whatever, Grasshopper 2010 and 2011, but we never fully got to and things just got harder after that. And so we're at a point, an inflection point, where we have the means to actually leverage all of the tech that's been built over the many years. And I would also argue if you don't do it, your company may die. It may just, or be completely flat. I don't want to get into this too much, but we have so much tech out there. If we are not careful, we will become the world's slowest robots, clicking buttons all day instead of delivering the right information when we need to. And there is a real risk, right? And I'm going to go back to the food analogy. Clifton Harness at Test Fit is going to eat your breakfast. He's going to do SD for you. There is a risk that the traditional architect will walk to a client one day and the client will tell them, you see the Test Fit design? Make it CDs. That's it. You won't have the opportunity to deal with the whole design exploration because you're inefficient at it. We saw the Suffolk folks doing early design things. This is a traditional construction management company creating an early design app. So they're seeing the inefficiencies from the design community and solving it. Project Frog, you heard Matt, I mean, within 4 days, he's got a CDs like sitting, a fabrication drawing sitting ready for 4 hours. There you go, right? And again, these are sort of very niche sort of problems, but those things grow. Those things can expand. They've got the pattern, they got the process ready. Assembly is doing the same thing. And in many ways, I would, Chris would probably say the same thing. In many ways, they're disrupting themselves. And that's what my job is as well, is to disrupt ourselves. But that's the only that we're going to sort of keep ahead as a consultant, that is, of the rest of the tech industry. So that is the sort of conventional architect if they don't do it, but the opportunity is there, I would say. So how do you do that? Well, Michael talked about it as well. A lot of, Pablo talked about it. Martha's doing it already. Is like, you need to sort of figure out what those automations within those various stages of design can be automated so that you can do the more important things or just do it faster. I just want to, so this is an article that came out with recently, actually, from Harvard Business Review. And, I would say this graph is a little janky. Whoever wrote this graph probably doesn't understand business, because if any company in this room went to a minus 20% profit margin, they'd be out of business like 5%, right? But I would argue that the journey of doing machine learning is pretty accurate. So that blue line that you see, we're in that journey. And we spent a ton of money getting to the point where we are now, but we are at that point where we think that we're gonna go up. And when Dan was here, we started in 2015, that journey. Those apps were great there was a lot of marketing that came out of it. There was a lot of discovery, there's a lot of failure, but we're at a point where we're actually start leveraging that. So you guys have heard it, AI. I think of AI as a new Excel. You'll never go back once you can figure it out. Domain expertise, mine data sets, and synthetic data sets. And this is sort of our process. These are the models that we've created so far. And we think it's going to be like a recipe of models that we can plug into our apps. And this is, I'm going to show you 3 apps that we have used this process using Cortex, which is our sort of platform for deploying models, storing and deploying models for a steel, concrete, and timber building. Big thanks to the team, because we sort of all hands on deck put this recipe together for these particular buildings. In this case, we're doing, the tonnage, the typical tonnage, the weights, the embodied carbon, and we could do cost if we had those metrics. This is a SDDD type of thing. I don't see this as being a CD type of thing, but the fact that we can do things in seconds versus weeks is significant. This is a concrete building. And this is only the beginning, to be honest. We're gonna keep creating these models, improving the models, having various flavors of these models. And so kind of to Martha's point, this is never going to end. I mean, this is actually just this is going to keep going. It's never going to be 100% correct, but if we can get to the 80, 90% correct, it is a game changer, particularly for a structural engineer. So this is a timber building using those individual apps that Sila and Omid had shown. So this is where we are. I sat here last year and said that our goal is to do DD in one day. We're really, really close. And I think our challenge for next year is going to be the adoption part, is to make the engineers comfortable with the technology. So, which we heard a lot about that today. So that's my challenge for next year: build better models and get the sort of change the behavior and the culture of the firm so that they can get comfortable with this. Thank you.